Hey everyone, I welcome you all to this DevOps full course by Simplilearn. In this complete course, we will learn everything that we need to know to excel in DevOps. We have Matthews, Chidanand and Anuj to guide us through this journey. We shall begin with having a basic understanding of DevOps with a short animated video. After that, we shall dive deeper and understand what DevOps is all about. We shall see what is its relevance in the present scenario. We shall learn different tools in our learning journey. The tools that we shall see are Git, Gradle, Maven, Selenium, Docker, Chef, Ansible, Puppet, Nagios, and Jenkins. After we have a fair amount of knowledge regarding DevOps and DevOps tools, we will look at the interview questions that will increase our chances to crack any DevOps interview. So before we begin, make sure you have subscribed to our YouTube channel and don't forget to click on the bell icon so you never miss an update from Simplilearn. Now without any further ado, let's begin with our animated introduction.
Meet Tim. Tim builds a robot in his lab, a climate-controlled and pollution-free environment. Once he's done, he drops the robot off at his project partner, Mia's house. Mia takes it out to her backyard to ensure that the robot meets the requirements. But here is where the problem arises. The change in the environment causes the robot to malfunction. Mia is now really annoyed and she has a lot to correct. And it seems to her as though Tim didn't really do much. This wall between them leaves the poor robot to bite the dust. Well, what if we broke this wall? Tim and Mia now work together in a common space. Tim develops each block of functionality of the robot, which is then immediately checked by Mia. Both are now working simultaneously instead of waiting on the other to finish their task. As and when a feature is ready for use, they are put together to build the final product. They develop a common mindset and share ideas. To further speed up the process, they use several tools which can automate every stage. This means that the robot is now ready sooner, with less iterations and manual work. From an organization perspective, Tim would be the developer, while Mia, the operations. Their union is the core of the DevOps approach. DevOps has several stages and set of tools to automate each of these stages. Let's have a look at these. Tim first puts down a plan. In terms of software, this could mean deciding on the modules and the algorithms to use. Once he has the plan, he now codes the plan. With tools such as Git, Tim has a repository for storing all the codes and their different versions. This is called version control. Next, this code is fetched and made executable. This is the build stage. Tools such as Gradle and Maven will sort this out. Now before deployment, the product is tested to catch any bugs. The most popular tool automating testing is Selenium. Once the products are tested, Mia must deploy it. The deployed product is then continuously configured to the desired state. Ansible, Puppet and Docker are some of the most common tools used that automate these stages. Now, every product is continuously monitored in its working environment. Nagios is one such tool that automates this phase, and the feedback is fed back to the planning stage. And finally, we have the core of the DevOps lifecycle, the integration stage. Tools such as Jenkins is responsible for sending the code for build and test. If the code passes the tests, it's further sent for deployment. This is called continuous integration. Let's now have a look at an organization that has adopted the DevOps approach. Which of the below sequence of steps would they follow to develop a software? Leave your answers in the comment section. Keep an eye out for the right answer on the comment section or our YouTube community. Giants such as Amazon, Netflix, Target, Etsy, and Walmart have all adopted DevOps and seen a considerable increase in delivery and quality. In 2014, an hour of downtime for Netflix would cost it $200,000. It became absolutely crucial that Netflix prepared themselves for any sort of failure. And so, They took to the DevOps approach and implemented it in the most unique way. They developed a tool called the Simian Army. This tool created failures and automatically deployed them in an environment that did not affect the users. The team would troubleshoot these failures, and this gave them enough experience to deal with any degree of collapse. With everything being automated and happening simultaneously, organizations can now deliver at a much faster pace. So, considering the benefits of DevOps and its divergence from the traditional methods, would DevOps be the future?
What do you think helped Netflix evolve from shipping DVDs to streaming video over the web? Or helped Amazon to predict how much equipment to buy to meet traffic demands? How do you think NASA was able to analyze data from the Mars rover Curiosity? What would have made it possible for Walmart to become the king of the big box retailers and help Facebook refresh its mobile app so rapidly? The answer to all these questions is DevOps. The DevOps market generated $3.36 billion in 2017 and is expected to generate $9.4 billion by 2023. DevOps is helping many organizations to automate their entire process. The process allows any organization to create and improve their products at a faster pace than traditional models. So now let's understand, what is DevOps? DevOps, as the name suggests, is a combination of two practices. Dev refers to development, and Ops refers to operations. DevOps is not a workflow, but a culture that brings these two teams together. The development team writes codes for new products, security updates, and bug fixes. The operations team looks after the servers and makes sure that the deployments happen more reliably and frequently. The main focus of DevOps is on integrating these two teams in order to improve collaboration and increase productivity by automating the entire process of software development. DevOps has several stages and tools to ensure that all this process is implemented in the best possible manner. Let us have a look at all these stages with the tools that play a significant role in that phase. Beginning with the development phase. So the first step is to put down a plan that includes the modules and the algorithms to be used in the software. And once the plan is finalized, it is developed with tools like Git, as Git helps in storing all the codes and different versions of those codes. This is called the version control system. Now, this code is fetched and made executable in the next stage, that is the build phase. This phase uses tools like Gradle and Maven. After the code is made executable, it is supposed to be tested. The next stage tests the code for any bugs, and the most popular tool used in this phase is Selenium. Once the testing is done, deployment comes into consideration, and this is where the work of the operations team begins. In the deployment phase, the product is deployed, and this deployed product is continuously configured to the desired state. The tools that automate these phases are Ansible, Puppet, and Docker. The product from here is continuously monitored for any failures, and the most common tool that makes it possible is Nagios. The feedback of all the monitoring is sent back to the planning phase. This process is repeated in continuous cycles until we reach a satisfactory result. This completes the entire DevOps cycle, the process of automation from the planning phase to the monitoring phase. This is what is referred to as the core of DevOps lifecycle, the integration phase. Jenkins, another DevOps tool, is known for sending the code for build and test, and if this code passes the test, it is further deployed and monitored. Let us have a look at some features that are making industries move toward DevOps. Increase customer satisfaction, improve response time, fewer chances of implementation failure, reduction in IT cost, better business agility, higher employee productivity and satisfaction, faster delivery, better release control, frequent software releases, better collaboration among teams, automated server configuration. Now, when you know so much about DevOps, you must be curious to know what the future of DevOps holds. It is quite evident that DevOps is on the rise, and it's going to have a long way ahead. There are several fields that DevOps is going to be explored in the near future. Every organization has started leaning toward automation, so DevOps is going to play a major role in new upcoming organizations. When everything moves toward automation, there will be a need for DevOps in the security field. DevOps framework in AI and ML will help the DevOps team to focus on innovation and creativity by enabling them to manage the amount and speed of data in a more efficient way. DevOps focuses on infrastructure as code, which ensures continuity as all the processes from building to staging are configured automatically with no place for human error. The future of DevOps will make the culture more popular. There is no industry that does not want to shift toward more reliability in deployment. Every organization wishes to deliver their product in shorter durations and reduce the gap between its development team and operations team. All these scenarios will take DevOps to new heights in the near future. There are organizations that have shifted toward DevOps, and many are planning to do the same. Hence, the jobs in the market for DevOps engineers are certainly going to rise in the near future. So, when are you planning to master DevOps? You can begin today with Simplilearn's DevOps Certification Training course. Thank you for watching, and stay tuned to Simplilearn.
We're going to go through what we need to be able to do to go to DevOps, what the arguments are and why you need to do DevOps. And then we'll actually go through all the individual tools you need to be able to successfully implement DevOps within your organization. In addition to that, we're also going to take time and go through each of those tools so you get a good understanding of a step-by-step instructions on how to do basic setup of each of those tools. So let's get started. So what was DevOps before? So what was the process that we took for doing delivery before DevOps? Well, it was a model called waterfall, and waterfall was a very traditional approach to actually building out solutions. And the reason why it's called waterfall is that you break out all the individual requirements and individual sections of a project, and they cascade off each other. So if we look at the breakdown, we have requirements design, we have implementation, we have verification, we have maintenance, you'll have user acceptance testing, and this is all based on the software development lifecycle model, or SDLC, and it's been around for quite some time and is still used by a lot of companies today. The challenge you had with the waterfall model is that it really is a very long, drawn out model for actually building and delivering solutions. So it took a very long time to actually write code and then deploy the code. It was very difficult to actually identify problems within the code and provide feedback to the development team on what to fix. And this really was a very time consuming. We're talking about months, sometimes years, for projects to actually go through a waterfall model process. So along came a new method of being able to do delivery, and it's called Agile. And the Agile approach is a way of being able to take the actual work that's done in a waterfall model and compress it down into small iterations. And what we would do is a fundamental change is that you would actually take teams that were disparate and as part of the individual cascades within a waterfall project, and you actually bring them together. So you have your requirements team person, design, developer, and release management team all together in one group working on an iteration. The great thing about Agile is that you took a process that was weeks or months or even years in length, as it was with Waterfall, and you reduce it down to 2 or 4 week sprints, depending on the cadence for your team. Typically, you have a 2-week sprint, and then the goal is that at the end of each sprint, or sometimes every other sprint, you would do a software release, and so that customers were getting the software much faster. The problem that we still ran into though with Agile is fundamentally similar to what we were having with Waterfall. You have your DevOps person working on code on their system and it'd be working great on their computer, and then you have the operations person who's migrating the code from the developer's environment, the test environment, to the production environment. And you would run into issues where the code simply wasn't working. And there's a lot of reasons why that would happen. The actual developer environment would often be very different or would have different dependencies in it. So the hardware, the software, there may be additional applications that were installed on the operating system that simply hadn't been transferred over to the operations environment. And so what you would have is a disconnect between the developer environment and the operations environment, making it difficult to actually roll out code. So you'd run into a program where when you rolled out code, you'd have to have a rollback plan in case the code wouldn't work in production. And so each release became an event where everybody got very stressed about the actual event of releasing code because you didn't know whether it was going to work. So DevOps really looks to address and solve a lot of these problems. So the key word that you'll often hear with DevOps is continuous integration. And what that means is essentially that as a developer is working on their code is constantly being tested against not just the actual code itself with unit testing, but the environment with which it's going to be released in. And the goal from a DevOps model is that the breakdown of communication that happens with Waterfall and Agile, where developers and operations teams aren't working in the same environment, is being removed. And you're able to provide a continuous and contiguous environment between the developer and the actual operating model. So the reality is when the developer is working on their code, they're actually working in an environment that is identical to the production environment. And so when the actual operations person comes to actually do releases for the code, and you can see some teams are doing as many as 20 to even up to 50 releases to production environments every single day, you're able to guarantee that the actual code itself will work, and releases go from being a stressful event to a byproduct of good testing and good setup and structure for how you actually build out your solutions. So what we're seeing here, so the goal is that as a developer and as an operations person, that the code is working continuously in both environments. You have continuous integration and continuous delivery. So simply put, what we're able to do is we're able to eliminate the problem of the operation environment not being in sync with the development environment. And this is an improvement on Agile. And this is not to say that Waterfall or Agile are wrong as delivery models. What it is just a maturity of the ability to deliver solutions. And DevOps is just another rung in that maturity curve, using tools that are available to us now that 5-10 years ago simply weren't available. So the goal is for you as a team to move to a DevOps model where you can implement continuous releases on your software as long as you're using the tools that are available. And the good news is those tools are open source tools. So let's go through some of the benefits of why you'd want to go and use DevOps. So, essentially, what's in it for you? So over the next few slides, we're going to go through what is DevOps. We're going to go through the benefits of DevOps. So in the last few slides, you've actually seen, what is DevOps and the benefits of DevOps along with the life cycle. But we're also going to start digging into the tools that you have that are useful for DevOps. And we're going to focus in on 7 tools that can provide an end-to-end infrastructure for delivering DevOps solutions. There are significantly more tools available on the market, but these are 7 of the most popular for each of their categories. So DevOps really is an essential collaboration between the development team and the operations team. These are teams that have in past been somewhat at conflict with each other, and what you have now is an opportunity where those teams can now work continuously with each other. The expectation with DevOps is that it will continue to mature. Indeed, you're actually even seeing some groups which are now called DevSecOps, where they're integrating security as part of the delivery between the development team and the operations team. The bottom line is a DevOps engineer is highly in demand. The demand for a DevOps engineer is literally going through the roof, with salaries going up exponentially around that. So let's dig into some of the benefits of DevOps. It's not just a new catchphrase, it's actually got significant value and how you can speed up delivery of your software. So the benefits of DevOps can really be broken up into a number of key areas. First of all, we have continuous delivery of software, which allows you to continuously release new features with the security and understanding that the software going out is of high quality. It allows the teams that are working on the software delivery within your organization to more effectively collaborate with each other so that you're all talking from the same page and understanding of what needs to be delivered. The deployment process itself moves from being an event where there's a lot of stress and there's a lot of contingency plans to being a much easier deployment. The efficiency within the actual code that you're writing and the ability to scale up using the different tools that are available allows you to be able to bring in and scale up and reduce the teams you have running the software as needed. Errors can be fixed much earlier and more quickly and can be caught before anything gets pushed out to the production environment. And fundamentally, what we're looking for is improving the security of the actual releases. So the actual concept of security is center to all the work you're doing. And then finally, what really allows you to reduce the number of errors is that there is much less manual intervention. There is a greater reliance on scripted environments that you can actually test and validate for their security, reliability, and uptime efficiency. So let's talk a little bit about the life cycle of a DevOps. So the very first step that you'll take is to actually build out a build and test environment. And this is a continuous build and test environment. And this is managed with the first step of your source code. Once you move through that, then you're looking at continuous integration, which means that every time somebody checks in their code, they're validating that the code actually can run in the production environment. Once you've actually then passed the continuous integration and the testing that you have with your code, you're looking at continuous deployment. If the code works and is available to be released into the production environment, let's go ahead and release it. And once you actually have release code, then you want to be able to validate that your environment is working efficiently. You may release code that is a new feature within your application, and customers may then gravitate immediately to that new feature. If they do, you want to be able to ensure that the code is working and, more importantly, that the infrastructure is there to support. And then finally, you're looking at software released as a continuous event. And then you go back to the beginning. You start working on more code. You run it through your build environment and continuous integration, deployment, continuous monitoring, and keep that cycle moving. So let's dig into the tools that you as a DevOps engineer would need to learn. If we break down the environment that we have, all the way from source code management to software release, there are a number of key tools that you want to be able to use. So for instance, source code management, Git is an open source tool that you would want to use for managing your code. The continuous build and test environment will be managed with Maven and Selenium. Integration with the environments that you're working on is managed through Jenkins. The actual deployment to your production environments would be managed with products such as Ansible and Docker. And then the monitoring of your network would be used with tools like Nagios. The thing that you have to remember with all these tools is that they're open source tools. There is no licensing that you have to purchase. Some of the tools will have pro level licensing that you can choose to select. But to get started, all of these are open source tools you can actually start using for free right now.
So we'll start by downloading and installing Git on our system. We'll then have a look at the Git bash interface. We'll type in some basic Git commands. Next, we'll create a local repository. That is, we'll create a repository on our local machine. We'll then connect to a remote repository. And finally, we'll push the file onto GitHub. First things first, we need to download and install Git. So download Git for Windows. And I'll select the second link. So 2.19.1, which is the most latest version of Git, that's the one we want for Windows system. Choose your version. So mine is a 64-bit system and it's downloading. So this will take a while. So Git is finally downloaded. Now we need to install this on our system. Click here, run. So go to next. We don't have to change this path. Just click on in quick launch and on desktop. Next, next, again next. Nothing to change here either. And install. So now Git is getting installed on our system. So we don't need to view the release notes. We just want to launch the Git bash. So let's just tick that and then click on finish. And your Git bash interface appears here. So we are on the master branch. The first thing we do is we'll check the version for our Git. So the command is git -- version. And as you can see, version 2.19.1 on our Windows system, which is exactly what we just downloaded. We'll now explore the help command. So let's just type git help config. So config is another command. And as I hit enter, the manual page for the second command opened up, which is config. So what help command does is that it provides the manual or the help page for the command just following it. So in case you have any doubts regarding how a command is used, what a command is used for, or the various syntax of the command, you can always use the help command. Now there's another syntax for using the help command itself, which is git config -- help. Enter. This does the exact same thing, as you can see. Now that we looked at the help command, let's begin by creating a local directory. So mkdir test. Now test is my new directory. I'll move into this directory. So cd test. Great. So now that we are inside our test directory, let's initialize this directory. So git init is the command for initializing the directory. And as you can see the path here, this is the local path where a directory is created. So I'll just show you the directory test, and it's completely empty. What we do now is we'll create a text file within this new directory that we created. So new text document, and I'll just name this demo. I'll open this and just put in some dummy content. So hello Simplilearn. Save this file and go back to your bash interface. Let's just check the status now. So git status, and as you can see, our file has appeared. It's visible, but nothing is committed yet. So this means that we have not made any change to our file through the Git tool itself. So the next thing that we are going to do is we'll be adding demo to our current directory. The next command that we'll be applying is the commit command. And when you add certain files to the current directory, the commit command is applied on all the above directories. So git commit -m and a message that will appear once the file is committed. So as you can see, one file is changed and one insertion. I'll just clear the screen. Next thing we need to do is we need to link our Git to our GitHub account. So the command for doing that is git config global user.username. And this will be followed by our username. So let me just show you my GitHub account. So this is my GitHub profile and my username is Simplilearn-GitHub. So guys, before you begin this procedure, just make a GitHub account. Type in my username here, Simplilearn-GitHub, and enter. And there you go. Our Git is successfully linked with GitHub. Next thing we do is we'll just open our GitHub and we'll create a new repository. Give a repository name. So I'll name it test_demo and create repository. Great. So our repository is created. This is our remote repository. What we do next is just copy the link and then go back to your bash interface. Now we need to link our remote and our local repository. So git remote origin and then paste the HTTP link. And now that our local repository and our remote repository are linked, we can push our local file onto our remote repository. So the command for doing that is git push origin master, as we are on the master branch. And that's done. So now let's move back to GitHub. I'll just click on test demo. And as you can see here, our local file has been pushed to our remote repository. With that, we have successfully completed our demo.
So we're going to introduce the concept of version control that you will use within your DevOps environment.
Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run into is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches, and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public shareable. It is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way, way, way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merge into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you're kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means, though, is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it could be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time.
Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch. And we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's been done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. And it makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command, commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you're going to merge that into the main branch. A git rebase will reapply commits on top of another base tip. And git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we'll actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the readme file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into README file, and I can change this. So we can go hello Git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the README text. So to do that, we'll use the diff command for Git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world. And then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and say git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/Simplilearn-GitHub, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/Simplilearn-hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right hand corner of the screen. Now, right now I'm actually logged in with the default primary account for this project. So I can't actually fork the project as I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in, and we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature, and then we can then paste in the URL of the new directory that has the forked work in it. And now at this point we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub, and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name, or by email address, or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. Call it test, and we're going to move into the test folder, and we will initialize that folder, and we're going to move some files into that test folder. Call this one test1, and then we're going to do file, save as, and this one's going to be test2. And now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit. And it's gone ahead and added those files. And so we can see the 2 files that were created have been added into the master. And we can now go ahead and create a new branch. You can call this one git branch test _ branch. And let's go ahead and create a 3rd file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file and do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test _ branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test _ branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test _ branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modify. And we can then commit that file back in. And we've actually been able to then commit the file with 1 changes, and we see it's the text-free change that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a. and we're going to commit those files. Git commit -a-m, adding 2 new files, and it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master, so we do git rebase master, and that will then give us the command that everything is now completely up to date. We can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files listed in correctly.
Now we will be talking about that how exactly we can make use of Maven here in performing various kind of operations, whether it's a build, compilation, various kind of stuff there. So let's talk about it, why exactly we use Maven here. Now Maven is something which is a kind of a build tool which is there for most of the Java-based projects here. So this tool also helps us in building up the source code by downloading some couple of dependencies. These dependencies are something which is being configured by the developers, which a developer feels that the project is dependent on, and he requires those dependencies to be downloaded. So this tool is specifically used to build and manage any kind of a Java-based project, whatever the complexity of the topic or the project is there. So this tool will be able to handle that particular requirement or that project. So it simplifies the day-to-day work of a Java developer and helps them in their projects for performing daily-to-daily activities. Right now, Maven also helps us in getting the specific jar files for each and every project. So if you are you can pretty much make a jar file, var file, or ER file, any kind of a package mechanism you can follow for your Maven there. So to download the dependencies, we don't have to actually go to the official website of each and every software. You can easily get it, the dependencies of each and every third-party binaries on the mvnrepository.com. This is a website which is present, on which if you visit, you will be able to download the dependencies which is required by your project or by your specific project over here. So it totally depends on how exactly you want to download and you want to get together a specific repository over here. So mvnrepository.com is the one. If you visit, you will be able to download and go through all the jar files, dependent jar files as in dependencies which you require for your current project. Right. So now what exactly is a Maven all about? So let's see on that part. So Maven is a popular open source build tool which is developed by the Apache group, and the primary ownership of this tool is to build, publish, and deploy several projects at once. Maven is written in Java, and it can be used to build projects written in C#, Scala, Ruby, etc. So apart from Java, these are the different programming languages or the tools which is supported by the Maven here for performing the build activity. So the tool is used for build and management of any kind of a Java-based project. It simplifies the day-to-day work of a Java developer and helps them to automate most of the compilation or build perspective tasks on the projects. Right. Now Maven is a kind of a BOM-based project, so it also known as a project object model, and it focuses on simplification and standardization of the building process. In the process, it takes care of all the followings here: builds, dependencies, reports, distribution, releases, mailing list. So all these things are being taken care as in this particular process here, and ultimately it's an ability inside the Maven that how the overall build process needs to be automated and standardized here. So all these particular mechanisms can be followed as such over here, so that we can have a good standards and the simplifications implemented as such here. Now in this one we are going to talk about that how we can work on Maven installation on Windows and Ubuntu platform here. So first of all, we'll do it on the Windows platform here, and we'll see that how the installation really works. So for this one, I will be doing the installation into my local system. Now before even going for Maven, Maven is a kind of a build tool which is available there, primarily for performing any kind of build automation for the Java based projects. Now since it's used for Java, we also require the JDK installation onto our system. So for that, both of the installations we will be covering over here, and we'll see that how the installation really works as such over here. Right, so before even going for Maven, we have to install the JDK onto our Windows machine so that we can proceed with Maven, because Maven requires the JDK installations to be there. Now there are two ways of JDK installation. Either you go for the exe file, or you extract the binaries of JDK to a directory and then set up the java_home path for that. But if you are using the executable, that will perform the path configurations for you also. So in that case, you don't have to reconfigure it again and again. So that's what we are going to see here. So first of all, we will try to do the installation of JDK. So for that, we'll go to the website of JDK, and then we have to click on this one to access the Maven installations part here. So that's what we are going to do. So let's proceed, and let's open the Chrome and try to go through these two URLs so that we can do the installations one by one. So here I have to just search for JDK 8 download. So it will show me the URL for oracle.com. So here you will get the JDK for the different platforms, for different operating systems. Now here what you can see here that you have the configurations in which you have the JDK installation. So we have to here I'll go for the Windows 64 version, because that is something I will be using to do the installation. So this is the complete executable link. So here you can download. So we are downloading the SDK U251. So just search for Windows 64. Yeah, this is the one. So let me click on this one. Let me quickly log into the web page. So once the login is done, you will be able to see that it's trying to download the exe file. So that was for the JDK, for the Java. Now for the Maven, I am going to go for the Maven download over here. So in this one, the Maven repo link is there. maven.apache.org is the link for this one. Now here we have the different options. You can see here that the binary zip archive is there, then source zip archive is there. So depending on the installation which you want to perform, you should be able to download that file, and it works there. So let's first install the JDK portion, and then we'll go with this one. So we'll click on this one also anyways, because it's something we have to anyways do it. So we'll click on this so that this Maven is also getting started downloading over here. So once both of them are downloaded, we will proceed further with the setup. So let's wait for another 1 minute to do this one. So the Apache Maven is kind of downloaded over here. So we wait for the JDK download also over here. So next 5-10 seconds only left out. So first JDK will be there, and then Maven installation configurations will be there. So for Maven, we just have to extract into a directory and give the MVN home path into the properties, into the variables, so that it can pick it up over there. Okay, so we have to extract the zip file for Maven, give the path, and then we will check with the Maven command whether it's working fine or not. So let's try to install the executable. So we'll open the directory where the executables are there. So first of all, we'll install the JDK. So we'll double click the installer for JDK. It's of around 200 MB. So the complete JDK will be installed. So we have to just go for next. Now when you go with the installer, so usually the Java home paths and all that stuff is already configured. So you don't really have to change the passwords or Java home, any kind of variable you have to put it up. All those things will be automatically cleaned up. So it's running the installation. Close. So then we have to extract the Maven. So we have to extract this directory, because here the Maven complete executables and libraries are there. So we just have to extract it and place into a directory so that we can further on use it and access the path. So once the access is done, yep, so this is done there. So I can rename it to like Maven. So I can rename it like to as Maven, and I can cut it down and put it into the C drive here. Now this is the Maven home path which is going to be there, right? So all I have to do is that I have to close this one and this one and this one and this. So what we have to do is that we have to really go to the system properties so that we can extract it. So I'm going to open the system properties over here. Properties. Now here the advanced system settings. Now in this one we will be setting up the paths. So environment variable will go. Now here if you scroll down you will see all the different paths which is available there as such over here. Now if we want to see that if the Java is fine or we require for JDK also, so all we have to do is that we have to open the CMD prompt. Window R we are providing. So using the window R I'm opening the run window where I can say like CMD. Now in this CMD I'm going to say like Java -version. So Java is there, so which means that we don't have any problem as such. Now I'll just go here and set up a new one called mvn_home. So here the same path. So you can browse for directory also, but I am using the mvn home over here in this one. Now I have just added that, and in the path variable in the last we have to actually add the bin directory also, so that whenever we run the mvn command, so that should also be resolved. So mvn_home is not the only variable which you will be configuring. In fact you will be configuring the path variable also, that you can go ahead and put up a new directory entry for the cmd here. So cmd till the cmd directory you will go there, and whatever the executable is there you should be able to resolve that. So for that again you have to open the window R, CMD prompt, Java-version, and then you can run mvn-version here. When you run the mvn-version, it will let you know that which particular Java runtime you are using, 1.8.0_251. That's the same one which we have configured. And it also let us know that where exactly the executable is there, and we can now proceed further with the execution of the Maven build. So you just have to check out your source code or go to that directory where source code is there, and you can run the mvn clean install. So that will ultimately go for the build process. So this is the way that how we can do the installation of Maven on the Windows platform. Now since this is done, now we will go ahead with the second installation where we are going to do the installation of Maven and JDK onto the Ubuntu machine. So for that we will log into the particular cloud lab of Simplilearn LMS. So let's log into the LMS here. So now we are going to do the installation of JDK and Maven on the Ubuntu virtual machine here. So for that we will log into the LMS. So let's log into that. So this is the LMS over here. Here I have already started the lab here. So all I have to do is that I have to just click on this link here. So it will open the lab into a new tab. It's a GUI mode of Ubuntu server, so which we will be using to configure it. So here first of all I can open the Chrome browser also. So let me open the browser here so that I can download the Maven executables as such over here. So JDK we can do it using the package installation. So using the apt executable we will be doing the installation. So I have to just open the terminal here. So once the terminal is opened, you have to log in through the root ID. Now why we require root ID? So that we should be able to do the package installations and other configurations. So that requires root access. Now once that is done, you have to run the particular app update command. Next you have to install the installer. So the Oracle installer we have to install. Now once the setup is done, so let's install the latest package over here for Oracle-Java 14-installation. So this will install the JDK 14 over here. So for that configurations. Now at the same time we'll go for Maven download also. So here we'll go for download Maven. So this is the tar file for executable. So I'm going to copy this URL here, and over here we'll say yes. So now the Java should be configured and should be set up over here in this one. So what we really need to do is that we need to run the Java command to see that if the installation is done properly or not. So let's open the terminal again, another terminal, so that I can perform the steps related to Maven. So I have got the URL, so I'm going to the OPT directory, which is always an optional directory where we can do the setup and all those configurations. So I'm going to run the wget command and then the URL which I have downloaded. So this should download the tar file over here of Maven. Now once that is done, so I have to extract it. So tar-xvzf and the tar file name. This is a tar gunzip file, so I have to use tar-xvzf parameter over here to extract it. Now what exactly I have got the Apache Maven directory over here, so I'm going to rename it. In order to rename it, what we need to do, we need to actually go for the particular move command. So move whatever the existing folder you have, and then I'm going to rename it with the Maven directory. Now once that is done, I'm going to the Maven directory, and this is the path or Maven_home path which is available as such over here in this one. So here all the bin directories, executables, all this stuff is there. So now I can use it like mvn_home and the same configuration just like we did in the Windows. So here also the same process we have to follow. So Java version should be let me know that which version is deployed. So 14.01 version is deployed over here. So for Java I don't have to set up the path again here because I'm using for the installer, so I don't have to set up the path, right? So for Maven, now what exactly I have to do, I have to go to the etc profile D. Now here I'm going to put up a particular file. Now here you can see that we have the JDK file here, which means that the path variables and everything is configured as such over here. So you can see that Java_home, path, all these variables are copied here. So I'm going to also create a same file similar to this one here, but in this case what I'm going to use it that I'm going to remove some of the values. So I'm going to have some of the parameters added. So in order to do it effectively, I can do the echo command so that I can copy the things from here and I can simply put it up into the file here. So I'm going to have the path variable added up over here. Now why I'm putting up the path, because it's the same configuration which we did over there also. So opt/maven/bin. So all the bin directories should be added to the specific path variable. So I'm just trying to create a file called maven.sh. Just like a jdk.sh over here, I'm also creating similar kind of file over here called maven.sh. Now I'm not going in the VI mode or other editors because I just want to make you understand that how I'm copying it, the content. I'm taking the jdk.sh as a reference and putting up the details over here in this one. And then I'm going to export mvn_home over here, which is related to like opt/maven. So this is what we are going to put up over here, and then Maven. In the end, Maven, this is the file which you should be having. Now why we are using it? Because of the fact that it's being used, or it will be utilized in such a way that you can perform the changes or whatever configurations you want to perform. This will help you to set up the certain paths like path and mvn home so that you can run these scripts as such over here. So I'm going to give the executable permissions to this one, and that's it. So now what exactly I have to do is that I have to do the source here, profile.d maven. Once that is done, I will be able to run the mvn-version over here, and the JDK part is already open, so it's going to refer to that part. So this is the way that how we configure the Maven and the JDK specifically on the Ubuntu virtual machine. So pretty much that's it for this demo. In this demo, we primarily talked about that how we can do the installation of JDK and Maven on Windows, and how we can do the similar task on the Maven on the Ubuntu virtual machine also here. Hello everyone, welcome to this demo. In this demo we are going to talk about it how exactly we can do the installation of Maven on the Mac operating system. So here we are going to talk about it how we can do for a specific setup where we can do for the installation of Maven in a Mac operating system. So let's see. So there are two ways of doing the installation here. First is through the brew executable on the Mac. Now this brew utility on Mac is just like apt or yum utility which is present in most of the environments or most of the platforms here. But here we are using this brew to do the installation of Maven on the Mac operating system. And again, So next one is just a particular mechanism where you should be able to have the setup, like you can download the binaries from the Apache website, and then you can export the m2_home and the path variable so that you can start using the Maven executable. So we'll talk about these things, and we'll see that how exactly we can go for this setup. So let's log in to a particular machine or Mac operating system, so where we will be able to do all this activity. So this is the Mac system which we have here. Now in this one, what we are going to do is that we are going to open the terminal. So we are going to open a terminal here. So this is my terminal. So usually in Mac, you don't require any other mechanism. So the inbuilt terminal is more than sufficient for doing this stuff because it's similar to a Linux based platform here. So I'm going to run the command here. So first of all, I'll just double check that if my brew executable is working fine. So I'll just run the brew help command to see that if my brew is working fine as such over here in this one. Now I have the command called brew install. So that is a command which we need to use. Now in this one, we have to actually give the specific package which we want to install. So we will say like brew install Maven. So it will download the specific executables on the system. From the website, it will download the Maven executables. So it will take some time, but ultimately it's trying to download it and the particular tar file. So you can see here that it's downloading 3.6.3 tar file over here. So I can see that the installation is done. So the 3.6.3 version should be installed over here. So when I do like Maven mvn under hyphen version over here, so you can see that the 3.6.3 version is deployed as such over here. Now this is something which is done with a purely command over here called brew, which really helps us to do any kind of package installations. Not only Maven, other packages also can be installed pretty much with the help of this executable. Now, in order to see the manual stuff, what we really need to do is that we need to actually clean this specific installation so that I will be able to show you the manual installation also over here. So what I'm going to do is that I'm going to run the command called brew uninstall Maven so that the Maven should be removed from your system. So we are just trying to remove the Maven from here, and you can see that the Maven executable is not working as such over here. So which means that the Maven is uninstalled in this case. But why I have uninstalled here? So that I should be able to go ahead and download some custom Maven over here in this one. So I have opened the browser here. So I'll go for the Maven executable. So we'll go for Maven download so that we should be able to download a specific the executable here. So I'm going for this directory. So here 3.6.3 version same is available here. So I'm going to download the bin.tar.gz, which was the file we have. So this is also a kind of a Linux platform, right? So that's the reason why here the tar file should work perfectly fine. So here I'm going to the OPT directory where we can have all the optionals related packages. So if it is not there, so I can create a directory called /opt. So I can log in with root. So if you don't have the root access, so you can go for the applications. In the applications, you can actually create a directory called Maven. So here I can go for Maven. Yeah. So here we will be downloading the var file here. So the tar.gunzip file we are downloading over here. So I'll give the path here. So once the var file or wget command I am using to do the installation, but sometimes the wget is not available. So I can go for the brew install wget also. If that package is available on brew, the installation will be done. So we'll try to do the installation using wget so that we will be able to get a tar file generated or downloaded. There are other ways also. You can download it from the browser also. Yeah, you can go to the browser and here you can actually click and download it, and then you can transfer it locally to this specific directory also. So both the possibilities are there, but I'm just trying to download the wget command so that it will be easy for me to do the setup and to do the download over here. So I'm going to run the same command again. So it will download the tar file. So this is the tar file which is available over here. So I'm going to extract it over here. So once the extraction is done, so I'm going to rename it like to Apache Maven. so that I should not have any kind of versioning or these kind of parameters over here. And the apache.maven hyphen this tar file I'm trying to remove as such over here. So this is what I have got as an end result over here. Now this is the current directory in which I have these applications and these setups going forward over here. So if I run the mvn hyphen version command, so that will not be giving me any kind of output over here, because still I have extracted the tar file, but that is not, the activity is not complete. I have to exactly set up some environment variables so that I should be able to run this mvn command. So what I really need to do over here is that we have to export certain variables. Application/maven Apache Maven. So this is the home directory which I'm trying to configure over here. And then next thing is that path variable. So I'm going to have, we are going to coordinate the path variable with the folder. So I'm going to have the folder structure here. So the bin directory we have to provide. So I'm going to copy here and paste, and then I'm concatenate it with the bin here. So now my environment variables are established. So my mvn hyphen version command, as you can see here, is that it's being picked up over here, but it's saying that the particular Java runtime is not available. So I can go for Java brew install Java. So that should be enough there to install a Java package there. So you can see that it says that it's already installed, so and up to date. So that's the reason why it's not able to do the installation. So I'm going to reinstall OpenJDK. Because what happens that when we do the installation, some environment variables related to Java should be formatted or should be extracted over here, right? So as you can see that here it's saying that if you want to really use the executable of Java, you have to concatenate the path like this. So let's run that, and then we can see that the particular executable of Java will also be find out over here. So Java hyphen version showing that yes, it's available there. And now my command should be able to show me that yes, it's working fine. The JDK was already installed, but the problem with that is that since it's installed into a particular location, so you have to actually override your path value so that you should be able to see in that directory and find out the Java executable. So that I have got by doing the deinstallation. I got the command over there in the output saying that this is the installation which is done, and now you just have to extract, or you have to just put that path directory into the specified path variable, and that's how you got the Maven and Java both command lines working over here. So this is how you will be doing the Maven installations all together, how the overall installation of Maven and the JDK really works on Mac operating system. Now what exactly is a Maven repository all about? So Maven repository is something which is kind of a directory, or it's kind of a location where we have all the jar files packaged all together in a single location. So depending on the software which you want to download, the dependent jar files can be downloaded from there. So the metadata refers to the POM files relevant to each project here. This metadata is what allows Maven to download the dependencies. Now there are three types of repositories from where we can download the dependencies. The first one is the local repository, second one is the remote repository, and the third one is the central repository. So these are the primary three type of repositories which is available there for a specific Maven over here. So whatever repository you want to follow, you want to access, you can pretty much access it and you can go with that. Right now, the local repository will be primarily present onto your PC. That's the way that how it's present there. And the particular remote repository is something which you can store on any remote machine or remote server. And the central repository is something which you can have it onto the internet. So usually the central repositories is something in which we can actually host our different kind of dependencies and the jar files over there. So local repository on the machine of the developer where the project material is saved. So all the particular dependencies jar file will be available on your local machine. Remote machine is the location where you can actually store all your particular dependencies, from where you can download these dependencies whenever you require it. So this repositories work similar to the central repository. Whenever anything is needed from the remote repository, it's first downloaded into your local repository and then it will be utilized. So if you feel that the dependency is something which is not there in the local, it will be first downloaded from the remote repository and then it will be utilized or will be referenced onto the local machine there. And central repository refers to the Maven community repository there, where you will be able to see each and every dependency present on that repository. So Maven downloads the repositories from here in the local repository whenever they're needed or whenever required. All these dependencies are cached locally, from where it will be referenced in the next, or whenever we want to refer that, we will be able to do that particular reference easily on that part. So this is the way that how the three particular repositories or Maven repositories really helps us for performing various kind of automations as such here. Right, now what are the basic concepts of Maven here? So some of the couple of basic concepts which is present in Maven is, like, for the first time we have the project object model. So project POM refers to the XML file which has all the information regarding the project, how this particular project should be built up, how the different build process should be automated there. It also has a description of the project, details regarding the versioning. Versioning information is also stored as such in this XML file, in this particular POM reference file as such over here. The XML file is which is there in the project home directory. So Maven is something which search for the POM file in the current directory. If it's able to find that particular POM file, so it will execute or it will proceed with the build step. Otherwise it will halt there itself. So this POM file is very important because it will act as a kind of a build script, and primarily the Maven tool will be able to process each and everything which is configured as such in this specific XML file there, and according to that only it will function or it will proceed further. Right, now second thing is the dependencies and repositories. So dependencies usually refers to the jar files, so the Java libraries which we need in into our particular project. So while working on the project, we may be having the dependency on couple of dependencies. So these dependencies we have to actually download or we have to actually refer, and once these particular information or these details are referred, so what will happen that we need to download these specific dependencies from the particular Maven repositories. So if the dependencies are not present in your local repository, then Maven will try to download it from the central repository and cache it into your local repository. But first of all, it will look on into the local repository, and if it is not present in local, then only it will go to the remote or the central repository. Then we have build life cycles and phase and goals there. So build life cycles consists of the sequence of build phases, and each build phase consists of sequence of goals here. Now each goal is responsible for performing a specific task. When a phase is running all the goals related to that phase, and its plugins are also used to performing the compilation, preparing the artifacts, downloading the dependencies, all different things being done by the plugins here. Then we have the build profiles. So build profiles refers to a set of configuration values. Now generally we have the generic build process for all the environments or all the particular code base there, but sometimes we do have some kind of a differences there. So that is where we can go for the profiles, because a specific profile can have its own configuration, and whatever it's required for the build process, we can have different configurations stored inside the Maven build script here. Then different build profiles are added to the POM files, and which enables the different build as such here. So depending on these profiles, we can actually decide that how we need to proceed with the build process and how the different kind of build automations needs to be performed here. Then a build profile helps in customizing the build for the different environments, so that also we can perform as such while performing or while working on the different components and the different management here. So a build profile is something which you can configure, you can utilize, and depending on that build profile, we will be deciding whether to proceed further or how to decide on that particular factor. So these are something which we need to take care, or we need to work according to which we can decide that how the specific configurations and specific automation needs to be performed here. Now usually when we go for the Maven there, so we have to use some couple of Maven plugins. Now the goal of using these specific plugins is to automate some of the basic stuff like compilation, creating the var file, creating the jar file. So when we are using the plugins, we don't have to configure the steps or write the steps that how these specific plugins should be installed or should be referenced. It's ultimately the internal configurations which we are looking forward or which we are using while working on these specific plugins. So you can download some couple of plugins using which we will be able to decide that how a specific goals needs to be achieved here. So Maven has its own standard plugins that can be utilized. So if want to go for a custom one, so you can do that, but pretty much you can go for the default one, and you can pretty much have some specific goals executed with the help of these build plugins. Now next thing is the Maven architecture. So in Maven, what happens that let's talk about the basic architecture of Maven here. So the Maven executable, when it's deployed, so it usually reads the pom.xml file, which is the build script here. Now once the specific pom.xml file is being read out, so it will process the components. It will download, or it will process the dependencies, plugins, life cycles, phases and goals, and even the build profiles. And if any kind of interaction is required, so it will try to connect to the central repository or a remote repository, and according to that it will provide the information and provide the details as such. So Maven repository is something which is very important because it's ultimately trying to connect to the Maven repository and try to achieve the various kind of automation here. So it's very important because ultimately it's trying to help us to go for the complete end-to-end build automation when we'll go for a specific POM based build automation. So Maven executable will read the pom.xml file, then download the dependencies defined into the pom.xml file, and that dependencies are cached locally from the remote or the central repository. Now then create and generate a remote report according to the requirement and execute the life cycles, phases, goals, plugins, etc. So it will process the pom.xml file there, and whatever the plugins and goals or the life cycles which is configured there, step by step each of them will be executed into a sequence here. Now let's talk about the overall build lifecycle of the Maven here. So what happens that the Maven build lifecycle is something which is a kind of a collection of different steps there, and this is something which is followed to perform a build automation for a specific project. So that there are pretty much 3 steps which is being done. So first one is the default. So it handles the project deployment there. Second, handles the project cleaning, which is a clean there, and then we have site. So it handles the creation of the project sites documentation there. So these are the 3 built-in particular life cycles which is available there at the Maven level, which you can utilize to perform a various kind of particular steps execution for your project. Right, so the build cycle has the different build phases or stages there, because when we are performing a build, a variety of things needs to be performed over here. So the first one is the compile, then test compile is there. So compilation is there for the source file, and test compile is there for the test cases. Test will execute the test cases, package will package the bundle, then we have the integration test to run the integration test cases, then we have the verify, then install goal is there, and the last one is the deploy, which is there to deploy the artifacts to the artifact tree. So all these things are the different phases and the stages which is being followed as per a specific build here. So during these builds, these are the different phases and the stages which we normally follow for performing the build automation. Now what is the exactly advantage of a specific Maven here? So that is something which we need to talk about, that how the particular automation needs to be done, or how we can actually go for the configurations where we feel that yes, we want to perform or we want to take certain benefits out of the implementation of Maven here. So for that, what happens that we have to see that the various kind of benefits. The first one is that Apache Maven helps manage all the processes there, such as building, documentation, releasing, and distribution in project management here. So the tool simplifies the process of project building. It increases the performance of the project and the building process altogether. And the task of downloading jar files and other dependencies is also done automatically. We don't have to indulge in any kind of download part as such manually over here. right? And Maven provides easy access to all the required information. So Maven makes it easy for a specific developer to build a project in the different environments. So we don't have to worry about the environment, we don't have to worry about the infrastructure, nothing is required. Everything is available there inside this package. And depending on the particular, you can write the source code on one machine and you can pretty much do the build on another machine. And this is the reason how the build automation really happens on the first place, because the developer is writing the source code in one location and the same code is deployed onto the particular, or built onto this Jenkins or any kind of build tool there. Right, in Maven you can easily add new dependencies, so you must write the particular dependencies in the POM file. So if you feel that you want to download some particular dependencies, so all you have to do is that you have to put that dependency into the specific pom.xml file there, and depending on that, the execution will be really performed and executed as such here. Right, so let's talk about the demo now. So let's see that how exactly we can go for this demo and we can perform the various kind of automations. So this is the virtual machine which we have here, on which the Maven is already installed. So we can run like mvn. So Maven will be available as in 3.6.3 here. Now I'm going to run a particular command called mvn archetype generate here. Let me create a directory here, a temp directory, and to perform this activity over there. So mvn archetype generate. Now once we run that, so what will happen, that it will download some of the binaries there, because ultimately what we are trying to do is that we are trying to generate a new project, like a Maven project. So a couple of particular plugins will be downloaded by the Maven executable so that it can achieve that particular execution. So we just have to wait for downloading all these values. Now here it's trying to give us a particular attributes, like it's asking the different attributes over here. So what exactly we want to configure. So if you want to configure, you can provide that details, otherwise you can perform or whatever the setup you want to perform. Now here it's asking for the version, so which kind of version we want to follow. So I'm going to follow like 5 here, so I'll press 5. Then a group ID which is there, so it's basically a kind of a group mechanism, so I can say like com.Simplilearn. So that's the value which I'm providing here. Artifact ID, I can make it like a sample project or something like that. I can do, so that will be the artifact ID which is there. So version I am keeping the same only. So and yeah, so package same here. So I just want to create, so I'll just provide the value called yes and enter. So with this, what will happen, that a sample project will be created here, right? So whatever the artifact ID you provided, so according to that, the project is created in this directory. So you have to go into this directory and see that what exactly the files are created there. So you have the pom.xml file. Now this pom.xml file, when I open, so you can see here that there are some attributes, like you can have the values related to what version or group ID you want to follow. So this is the group ID, this is the artifact ID. So this is jar file. By default you can change it according to your requirement. Then this is the version, and if you feel that you want to do the changes to the name, that also you can perform here. So by default the JUnit dependency is added, but if you want to keep on adding your own custom dependencies, you will be able to do that. Now in this case, if XML file is already there present in the local directory, so according to that the execution of the steps will be performed, and according to that you will be able to get some desired values here. So ultimately in the target directory you will be able to see that some couple of jar file or a specific jar file is generated here. So you can see that in the target directory this jar file or this artifact is generated here. So this is a way that how we can actually go for a generic one, like a new particular project, and later on you can, depending on your understanding, you can keep on adding or you can keep on modifying the dependencies, and that's how you can get the final result there. So that's it for this demo, in which we have find out that how exactly we can go for a particular project preparation with the help of mvn executable. Welcome everyone to this topic, in which we are going to talk about that what exactly is the different Maven interview questions here. Now in this one we are going to talk about what are the different questions, some couple of questions we are going to go through, and we'll try to understand that what exactly the answers are. Now let's talk about the first question over here. So what exactly is in Maven here? So Maven is nothing but a kind of a popular open source build tool which is available there. Now before Maven, there were a couple of build tools which was present, like Ant, and a lot of other legacy tools was present there. But after that, Maven is something which was released as an open source tool, and it really helps the organization to automate some couple of build processes, and have some particular mechanisms like build, publish, and deploys of different projects at once itself. So it's a very powerful tool which can really help us to do the build automations. We can integrate them with the other tools like Jenkins, and we can automate them, we can schedule the builds. So a lot of various advantages we can get with the help of this tool here. It's primarily written in Java, and it can be used to build up various other kind of projects also, like C#, Scala, Ruby, etc. So all these other typical tools can also be built up with the help of this tool. So this tool is primarily used to do the particular development and management of the artifacts in the Java based projects. So for most of the Java based projects nowadays, this is the default tool, and it's already integrated with the Eclipse also. So when you go for a new Maven project, automatically it will be created for a Java project. You can use it for other languages also, but yes, default choice of Java, of the Java programming language, is Maven build tool only. Now let's talk about the next question. So what does the Maven help with? So Apache Maven helps to manage all the processes such as build process, documentation, release process, distribution, deployment, preparing the artifacts. So all these tasks is being primarily taken care by the Apache Maven. So this tool simplifies the process of project building. It also increases the performance of the project and the overall building process. So all these things are something which is being taken care by the specific Maven tool here. So it also uses the particular, it downloads the jar files of the different dependencies. For example, if your source code is dependent on some of the Apache Web Service jar files or some of the other third-party jar files, in that case, you don't have to download those jar files and keep in some repository or keep it in some lib directory. You just have to mention that dependency in the Maven, and that jar file will be downloaded during the build process and will be cached locally. So that's the biggest advantage which we get with Maven, that you don't have to take care of all these dependencies anywhere into your source code system. So Maven provides easy access to all the required information. It helps the developer to build the projects, and without even worrying about the dependencies, processes, or different environments, or different, because it's an kind of tool which can be used in any platform, Linux or Windows. So they don't have to do any kind of conversions. So all they have to do is that they have to just add new dependencies, and that should be updated into the POM file, and depending on that dependencies, the source code will be built up, and they don't have to refer any kind of third-party jar files. So they don't have to play with the class paths during the build process. So no customizations is actually required with this one. Now the next question is that what are the different elements that Maven take care of? So there are different kind of elements which is being taken care by Maven. So these particular elements are builds, dependencies, reports, distribution, releases, and mailing list. So these are the typical different elements which is being taken care by the Maven during the build process and during the preparation of the builds here. So all these things you can they can explore, they can extract on that part, and they can fully understand that how they can work on all these different processes. Now next question is that what is the primary difference between the Ant and Maven? First of all, both of them are primarily used for the Java based project. So Ant is the older version, and Maven is something which was launched after the Ant here. So Ant has no formal conventions which can be coded into the build.xml file there. But yes, the Maven has conventions, so information is not required as such in the pom.xml file there. So Ant is procedural, whereas Maven is declarative over here. So Ant does not have any kind of life cycle, so it depends on you that how you program the Ant there. But Maven is having a lot of life cycles there which we can configure, we can utilize. So the Ant related scripts are not reusable because you cannot reuse it, and you have to do some kind of customizations in order to work on that. But yes, Maven is not having much of the project related any kind of dependencies. They can be easily reusable there because there is nothing about the pom.xml file. It's just the artifact name and the dependencies, which is something we can override or we can change, and then the same pom.xml file we can reuse as such for the new project also. So that is where the reusability comes into the picture. Now Ant is a very specific build tool, so we don't have to, there is no plugins as such which is available there. You just have to code everything that what build process you want to prepare. Whereas in case of Maven, we have the concept of plugins, which can really help us to understand that how we can make use of these plugins so that we can have the reusability implemented. So these are some of the differences which is available there between the Ant and Maven here. Now next thing is that what exactly is in POM file all about. So POM file is nothing but it's kind of a XML file which is available there, and it's having all the information regarding the project and the configuration details. So it primarily used over here that how the configuration needs to be done and how the setup should be performed as such here. So pom.xml file is the build script which we prepare. You can prepare it using a particular component, or you can have a particular mechanisms, or if you feel that you want to have some kind of setup. So all these things typically can be implemented, can be done with the help of build tools. So build tools can be really helpful for us to do the automations, and it can really help us to understand that how some build processes we can automate with simply with the help of pom.xml file here. So the developers usually put up everything inside these dependencies in the pom.xml file here. So this is the file which is usually present in the home directory. It's in the current directory, so that once the build is triggered, it will be picked up from that directory, and according to the steps, according to the content of the pom.xml file, the build will be processed or will be created here. Now what all included into the POM file here? So the different components which is included into the pom.xml file here is the dependencies, developers and contributors, plugins, plugin configuration, and resources. So these are the typical components which is a part of a pom.xml file, which can be same for a lot of projects. You can do some customization, and then the same POM file can be reused for the other projects also. Now what are the minimum requirement of the elements which is there for a pom.xml file, so without which the pom.xml file will not be validated and will be getting a kind of validation errors. So the minimum required elements are project root, model version, so it should be 4.0.0, the group ID of the project, the artifact ID of the project, and the version of the artifact. These are the minimum things which we want to define so that we can understand that what kind of artifact we are trying to prepare or we are trying to create here. So these are the minimum required elements which is required in the pom.xml file, without which the validation of the POM file will fail and the build will also fail here. Now what exactly is the meant with the term called build tool? So build tool is an essential tool, is a kind of a process for building or compiling the source code here. So it's needed or it's required for the below generated processes. If you want to generate the source code, if you want to compile the source code, you want to generate the source code, you want to generate some documentation from the source code, you want to compile the source code, or you want to package the source code, whether it's a jar file, it's a war file, or it's a ER file. So whatever the packaging mode you want to select, you will be able to do it with the help of the particular build tool here. And if you feel that you want to upload these particular artifacts to the artifact tree, whether it's on remote machine or locally there, so that also you can do it with the help of this particular build tools here. So build tools can be helpful in doing a lot of activities for the developers. Now what are the different steps which is involved to install Maven on Windows? Now all you have to do is that you have to just first of all download the tar file from the Apache Maven repository there. Once that is done, so what happens that you have to set up some couple of environment variables. Now if you download the Java JDK using the exe file, in that case the java_home will be configured automatically. But if it is not available and you're not able to run the Java command line, in that case you have to set up the java_home. And then similarly for Maven, you have to go for the Maven_home. That particular variable you have to configure. Now once that is done, all you have to do is that you have to edit the path variable. So the bin directory of the Maven extracted folder, you have to put it up into the path variable. And once that is done, what will happen that you will be able to check the latest version, the version of the Maven over there. If it is like some old version, again you have to extract the latest version and do the steps all together again. So these are some of the ways that in which you can actually go for the installation or the configurations of Maven on the Windows platform. Now, what are the different steps which is involved for the installation of Maven on Ubuntu? So Ubuntu, it's fine. You just download the package of Java JDK there. Once the JDK is installed over there, what you can do, you can simply go ahead and say that, yes, I want to search for a particular Maven package which is available there. So once the JDK is installed, all you have to do is that you have to configure the java_home, m3_home, maven_home, and the path variable. Once all the path variables are something which is configured, then we will be able to check the latest version, like whether it's the version is correct or we are getting the standard version over here or not over here. So that's the main mechanism that how we will be able to configure the Maven on Ubuntu here. Now, what exactly is the command to install the jar into the local repository? Now, sometimes what happens that we are not able to fetch, like some dependency is not present on the particular central repository, Maven repository, or your Artifactory repository. In that case, you have some third-party jar which we want to install locally onto your repository. So in that case, we can go for the but we can download the jar file there, and then we can run the command called mvn install-file, and then we are giving the path like -d file where the path of the file should be provided. Now once that is done, so what will happen that in the local .m2 directory, the specific artifact will be downloaded and will be installed there. So this is a mechanism where you will be able to configure or you will be able to set up the artifacts locally, the jar file locally here in the local repository. So next question is that how do you know that the version of the Maven being used here? So the version of the Maven is pretty easy to calculate. So all you have to do is that you have to just go for mvn and space -- version. The moment you do that, it will let you know that what JDK or what Java version you are using, and it will also show you that what particular Maven version you're going to use here. So all that details you will be able to get with that particular command here. Now, what exactly is the clean, default, and site-in variable here? So these are the build cycles which is available there within Maven. So these are the built-in build cycles. So for clean, what happens that this life cycle will help you to perform the project cleaning. So usually during the build, there are some files which is created into the target directory. So the clean life cycle is essentially helping us to clean up all that directory, all that particular target directory. And when we talk about the specific default, so default life cycle handles the project deployment. That is the default life cycle, and site is something which is helpful for creating the site documentation. It's kind of a life cycle which is available there. So clean, default, and site are the different life cycles which can perform different kind of attributes or different tasks here. Next question, what exactly is a Maven repository? So Maven repository refers to the directories of the package jar files that contain metadata. Now the metadata refers to the POM files relevant to each project. So here you can able to get your artifacts stored there. You can download these artifacts also during the Maven build. If you put up that dependency, there are different kind of repositories which is available there. One is the local repository, one is the remote repository, and one is the central repository. So these are the different typical type of repositories which we have, where we can store the artifacts also, and from where we can download the artifacts also whenever required. Now the first one is the local repository. So local repository refers to the machine of the developers itself, where all the project related files are stored there. Now whenever we work on the particular Maven, so there is in the home directory .m2 folder is created. Now usually whatever the artifacts downloaded from Artifactory or from the Maven repository, it gets cached locally there, and once it is downloaded, next time it will not download the same artifacts or the same dependency altogether again. So this local repository is something which is available locally on the developer's machine only. So it contains all the dependent jars which a particular developer is downloading during the Maven build. Now remote repositories refers to the repository which is present on the server, and from where we will be downloading the particular dependencies. So when we are running the Maven build on a fresh machine, so usually over there the local repository does not exist. So in that case, what happens that the .m2 directory is empty. But the moment you run the build, what will happen that the artifacts or the dependencies will be downloaded from the remote repository, and once it is done, once it's downloaded, it will be added, or it will be downloaded cached locally there, and it will be helpful in the future run. So that will be considered as a local repository because all the artifacts, all the dependencies are downloaded there. And central repository is something which is known as the Maven community, where all the artifacts is available there. So usually we cache or we mirror these central repositories as our particular remote repositories, because it could be a possibility that these remote repositories are something which we are hosting into our organization, and central repository is something which is available centrally for everyone to use it. So these are something some kind of repositories where each and every artifacts will be stored, and anyone will be able to have the access to these particular artifacts here. So these artifacts are every open source artifacts is something which is available over there to these central repository. Now, how does the Maven architecture really work here? So the Maven architecture really works in the 3 steps. The very first step is that it reads the pom.xml file here. That's the very first step. Second, it downloads the dependencies defined in the pom.xml file into the local repository from the central or the remote repository here. Once that is done, so it will create or generate the reports according to the life cycles which you have configured, whether it's a clean, install, cite, deploy, package, or whatever the life cycle you want to trigger. You will be triggering that particular life cycle, and corresponding to that the build or a specific task will be performed. So these are the 3 steps in which the overall build or any kind of execution of pom.xml file really happens here. Now, what exactly is the Maven build lifecycle? So Maven lifecycle isn't nothing but collection of steps here that needs to be followed for doing a proper build of a project here. So there are primarily 3 built-in cycles which is available there. Default, which handles the project deployment; clean, which handles the project cleaning there; and cite, which handles the creation of the project sites documentation. So these are the 3 primary built-in build cycles, life cycles, which is available as such. Now, so build lifecycle has different kind of phases or the stages here, because in the previous particular slide we were talking about what are the different particular build life cycles which is available there. But these are the different phases, like what are the different step-by-step executions, like further deep down, which is available there inside a specific Maven build lifecycle. So here you can see that it's compile, then the test compile, test execution is there, then package, integration test, verify, install, and the lastly deploy here. So these are the different build phases which is available as such over here. So what exactly is the command to use to do a particular Maven site? So mvn site is something which is used to create a Maven site here. Now usually whatever the artifacts is prepared, that will be prepared in the target directory. So here also you will be able to see a site directory which is available there in the target directory, which you can refer for the site documentations. What is the different conventions used while naming a project in Maven? So usually it involves 3 components. So the full name of a project in Maven includes first of all the group ID. For example, com.apache, com.example. So these are some of the particular way that where you can provide the group ID. Artifact ID can be exact project name like Maven project or whatever the project you are creating. So sample project, example project. So these kind of things will be there in the artifact ID. And lastly is the version, like which version of your artifact you want to prepare, like 1.0.0 snapshot, 2.0.0. So like this information you are providing, that what particular version you are trying to configure here. Now let's move on to the intermediate level, where we will be having a little bit more complex questions related to the Maven here. Now what exactly is a Maven artifact? Now usually what happens that when we do a build process, as an end of result of the build process, we will get some artifacts. For example, when we build a .NET project, so there we will be able to have a exe or DLL files as an artifacts. Similarly, in case of Maven, when we do a build process, there we get the different kind of artifacts, like depending on the packaging mode, like jar file, var files, or the ER files here. So these are something which is, getting generated during the build process, during the Maven process, and you can store them into your local repository, or you want to push them to the remote repository. It's something that totally depends on you. So Maven is a tool which can help you to create all the artifacts, whether it's a jar file, whether it's a var files, or whether it's a ER file here. And every artifact is having 3 attributes. The first one is the group ID, the artifact ID, and a particular version. And that's how you will be able to identify a full-fledged artifact as such in Maven. So Maven is not about only the name of the jar file. It's actually referring to the attributes like group ID, the artifact ID, and the version of the artifact here. Now, what are the different phases of the clean lifecycle here? So clean is something which is being used to clean the target directory so that a fresh build can be triggered there. So there are 3 steps: pre-clean, clean, and post-clean here. So if you wish that you want to override the particular lifecycle configurations and you want to run some particular steps before the clean activity, so you can do it into the pre-clean, and if you want to do it like some steps after clean, then post-clean can be utilized. Now, what are the different phases of the site lifecycle? So pre-site, site, post-site, and site deploy. So these are the different phases which is available there in the site lifecycle. What is exactly we meant by the Maven plugin? Now, this is the huge difference between the Ant and Maven here, because in Ant we were not having that much support of the plugins, and that's the reason why we had to deal with all the build configurations. So we have to simply put the overall build process, that how the build should be triggered, but that is not something which is there in case of Maven. In Maven we have a lot of flexibility, because we can actually put up what exactly build configurations we want to put here. We can put some features like important features over here in Maven, and these plugins we can utilize. For example, I want to perform a compilation. Now, I don't really want to do any kind of configurations in this one. So what I can do is that I can simply use the compilation plugin in Maven, and that can really help me, because I don't have to unnecessarily write or rewrite the configuration that how the compilation should be done. It's something which is pre-configured or pre-written in these plugins, that I can simply import the plugin and I can do the build process or the compilation process in a pretty standard mode. So I don't really have to do any kind of workarounds with that, and simply with a small automations I will be able to reach that how this Maven plugins can be integrated into my .xml file, and I can desire or I can have some particular procedures and some steps executed there. So that's the biggest benefit which we really get with the help of Maven plugins. Now, why exactly the Maven plugins are utilized? So to create a jar files, to create the var files, to compile the code files, to perform the unit testing, to create the project documentation, and to create the project reports. So there are a variety of things in which we can actually use these Maven plugins through the integrations within the .xml file there. So it's all about the plugins. You just import the plugin and that desired activity will be performed there. Now, what are the different type of plugins which is there? So you can have either a build projects. For performing the build activities, you can have some build plugins. For reporting plugins also there, which can be only generated or utilized to generate the reports, to process the reports, and do any kind of formatting or any kind of processing on the reports here. So that is where the reporting plugins are utilized. Now, what is exactly the difference between the convention and the configuration in Maven? So convention is in particular process when the developers are not required to create the build processes. So configuration is when the developers are supposed to create the build processes. So the users do not have to rectify the configuration in detail, and once the project is created, it will automatically create a structure. So they must specify every in case of configuration, you have to provide each and every details. So that's how the configurations really happens, because you have to put every detail into the .xml file, and that's how the particular configurations really work as such. So this is the huge difference between the conventions and the configurations here. Now, So why exactly is said that Maven uses conventions over the configurations? So Maven pretty much does not put any efforts like on the particular developers that they have to put each and every configuration. So there are some ready-made plugins which is available there, and pretty much we are making use of that so that in such a case we don't have to worry about the executions, and we will be able to pretty much work on that. So conventions, like Maven uses the conventions instead of the configurations, so the developers they don't just have to create the Maven project, the rest of the particular structure will be taken care automatically. So they are not expecting that the developers should be doing the configuration work, and everything should be taken care in such a way that you just have to start the things and rest of the things should be taken care by the Maven itself. So Maven will be responsible, because due to the plugins, it will be responsible to set up the default architecture, the default folder structures, and all you have to do is that you have to just place the source code in the desired folder structure here. So that's something which you need to do as a particular developers. So what exactly is the Maven order of inheritance here? So the order of inheritance is the settings, CLI parameters, parent POM, and the project POM, which means that if you have some configuration and settings, that will be the highest value, then the CLI parameters are there, then the parent POM is there, and then the project POM. So this is the way that how the particular parameters or the configurations will be picked up by the Maven. So that's the order. So what does the build life cycles and the phases imply in the basic concept of Maven? So build life cycles consist of a sequence of build phases, and each build phase consists of a sequence of goals. When a phase is run, all the goals related to that phase and its plugins are also compiled. So you will be able to have a lot of particular goals which is residing inside a phase there. And similarly, lifecycle is nothing but a kind of a sequence of the different phase. So lifecycle comes in the top, then it comes on the phases, and then it comes on the goals here. Now, what is the terminology called goal in case of Maven? The terminology goal refers to the specific task that makes it possible for the project to be built and organized. So it's something which we can run. So it's the actual implementation which is going on there. For example, in the build process, in the build phase, I have a different goals like clean, install, package, deploy. These are the different typical goals which is available there, which I can execute into the Maven here. So these are the different goals like which we can execute and which we can run during a Maven build. Next question is, what is exactly meant by the term dependencies and the repositories in Maven here? So dependencies refer to the Java libraries which we usually put up into the pound.xml file there. Now what happens that sometimes our source code is requiring some jar files like a secondary jar files for performing the build process. So instead of downloading it and storing it into the class path for doing the build process, we just have to specify the dependency of that artifact, what dependency we need to put, and once that dependency is put up there, we will be able to have that jar file downloaded and cached into the local repository during the Maven build project. Now if the dependencies are not present in your local repository, then Maven will try to download it from the central repository, and again if it is not it's something which is available, which is downloaded from the central repository, then it will be cached locally into the local repository. So that's the cycle which is being implemented and utilized during this process. Now what exactly is a snapshot in Maven? So snapshot refers to the version already available in the Maven report repository. It signifies the latest development copy. That's what we do with the case of snapshot here. So Maven checks for a new version of snapshot in the remote repository for every new build. So during the build process, like a new snapshot version is being downloaded, and the snapshot is updated by the data service team, which with updated source code every time to the repository for each Maven build. So snapshot is something which we will be using like very frequently. We will be updating to that, and frequently we will be updating the version to that, and we will try to explore and we'll try to do the modifications. Now what are the different type of projects available in Maven? So there are thousands of Java projects which can be utilized or can be implemented by Maven here. So this helps the as the user that they no longer have to remember every configurations to set up particular project. For example, Spring Boot, Spring MVC, Spring Boot, etc. These are the different projects which is already available in Maven. So most of the we have already discussed that for the Java based projects, Maven is something which is considered as by default. So a lot of organizations are actually using it for storing or utilizing it for the particular Maven project. Now, what exactly is the Maven archetype over here? So Maven archetype refers to a Maven plugin that is entitled to create a project structure as per its template. These archetypes are just project templates that are generated by Maven when any new project is created there. So this is something which we are using so that we will be able to create a fresh new projects. Right, so let's go on to the advanced level of this Maven questions. Now, what exactly is the command to create a new project based on an archetype? So MVN archetype generate is used to create a new Java project based on the archetype. Now, this will take up some parameters from as an end user from you, and depending on that parameters, it will create the pom.xml file. It will create the source directories. Inside that, main, Java, test, all these different couple of directory structures will be automatically created. Now, why we require this command? So that if you are going to create a project from scratch from the day one, this command will help you to have all the folder structures created, and then further on you can put up your source code and those files as such in this folder structure. So that's how is the mechanism that we will be able to see that how the setup can be performed really over here. Now, what does Maven Clean implies? Now, Maven Clean is a plugin that suggests that it's going to clean the files and directories there. So whenever we do a build process, usually in the target directory we have some class files, some jar files, or whatever the generated source code which is available, that will be present in the target directory. So the Maven Clean is something which is available, which is going to clean all these directories. And why we are doing this directory structure cleanup? So that we will be able to do a fresh build process, and there should not be any kind of issues as such over here. So that's the main reason why we are looking forward for this particular mechanism or for this particular changes as such here. Now, so what exactly is a build profile all about? So build profiles refers to the set of configurations where we can have like typically two different kind of build processes there. So if you feel that the same pom.xml file you can you want to run for different particular configurations, so that you will be able to do pretty much with the help of this component. So build profile is used to do a customization processes so that you will be able to have the process, and you will be able to perform the configurations and the setups all together there. So that's a very important aspect to be considered, that which we need to discuss when we talk about the build profile. So build profile, whenever you feel that you want to do some customizations and you want to proceed with the setup, so that's where it's utilized. Next thing is that what are different type of build profiles which is available there. So the build profiles can be done on for a particular project, like per project you can do. You can even do the build profiles in the settings.xml file also, and if you feel that you want to do it into the global settings.xml file, so that also you can do as such over here. So there are different ways in which you can do the customization, and once the customization is done, you will be able to have the different ways of doing the setups and the configurations over there. So what exactly is meant by the particular system dependencies here? So let's talk about that also. So system dependencies refers to the particular mechanisms where we feel that how the dependencies should be present there. So that is something which is having a scope of system there. So these dependencies are commonly used to help Maven know the dependencies that is being provided by the JDK. System dependencies are mostly used to resolve the dependencies on the artifacts that are provided by the JDK. So these dependencies are somewhat which is being utilized and used over here, so that we will be able to implement and go ahead through the system dependencies. What is the reason for using an optional dependency here? So optional dependencies are used to decrease the transitive burden of some libraries. So what happens that when you download an artifact, when you put up a dependency, so it could be a possibility that some dependencies as in particular optional can also be downloaded. Now these are not always required, but yes, sometimes what happens that these are downloaded so that you don't have to put each and every artifact or dependency into the pom.xml file. For example, you're trying to download some Apache tool, and with that some like 3-4 jar files or 3-4 another dependencies are also getting downloaded. Now if you are using that dependencies, that totally great, because you don't have to put that list or that entry in the dependency list in the pom.xml file, and that can really save your time. But if you feel that you don't want to have them and these are the optional ones and you really want to get rid of that, so that also you can exclude while downloading any kind of dependency. So these are the optional ones which, depending on your requirement, you can utilize, you can process, and if you feel that you don't want to get it, you won't want to process it, you can simply ignore it and you can get rid of that also. Now, what is a dependency scope and how many type of dependency scope are there? So there are different type of dependency scopes which is there, which is used on each and every stage of the build here. So compile, provided, runtime, test, system, import. These are the different kind of dependency scopes which we have, using which we can define that when exactly we want to go ahead for a specific build process. So depending on your requirement, you can explore all these build scopes and you can get benefits out of that. What is exactly an intransitive dependency in Maven? So Maven avoids the need to find out and specify libraries that our own dependencies require by including the transitive dependencies automatically. So transitive dependencies says that if X depends on Y and Y depends on Z, then X depends on Y and both there. So which means that you are not dependent on one artifact, you also need the Z artifact there with the Y artifact. So that is what you need to do so that you will get both the dependencies there, because this is normal that if you are trying to download some particular artifacts or download some dependency and that dependency is also dependent on some other artifact or some other jar file, then you have to include both of them. So this is something which you will be able to get so that you can easily download all these dependent jar files also, and the Maven build can be success. How can a Maven build profile can be activated? So Maven build profile can be activated through different ways. So explicitly using the command line, you can talk about that which profile you want to execute. Through Maven settings, you can do based on environment parameters, OS settings, and present and missing files. So these are the different ways in which you can actually activate that which particular profile you want to have. So profiles configurations can also be saved in various situations and various files, and from there you will be able to refer that which file you want to refer as such. Now, what is meant by the dependency exclusion? The exclusion is used to exclude any transitive dependency, because you never know that if you are trying to put up a dependency entry in the .xml file, that artifact is also further dependent on another artifact. So in order to see that you want to exclude that dependent artifact which is being automatically downloaded, that also we can exclude with the help of exclusion. So you can avoid the transitive dependency with the help of dependency exclusions here. So what exactly is in Mojo? So Mojo is nothing but Maven plain old Java object here. So it's an executable goal in Maven, and a plugin refer to the distribution of such Mojos. So Mojos enable the Maven to extend its functionality that already is not founded in it. So it's kind of an extension which is there, and using this we can get some additional benefits and some executions over there. So what is the command to create a new project based on a hard drive? So again, archetype is something which we normally use to create the new projects. Now you can give the parameters in the command itself, or you want it to in kind of an interactive mode where it will take the parameters from the end user, and according to that the project will be created onto hard drive or onto server, wherever you wish you want to create, you can create a new project. So explain about the Maven settings.xml file. So Maven settings.xml file contains the elements that are used to define that how the Maven execution should be there. So there are different settings like local, remote, central, all these different repositories are configured as such over here. Now in this case, what happens that usually the configurations are done in such a way that it can go for the executions, it can go for the build process, and the complete executions can be involved and can be achieved as such here. So all these executions are something which we can really perform, and here we can put some credentials, how to connect to the remote repository, how to connect to remote repository. All that stuff is something which we talk about over here. What exactly is meant by term super POM here? So super POM refers to the default POM of Maven. So the POMs of Maven can derive from, so it's nothing but a reference to a parent POM which is available there, that is a super POM. So if you define some dependencies in that super POM, automatically the child POM will also be able to inherit all those dependencies. So we can put some executions, like we can put some configuration in the super POM, so that if multiple projects are going to refer that, they should be able to refer that easily. So that's the reason why we primarily use the super POM, so that we can have the execution, some processes put up over there, and all the other projects should be able to refer or inherit from there. So where exactly the dependencies are stored? So dependencies are stored like in different locations, like you have the local repository, remote repository is there, local repository is on the local developer's machine, and remote repository is something which is available on a server in form of Artifactory. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation, we have to download the Gradle executables, right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one, right? Now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is 2 environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle underscore home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd java version to check the version of the Java, and then the Gradle underscore version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it says that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system. And in this one we will be also working on some demos and some hands-on to understand that how we can make use of Gradle for performing the build activity. So let's begin with the first understanding that what exactly is in Gradle all about. Now Gradle is a kind of a build tool which can be used for the build automation performance, and it can be used for various programming languages. Primarily it's being used for the Java based applications. It's a kind of build tool which can help you to see that how exactly automatically you can prepare the builds, you can perform the automations. Earlier we used to do the build activity from the Eclipse, and we used to do it manually, right? But with the help of this build tool we are going to do it like automatically without any manual efforts as such here. There are like a lot of activities which we will be doing during the build process. Primarily there are different activities like compilations, linkage, packaging. These are the different tasks which we perform during the build process, so that we can understand that how the build can be done and we can perform the automations. This process also it's kind of standardized, because again if you want to automate something, standards or a standard process is something which we require for that before being going ahead with that part. So that's the reason why we are getting this build tool, because this build tool helps us to do a standardization process to see that how the standards can be met and how we can proceed further with that part. Also, it's something which can be used for a variety of languages, programming languages. Java is the primary language for which we use the Gradle, but again other languages like Scala, Android, C++, Groovy, these are some of the languages for which we can use the same tool. Now it's actually using like it's referring to as a Groovy based domain specific language rather than XML, because Ant and Maven, these are the XML based build tools, but this one is not that dependent on XML. It's using the Groovy based domain specific language. DSL language is being used here. Right now again it's something which can be used to do the build. It can further on be used to perform the test cases automations also there, and then further on you can deploy to the Artifactory also that okay I want to push the artifacts to the Artifactory, so that part also you can get it done over here. So primarily this tool is known for doing the build automations for the big and large projects, the projects in which the source code, the amount of source code and the efforts is more. So in that case this particular tool makes sense. Now Gradle includes both the pros of Maven and Ant, but it removes the drawbacks or whatever the issues which we face during these two build tools. So it's helping us to remove all the cons which we face during the implementation of Ant and Maven, and again all the pros of Ant and Maven is implemented with this Gradle tool. Now let's see that why exactly this Gradle is used, because that's a very valid question, that what is the activity, like what is the reason why we use the Gradle. Because the first one is that it resolves issues faced on other build tools. That's a primary reason, because we are already having the tools like Maven and Ant which is available there, but primarily this Gradle tool is something which is removing all the issues which we are facing with the implementation of other tools. So these issues are getting removed as such. Second one is that it focuses on maintainability, performance and flexibility. So it's giving the focus on that how exactly we can manage the big large projects, and we can have flexibility that what different kind of projects I want to build. Today I want to build in different ways, tomorrow the source code modifies, gets added up, so I have the flexibility that I can change this build scripts, I can perform the automations. So a lot of flexibility is available which is being supported by this tool. And then the last one is like it provides a lot of features, a lot of plugins. Now this is one of the benefit which we get in the case of Maven also, that we get a lot of features. But again, when we talk about Gradle, then it provides a lot of plugins. Like let's say that normally in a build process we do the compilation of the source code, but sometimes let's say that we want to build an Angular or a Node.js application. Now in that case we may be involved in running some command line executions, some command line commands, just to make sure that yes, we are running the commands and we are getting the output. So there are a lot of features which we can use, like there are a lot of plugins which is available there, and we will be using those plugins in order to go ahead and in order to execute those build process and doing the automations. Now let's talk about the Gradle and Maven, because again, when we talk about Maven, like it was like something which was primarily used for the Java, but again when we are talking about Gradle, so again it's just being used primarily for the Java here. But what is the reason that we prefer Gradle over the Maven? So what are the different reason for that? Let's talk about that part, because this is very important. We need to understand that what is the reason that Gradle is preferred as a better tool for the Java as compared to Maven when we talk about for the build automation here. Now the first one is that the Gradle using the Groovy DSL language, domain specific language, whereas the Maven is considered as a project management tool which is creating the POMs or XML format files. So it's being used for the Java project, but XML format is being used here. And on the other hand, Gradle is something which is not using the XML formats, and whatever the build scripts you are creating, that is something which is there in the Groovy based DSL language. And on the other hand, in the POM we have to create the XMLs, dependencies, whatever the attributes you are putting up in the Maven, that's something which is available there in the format of XML. The overall goal of the Gradle is to add functionality to a project, whereas the goal of the Maven is to to complete a project phase, like to work on different project phase, like compilation, test executions, then packaging, so then deploying to Artifactory. So these are all different phases which is available there into the Maven. But on the other hand, Gradle is all about adding the functionality, that how you want to have some particular features added up into the build scripts. In Gradle there are, like, we usually specify that what are the different tasks we want to manage. So different tasks we can add up into the case of Gradle, and we can override those tasks also. In case of Maven, it's all about the different phases which is being happening over here, and it's in sequence manner. So these phases happens in the sequence order, that how exactly you can build up the sequence there. But in case of Gradle, you can have your own tasks, custom tasks also, and you can disrupt the sequence, and you can see that how the different steps can be executed in a different order. So Maven is something which is a phase mechanism there, but Gradle is something which is according to the features or the flexibilities. Now Gradle works on the tasks, whatever the task you want to perform, it works directly on those tasks there. On the other hand, Maven is something does not have any kind of inbuilt cache, so every time you are running the build, so separate things or the plugins and all this information gets loaded up, which takes definitely a lot of time. On the other hand, Gradle is something which is using its own internal cache, so that it can make the builds a little bit faster, because it's not something which is doing the things from the scratch. Whatever the things is already being available in the cache, so it's just pick that part, and from there it will proceed further on the build automation. And that's the reason why Gradle performance is much faster as compared to Maven, because it uses some kind of a cache in there, and then helps to improve the overall performance. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation, we have to download the Gradle executables, right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the OpenJDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output at whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably, in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one. Right now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is two environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java -version to check the version of the Java, and then the Gradle_version is what you're going to see, that we check the version of the Gradle which is installed, and now you can see that it shows that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system. So let's go back to the content. Let's talk about the Gradle core concepts here. Now in this one we are going to talk about what are the different core concepts of Gradle are all about. The very first one is the projects here. Now a project represents an item to be performed over here, to be done, like deploying an application to a staging environment, performing some build. So Gradle is something which is required. The projects, the Gradle project which you prepare is not having multiple tasks which is available there, which is configured, and all these tasks, all these different tasks needs to be executed into a sequence. Now sequence is again a very important part, because again if the sequence is not met properly, then the execution will not be done in a proper order. So that's the very important aspect here. Tasks is the one in which is a kind of an entity in which we will be performing a series of steps. These tasks may be like compilation of a source code, preparing a jar file, preparing a web application archive file, or a ER file. Also we can have, like, in some tasks we can even publish our artifacts to the artifact tree, so that we can store those artifacts into a shared location. So there are different ways in which we can have these particular tasks executed. Now build scripts is the one in which we will be storing all this information. What are the dependencies, what are the different tasks we want to refer. It's all going to be present in the build.gradle file there. Build.gradle file will be having the information related to what are the different dependencies you want to download and you want to store there. So all these things will be a part of the build scripts. Now let's talk about the features of Gradle. What are the different features which we can use in case of Gradle here? There are different type of features which is available there. So let's talk about them one by one. So the very first one over here is the high performance. Then high performance is something which we can see that we already discussed, that in case you are using a large projects, so Gradle is something which is in better approach as compared to Maven because of the high performance which we are getting. It uses an internal cache which makes sure that you are using, like, you are doing the builds faster, and that can give you a higher performance over there. Second one is the support. It provides the support. So it, yes, definitely provides a lot of support on how you can perform the builds, and it's being a latest tool which is available there. So the support is also quite good in terms of how you want to prepare the build, how you want to download the plugins, different plugin supports, and the dependencies information also there. Next one is multi-project build software. So using this one you can have multiple projects. In case in your repository you have multiple projects here, so all of them can be easily built up with the help of this particular tool. So it supports multiple projects to be built up using the same Gradle project and Gradle scripts. So that support is also available with this Gradle build tool. Incremental builds are also something which you can do with the help of Gradle. So if you have done only the incremental changes and you want to perform only the incremental build, so that can also be possible with the help of a Gradle here. The build scans, so we can also perform the build scans. So we can use some integrations with SonarQube and all, where we can have the scans done to the source code, on understand on how the build happens or how the source code really happens on there. So that code scan or the build scans can also be performed with this one. And then it's a familiarity with Java. So for Java, it's something which is considered as an by default. Not even Java, in fact Android, which is also using the Java programming language, is using the particular Gradle over here, so that the build can be done and it can gain benefits out of that. So in all the manners, in all the different ways, it's basically helping us to see that how we can make sure that this tool can help us in providing a lot of features, and that can help us to make a reliable build tool for our Java based projects or any other programming based project here. Right, now let's see that how we can onboard a Java project with the Gradle here, and for that we have to go back, and Gradle is something which is already installed. We just have to create a directory where we can have, like, how we can perform some executions, we can prepare some build scripts, and we can have a particular execution of a Gradle build happened over there. So let's go back to the machine. Okay, so we are going to open the terminal here and we'll see that how we can create it. So first of all, I have to create a directory structure. Let's say that we'll say like Gradle -project. Now once the project is created, so we can go inside this directory. So to create some Gradle related projects and preparing the files. Now in this one, let's first create a particular one. So we will be saying like vi build.gradle. So in this one we are going to put like two plugins we are going to use. So we are going to say like apply plugin Java, and then we are going to say like apply plugin app application. So these two plugins we are going to use, and when we got this file over here in this one, so it shows like build.gradle, which is available there in this case. So two these files are available. Now if you want to learn like what are the different tasks, so you can run like gradle tasks command over there. So gradle task will help you know that what are the different tasks which is available over here by processing the build scripts and all. So this will definitely help you to understand on giving you the output. So here all the different tasks are being given, and it will help you to understand that what are the different tasks you can configure and you can work over here, just like jar files, clean and all that stuff, build, compile, then init is there, then all these different executions, assemble, then java dog, then build, then check, test, all these different tasks are there. And if you really want to run the Gradle build, so you can run like Gradle clean to perform the clean activity, because right now you are doing like a build, so before that you can have a clean, and then you can run a specific command, or you can run the Gradle clean build, which will perform the cleanup also, and it will at the same time will have the build process also performed over there. So build and cleanup both will be executed over here, and what is the status, whether it's a success or it's a failure, that will be given back to you. Now in this case, in the previous one, if you see that when you ran the Gradle clean, it was only running one task, but when you go for the build process, when you run the Gradle clean build, it's going to give you a much more information. In fact, you can also give me further information, like you can have the -info flag also there, so that if you want to get the details about the different tasks which is being executed over here, so that also you're going to get over here in this one. So you just have to put like -info, and then all these steps will be given back to you, that how these tasks will be executed and the response will be there. So that's a way that how you can create a pretty much simple straightforward project in form of Gradle, which can definitely help you to run some couple of Gradle commands, and then you can understand that what are the basic commands you can run and how the configurations really works on there, right? Let's go back to the main content. Right, now let's move on to the next one. So in the next one, we are going to see that how we can prepare a Gradle build project in case of Eclipse. Now we are not using the local system, we are not directly creating the folders and the files here. We are actually using the Eclipse for creating a new Gradle project over here. So let's move on that part. Okay, so now the Eclipse is open, and I have opened in this one. The very first thing is that we have to do the Gradle plugin installation so that we can create new projects on Gradle, and then we have to configure the path, that how the Gradle plugin can be configured on the preferences and all that stuff, and then we will be doing the build process. So the very first thing is that we have to go to the Eclipse marketplace. In there we have to search for Gradle. So once the search is done, it will show us the plugins related to Gradle. So we have to go for build ship Gradle integration. So we'll click on the install. It will proceed with installation. It will download it. In some cases, maybe it's part of the Eclipse as in the ID. So you can go to the installed tab and you can see that also, that if this plugin is already installed or not. But in this case, we are installing it. And once the installation is done, we just have to restart the specific ones. We have to restart this Eclipse so that the changes can be reflected. So it's downloading the Gradle here, and once that is installed, we will be able to use it over here in this case, in this scenario. So we have to just wait for that part. So still downloading the jar files. So once the jar file is done, it's now over the areas and downloaded. So after that, we will be able to proceed further on that download aspect. So it's going to take some time to download it, and once it's done, we will be able to proceed further. Now once the progress is done, so it's asking us for the restart now. So before that, we just have to click on restart now, and then the Eclipse will be restarted altogether again here. So you can do it manually, or you can go for that options. It just require a restart so that the new changes can be reflected over here. So the plugins can be activated and can be referenced here. Now we have to just put up like the the configuration where we can have the system. So we can go for the Gradle configuration. So we can go for Windows and then preferences. Now in this case, we have to go for the ones in which the Gradle option is available there. So Gradle is what we are going to select. Now user home, the Gradle user home is what we need to use, right? So you want to go for the Gradle, you want to go for local installation. So all these options you can use. You can, if you go for the Gradle wrapper, then it will be downloading the Gradle locally, and it is going to use the Gradle W or gradlew.bat file. But if you already have an installation locally, so you can prefer that also, right? Now in the previous demo we have already got the Gradle extracted, so we just have to go for the downloads. In the downloads already Gradle is available, so we are going to select that part here. So this is what we are going to select, right? So this represents that this is the directory structure in which we are having the mechanism. So you can either go for the build scan, so you can select the build scan also. So once this is enabled, then all the projects will be scanned and will be, you know, published, and it's in kind of additional option which is available. If you really want to disable it, you can disable it also, and you can go with this configuration also. So this is where the particular Gradle folder is being put over here in this case, and then we have to just click on apply, and we just have to click on apply and close. So with this one, the particular execution is done. Now we will be going for the project creation, so you can right click over here, or you can go to the file also. So here we are going to go for the job project, and in this we are going to have a Gradle project. So Gradle project is what we are going to create here. And next, so we are going to say like Gradle project, and then next. So once that is done, so finish. So with this one, when you create the project, so what will happen that automatically there will be a folder structure will be available there, right? And there are some Gradle scripts which will also be created there. So we will be doing the modifications to there, and we'll see that how the particular Gradle build script looks like, and how we will be adding some couple of Selenium related dependencies, and we'll see that how we can have more and more dependencies added, and what will be the impact of those dependencies on the overall project. So that also, it's very important aspect to be considered. So let this processing be happen over there. It's just creating, and some plugins and binaries are getting installed and getting downloaded. So we'll see that once the project is imported, completely executed over here and got created, we can extract that. Now if you see here, the particular option is available about the Gradle tasks, so you can extract it also, and you will be able to know that what are the different tasks which is available there. Let's see that in the build they are running like build. These are the different tasks which is happening inside the build process. So Gradle executions will be also available over here in this case, and Gradle tasks will be different. It will be represented over here in this one. So you just have to extract on the Gradle build project. Okay, so this is the library which is available. Now what happens that you will be able to have like settings.gradle. In this one you will be able to have like, okay, Gradle -project is something which is available there in this one, so that's what I'm being referring. Then we have over here as in these folder structures which is created like source, main, Java. This is the one, source, test, Java is the one which is available as in the folder structure, and source, test, resources are also available here. So the main, source, main, resources are also available. Now in this case, what happens that these are the dependencies, project and external, these are the different dependencies are available there. So let's see, let's add a dependency over here in this one in the build.gradle script, and see that how we can do that. If we open build.gradle file, so you can see that these dependencies are there, like test implementation, JUnit is available there, right? And then we have a implementations of this one which is available. Now these jar files, when you put up, it will automatically be added up as in part of this one, as in part of the particular dependencies over here, and which means that you don't have to store them as in within the repository, and automatically they can be happened over there. So let's open a dependency page. So we will be going to MVN repository, where we will be opening a dependency link. So this is the dependency link here. So Selenium-Java is available, and it can give you the dependency for all the different options. Now we have for Maven, this is the one, and for Gradle, this is the one here. So we have to just copy this one, and we have to use it as a dependency. So this is the group, and this is the name and the version which we are using here. Now we have copied this one, so we will go back to the Eclipse. So here we have to just put that dependency, and we have to just save it. So this is something which is providing like Selenium dependencies which is available. So now we have to just refresh the project. So right click over here, then you will be able to see the options in the Gradle saying that refresh Gradle project. Now once the moment you do that, so you will be able to do, like, for the first time maybe it will take some time to download all the dependencies which is related to Selenium, but after that you will be able to see like the dependencies will be simply added up over here in this case. So you can see that all the Selenium related dependencies are added up. For any reason, if you comment these ones and you say like synchronize again, so you will see that all the dependencies which you are adding up from this Selenium from the Selenium perspective will be gone back again. So this is the way that how you can keep on adding the dependencies which is required for preparing your build for your source code, and from there you will be able to proceed further on the execution part. So that's the best part about this Gradle here. So that's a way that how we are going to prepare a Gradle project within the Eclipse, and now you can keep on adding like the source code in this one, and that's the way that how the code base will be added up over here. Right, so that's the way that how the particular executions or this Gradle project is being prepared in case of Eclipse.
Selenium installation is a 3-step process, so it has certain prereqs. The first prereq is you need to have Java on your system. So we will be installing Java first, and then we will be working with Eclipse IDE. So we will be installing Eclipse, and then we will install Selenium. For Java, we will install the version Java 8. And for Eclipse, we have a version 4.10. This was the last stable version which was released in December last year. So I'll be using that version. And Selenium, we will download the latest 3.14 version. Okay, so let's get started with our first step, which is the Java installation. So to install Java, let's go to the browser and simply just search for Java 8 download. So now you will see that there is an Oracle site which is listed there, and that is where you would be downloading all your Java package. So go ahead and click on that. And for you to download any JDK package from the Oracle site, you need to create an account. So if you already have one, you just need to log in using that account, and then you can download any of the JDKs. And if you do not have one, please go ahead, create a new account on the Oracle, log into that account, and then you can just download the Java 8. So since I already have an account and I have already downloaded the package, but I'll show you how and where to download it from. So in this page, if you scroll down, so you will see this Java Development Kit 8.2.1.1. So this is the version we'll be downloading it. So click on the Accept License Agreement, and then since we are working on the Windows system today, so we will be downloading this, the Windows package. So just click on that and it will get downloaded in your downloaded folder. And as I said, I've already downloaded the packages. So here it is. What I've done is I've just created a directory called installers, and I'm going to be keeping all my installables here. So here I have a folder called Java installer, and this is where my installable is. So now that we have this file, so we will just go ahead, double click on it and launch this installer. The installer is launched, and just click on run. So this will take a few minutes to install Java. The installer is launched. Now just click on the next button here. So here for the installation directory, you can change the directory to the choice of whatever drive and the folder structure you want to. I would like to leave it as default here, and we'll just go and click on next, and then the Java installation is in progress. So let's wait until this is completed. It really shouldn't take too much time, maybe just a few more minutes here. Okay, accept the license term, just click on next. We'll leave the destination folder as it is. So JDK 8 is successfully installed on your system. So close the installer now, and let's go ahead and check whether the installation is done properly. So for that, what I'll do is I'll go to my command prompt and I'll just say Java minus version. So it says Java version 1.8, and this tells us that the Java is installed successfully. Now, after this installation, there are a couple of configurations which we need to do. And what are those configurations? One is you need to set the path variable, and then we are also going to set a Java home directory. So for that, first let's go ahead and check where is the Java installed actually. Let's figure out the directory first. So if you remember, the directory structure where the Java got installed was in program files, Java. There are certain previous versions which I had installed and then uninstalled it. So that is why you see some residuals here sitting here. Let's not worry too much about that. Instead, let me go to the latest one what I have installed, which is this. Okay, and there is a bin folder here. And this is the path which we need to set in our path variable. So what I will do is I'll just copy this path and then go to your control panel. Here, go to your, where is my system? Yeah, so click on the system, go to Advanced System Setting, and here in the environment variables, find the path variable, okay, and then say edit. Now, what are we doing here in the path variable is we are going to add the Java bin directory to the path. Be very careful whenever you're editing your path variable. Do not overwrite anything. Always go into the edit mode, go towards the end here, and then just say Ctrl V, paste the path which you have just copied from the Explorer window. That's it. Now just say OK, done. So your path setting is done. So what's the next one we need to do? We need to add a new environment variable called the Java home. Now what I'll do for that is I'll just say new. I'll just type Java home here. And what is the value of this we need to set? We need to set the same path but without the bin directory. So we just need to set the path till your Java directory. That is this. So we'll just copy the path again and paste it here. That is all. Just say OK, click on OK, click on OK here, and we are done. So again, let's go to our command prompt and just say Java -version. So everything seems to be fine. So now successfully we have installed Java on the system. So what is our next installation step what we have? Now we need to install the Eclipse. So let's go back to the browser again. So to download Eclipse, we will be downloading the package from the eclipse.org. So when you go here to eclipse.org, you can see the latest version which is available. And the latest version available when this video was made was 2019-06. So especially with Eclipse, since it's an open source, I prefer to work with the last stable version, and so does most of the developers too. And hence that is the reason why I have picked up the version which is like last year's version, which is 4.10, which was released in last December. So you can always choose to go with the latest version, but then if there are any issues and if you're like first time working with the Eclipse, you're going to get confused as where these issues are coming from, right? So I would still recommend that you use the last stable version which is available with your Eclipse. So now to get the last stable version, what you need to do is go and click on this download packages. And here, if you scroll down this page, you can see here more downloads. So there is a list of all the previous releases of Eclipse which is available, and this is what we need to download. So just click on that 4.10 version and then click on the OS on which you want to install Eclipse. For us it is Windows, so I'll just click here on the 64-bit Windows and then click on the download, and you will be downloading the complete package. So once you download, this is what it will look like. So let's go back to our directory of installers. So this is the installer for the Eclipse which I got. Now what's the next step I need to do? Just launch this installer and install Eclipse. So I'll just say double click on this. I'll say run. So here you'll see multiple options here for Eclipse installation. So depending on your requirement, you can go ahead and install any of these packages. So for us, we just need an Eclipse ID for Java developers. So I'll select this and I'll say install. So again, you'll have a choice of directory where you want to install. So I have chosen D drive here. This is the default directory name it takes, which is okay. We can leave it as it is. And then also you have an option to create a start menu entry and desktop shortcut. So just leave the default selection as it is and go ahead and click on install. So this will take a while to install the Eclipse. This says select all. You can close this window. This says select all and accept it. Okay, so the installation has been completed successfully. So let's go and click on this launch and let's see the first window what opens. When you launch the Eclipse, you need to specify a workspace directory here. Now what is this workspace directory? So this is a directory or a folder wherein all the Java files or any programs or any artifacts which you're going to create through Eclipse will be stored in this particular folder. So this could be any location on your system. So this is, you can go ahead, browse the location and change it. So for in our case, what we will do is I'll go to the D drive and I already have a directory. So here I'll just select this folder and then create a folder called workspace. I'll say my workspace and then I'll say launch. So every time I open the Eclipse, right? So this is going to take as my default workspace, and all my programs, all my Java scripts or my automation scripts are going to be stored in this particular location. So we'll say launch. So this is a welcome window which opens. We can just close this. And there we go. The Eclipse is open with a certain perspective. So there are certain windows here which we do not need. Let's just close them. So now the first thing what you do after launching the Eclipse is go ahead and create a new project. So I'll say file, new, and since I'm going to be using Java with Selenium, I'll say create Java project. So give a project name. Let's say my first project. Now you have an option here to select the JRE which you want to use. So we just installed this JDK 1.8 Okay, so I'm going to click on use default JRE. Otherwise, you also have an option to use a project specific JRE. For example, I could have two different projects where one project I'm going to be working with JRE 1.8 and there is another project which I want to work with the latest Java, maybe Java 12. And I can have more than one Java installed on the machine. So this gives me an option to select whichever Java I want to work with. So if you have another Java installed here, it will show up in this list. So and you can just go ahead and select that. Now since we have only one Java installed on our machine, which is Java 1.8, I will say use default JRE, which is 1.8, and I will click on finish. Now if you observe this folder structure, the project which is created, see all the reference libraries to this particular Java have been created here. Now we are ready to create any kind of Java programs in this project. So now we have successfully done the second step of our installation, which is the Eclipse installation. After this, we need to install the Selenium now. So again, let's go back to the browser and see what files we need to download to install Selenium. So let me go to my browser, and here I will be going to the seleniumhq.org. So if you're working with Selenium, this particular website, the seleniumhq.org, is going to be a Bible. Everything and anything related to Selenium is available in this website. Whether you want to download the files, whether you want to refer to the documentation, anything regarding to Selenium is available here. So what we want now is the installables for Selenium. So here, go to the download tab. Now, for you to install Selenium and start working with Selenium, there are three things which are required for you to download. One is a standalone Selenium server. So this is not required immediately when you get started with Selenium. However, when you start working with remote Selenium WebDriver, you would be requiring this. When you have a grid setup, you will be requiring the standalone server. So for that, what you can do is you can just download the latest version available here. So when you click on that, it will download the file into your download folder. So this is one particular file which you need to keep. Next, Selenium client and WebDriver language bindings. Now in today's demo, we will be looking at Selenium with Java. So that means my client package of Java is what I need to download. So whatever programming language Selenium supports, we have respective downloadables available with that. Say if you're working with Python, then you need to download your client library for Python. And since we are working with Java, you need to download this package. So simply what you need to do, click on this link and it will download the Java package for you, which are basically the jar files. So we have client libraries now, and then there is another component what we need. Now with Selenium, you're going to be automating your web browser applications, correct? And you also want your applications to run on multiple browsers. So that means your scripts, the automation scripts which you create, should be able to run on any browser. Selenium works with multiple browsers like Edge, Safari, Chrome, Firefox, and other browsers. Even it has a support for headless browser. Now every browser which it supports comes with its own driver files. Now say for example, we want to say work with Firefox driver. So that means for us to start working with Firefox browser, we need to download something called as a Gecko driver here. And if you want to work with Chrome browser, you need to install the Chrome driver. So depending on what browsers you'll be testing with, go ahead, click on each of this link and download the latest driver files. Now, since we are going to be working with Firefox in this demo, what I need to do is I just need to click here on the latest link. So when I click on the latest link, it is going to take me to this driver files. So driver files are specific to each of the operating system. So if you go down here, you will see there is a separate driver file available for Linux, for Mac, and for Windows. So depending on which operating system where you'll be running your test, download that particular driver file. And this is the driver file I need because we are working on Windows machine. So these are the three different packages which we need to download from the seleniumhq.org for us to install Selenium. So let me show you the folder where I have already downloaded all this. So if you see here, Selenium Java 3.141.59. Okay, this is nothing but our client library, which we saw here. Let's go back to the main page here. That is this. So once I download this, this is a zip file. After I unzip the file, this is the folder structure I see. And let's see what is there in this folder structure. So there are two jar files here. And then in the libs, there are multiple jar files. And we will need all this to work with Selenium. And then we also downloaded the driver files. So what I did was, after downloading those driver files for the browser, I created a directory here called drivers. And I've kept all my browser drivers here. So I have a driver file downloaded for Chrome. I want to work with Firefox, so I have a Gecko driver here, and then for Internet Explorer. That's it. So this is all we need. So once we have all this, what you need to do is go to your Eclipse. In the Eclipse, right click on the project which you have created, and then go to the build path and say configure build path. Go to the libraries tab here. Now, do you see this JRE libraries here? This is what got installed first. And now similarly, we are going to add the Selenium jars to this library. And how do we add that? On your right, you can see this add external jars. Click on add external jars. Go to your folder where you have downloaded your Selenium, which is this. Select all the jar files which is available. So I have 2 jar files here. I'll just say click open. Again, I will click on add external jars. Now from the libs folder, I will select all this 5. So select all the 5 jars and click on open. So you should see all the 7 jar files here. So once you have this, just say apply and close. Now, if you look into your project directory here, you will see a folder called referenced library. And this is where you will see all the Selenium jars here. This is a very simple installation. In Eclipse, when you want to install Selenium, you just need to export all the jars of the Selenium into Eclipse. And now your system is ready to start working with Selenium scripts. Alright, so now let's just test our installation by writing a small Selenium test script. So for that, what I will do is, I'll go to the source folder, right click, new, and I'll say Java class. So let's name this as, say, first Selenium test, and I will select this public static void main and I will click on finish. Alright, so now let's create a use case. Say we want to launch a Firefox browser and then we want to launch the Amazon site. So these will be just 2 simple things which we will be doing in this test scripts. So for me to do that, what I usually do is I create a method for any functionality which I want to create here. So now I want to do a launch browser. So I'll create a method here called launch browser. Now, whenever you start writing your Selenium scripts, the first line what you need to do is you need to declare an object of WebDriver class. So here I'll say WebDriver driver. So now if you hover over this error, what it is showing, it says import WebDriver from org.openqa.selenium. So if you remember, when we installed the Selenium, we imported all these jars, right? So that means whenever we want to use a WebDriver, we need to import this class from these packages. So just go ahead and click on this import state. Done. Now next step. Now for us to launch a Firefox browser, it is a 2-steps process which is involved here. One is you need to set the system property and then you need to launch the driver. So let's do that. I'll say system.setProperty. So use this method setProperty. So this takes 2 arguments, the key and the value pair. Now what is the key I'm going to mention here? I'm going to be mentioning the Gecko driver and the path for the Gecko driver. Okay, because since I'm working with the Firefox. So in double quotes, I'll say webdriver.gecko.driver. This is my key. And the value is going to be, the fully qualified path for your driver files. And you know where we have kept our driver files. Let's go to that. Driver files in D:, I have Selenium tutorial. In installers, I have driver folder. Okay, so I'm just going to copy the complete path from here. Control C, and I paste it here. Control V. Along with this, I need to provide the file name for the Gecko driver, which is geckodriver.exe. And let's complete this step. Next. So once I've set the property, I need to provide a command for launching my Firefox driver. And how do I do that? I simply use this driver object which I've created, driver equal to new Firefox driver. Again, similarly, the way we imported packages for WebDriver, we also need to import the package for Firefox driver. So just hover the mouse over that and select import Firefox driver. With these 2 statements, we will be able to launch the Firefox browser. And as I said in our use case, what is the next thing we want to do? We want to launch, say, Amazon.in website. For that, there is a command in Selenium which says driver.get and you pass the URL here. So for me to write the URL, what I usually do is I go to my browser, I open the website which I want to work with. In our case, it's Amazon.in, and I just simply copy this fully formed URL, go to my Eclipse and just paste it here. Now this ensures that I don't make any mistakes in typing out the URL. Let's complete this statement and we are done. And now in the main function, I'll just create an object of this and we will call this method. So I'll copy this class, first Selenium test, say obj equal to new first Selenium test. And now I'll say obj dot, this is our function, launch browser. So let's save this and execute this. Control C, right click, run as Java application. Okay, so the Mozilla Firefox has been launched. Now it should launch your Amazon.in. Bingo. So there goes our first test script which ran successfully. Before you start understanding any automation tool, it's good to look back into what manual testing is all about, what are its challenges, and how automation tool overcomes these challenges. Challenges are always overcome by inventing something new. So let's see how Selenium came into existence and how did it evolve to become one of the most popular web application automation tool. Selenium suite of tools. Selenium is not a single tool. It has multiple components. So we will look into each of them. And as you know, every automation tool has its own advantages and limitations. So we will be looking at what the advantages are and the limitations of Selenium and how do we work around those limitations. Alright, so let's get started. Manual testing. A definition, if you can say, a manual testing involves the physical execution of test cases against various applications and to do what? To detect bugs and errors in your product. It is one of the primitive methods of testing a software. This was the only method which we knew of earlier. It is execution of test cases without using any automation tools. It does not require the knowledge of a testing tool, obviously because everything is done manually. Also, you can practically test any application since you are doing a manual testing. So let's take an example. So say we have a use case. You are testing, say, a Facebook application. And in Facebook application, let's open the Facebook application and say create an account. This is your web page which is under test now. Now as a tester, what would you do? You would write multiple test cases to test each of the functionalities on this page. You will use multiple data sets to test each of these fields like the first name, the surname, mobile number or the new password. And you will also test multiple links. What are the different links on this page, like say forgotten account or create a new page. So these are the multiple links available on the web pages. Also, you look at each and every element of the web page, like your radio buttons, like your drop down list. Apart from this, you would do an accessibility testing. You would do a performance testing for this page or say a response time after you say click on the login button. Literally, you can do any type of tests manually. Once you have these test cases ready, what do? You start executing these test cases one by one. You will find bugs, your developers are going to fix them, and you will need to rerun all these test cases one by one again until all the bugs are fixed and your application is ready to ship. Now, if one has to run test cases with hundreds of transactions or the data sets and repeat them, can you imagine the amount of effort required in that? Now that brings us to the first demerit of the manual testing. Manual testing is a very time consuming process and it is very boring. Also, it is very highly error prone. Why? Because it is done manually and human mistakes are bound to happen. Since it's a manual execution, testers' presence is required all the time. One needs to keep doing manual steps, step by step again all the time. He also has to create manual reports, group them, format them so that we get good looking reports. Also send these reports manually to all stakeholders. Then collection of logs from various machines where you have run your test, consolidating all of them, creating repositories and maintaining them. And again, since it's all is a manual process, there is a high chance of creating manual errors there. Scope of manual testing is limited. For example, let's say regression testing. Ideally, you would want to run all the test cases which you have written. But since it's a manual process, you would not have the luxury of time to execute all of them. And hence, you will pick and choose your test cases to execute. That way, you're limiting the scope of testing. Also, working with large amount of data manually is impractical, which could be the need of your application. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on application under test, and hence manually performing these kind of tests is not feasible. And to top it all up, say if you're working in an agile model where code is being churned out by developers, testers are building their test and they're executing them as and when the builds are available for testing. And this happens iteratively. And hence, you will need to run this test multiple times during your development cycle. And doing this manually definitely becomes very tedious and boring. And is this the effective way of doing it? Not at all. So what do? We automate it. So this tells us why we automate. 1, for faster execution. 2, to be less error prone. And 3, the main reason is to help frequent execution of our test. So there are many tools available in the market today for automation. One such tool is Selenium. Birth of Selenium. Much before Selenium, there were various tools in the market, like say RFT and QTP, just to name a few popular ones. Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks and he was working on a web application which needed frequent testing. He realized the inefficiency in manually testing this web application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and he named it as JavaScript Test Runner. Later, he made this open source, and this was renamed as the Selenium Core. And this is how Selenium came into existence. And since then, Selenium has become one of the most powerful tools for testing web applications. So how does Selenium help? So we saw all the demerits of manual testing. So we can say by automation of test cases, one, Selenium helps in speedy execution of test cases. Since manual execution is avoided, the results are more accurate, no human errors. Since your test cases are automated, human resources required to execute automated test cases is far less than manual testing. Because of that, there is a lesser investment in human resources. It saves time, and time is money. It's cost effective as Selenium is an open source. It is available free of cost. Early time to market. Since you save effort and time on manual execution, your clients will be merrier as you would be able to ship your product pretty fast. Lastly, since your test cases are automated, you can rerun them any point of time and as many times as required. So if this tool offers so many benefits, we definitely want to know more detail about what Selenium is. Selenium enables us to test web applications on all kinds of browsers like Internet Explorer, Chrome, Firefox, Safari, Edge, Opera, and even the headless browser. Selenium is an open source and it is platform independent. The biggest reason why people are preferring this tool is because it is free of cost. And the QTP and the RFT, which we talked about, are chargeable. Selenium is a set of tools and libraries to facilitate the automation of web application. As I said, it is not a single tool. It has multiple components, which we'll be seeing in detail in some time. And all these tools together help us test the web application. You can run Selenium scripts on any platform. It is platform independent. Why? Because it is primarily developed in JavaScript. It's very common for manual testers not to have in-depth programming knowledge. So Selenium has this record and replay back tool called the Selenium ID, which can be used to create a set of actions as a script, and you can replay the script back. However, this is mainly used for demo purposes only, because Selenium is such a powerful tool that you should be able to take full advantage of all its features. Selenium provides support for different programming languages like Java, Python, C#, Ruby. So you can write your test scripts in any language you like. One need not know in-depth or advanced knowledge of these languages. Also, Selenium supports different operating systems. It has supports for Windows, Macs, Linux, even Ubuntu as well. So you can run your Selenium test on any platform of your choice. And hence, Selenium is the most popular and widely used automation tools for automating your web applications. Selenium set of tools. So let's go a little more deeper into Selenium. As I said, Selenium is not a single tool. It is a suite of tools. So let's look at some of the major components or the tools in Selenium and what they have to offer. So Selenium has 4 major components. 1. Selenium ID. It's the most simplest tool in the suite of Selenium. It is integrated development environment. Earlier, Selenium IDE was available only as a Firefox plugin, and it offered a simple record and playback functionality. It is a very simple to use tool, but it's mainly used for prototyping and not used for creating automation in the real-time projects because it has its own limitations like any other record and replay tool. Selenium RC. This is nothing but Selenium remote control. It is used to write web application tests in different programming language. What it does, it basically interacts with the browser with the help of something called as RC server. And how it interacts is it uses a simple HTTP post GET request for communication. This was also called as Selenium 1.0 version, but it got deprecated in Selenium 2.0 version and was completely removed in 3.0, and it was replaced by WebDriver. And we will see in detail as why this happened. Selenium WebDriver. This is the most important component in the Selenium suite. It is a programming interface to create and execute test cases. It is obviously the successor of the Selenium RC, which we talked about, because of certain drawbacks which RC had. So what WebDriver does is it interacts with the browsers directly, unlike RC, where the RC required a server to interact with the browser. And the last component is the Selenium Grid. So Selenium Grid is used to run multiple test scripts on multiple machines at the same time. So it helps you in achieving parallel execution. Since the Selenium WebDriver you can only do sequential execution, Grid is what comes into picture where you can do your parallel execution. And why is parallel execution important? Because in real-time environment, you always have the need to run test cases in a distributed environment. And that is what Grid helps you to achieve. So all this together helps us to create robust web application test automation. And we will go in detail about each of these components. So before that, let's look at the history of Selenium version. So what did Selenium version comprised of? It had an IDE, RC and Grid. And as I said earlier, there were some disadvantages of using RC. So RC was on its path of deprecation and WebDriver was taking its birth. So if you look at Selenium 2 version, it had an earlier version of WebDriver and also the RC. So they coexisted. From 3. onwards, RC was completely removed and WebDriver took its place. There is also a 4. version around the corner and it has more features and enhancements. Some of the features which are talked about are W3C WebDriver standardization, improved IDE and improved Grid. Now let's look at each of the components in the Selenium suite. Selenium IDE is the most simplest tool in the suite of Selenium. It is nothing but an integrated development environment for creating your automation scripts. It has a record and playback functionality and is a very simple and easy to use tool. It is available as a Firefox plugin and a Chrome extension. So you can use either of this browser to record your test scripts. It's a very simple user interface using which you can create your scripts that interact with your browser. The commands created in the scripts are called Selenice commands and they can be exported to the supported programming language and hence this code can be reused. However, this is mainly used for prototyping and not used for creating automation for your real-time projects. Why? Because of its own limitation which any other record and replay tool has. So a bit history of Selenium IDE. So earlier Selenium IDE was only a Firefox extension. So we saw that IDE was available since the Selenium version 1. Selenium IDE died with the Firefox version 55. That was, IDE was stopped supporting from 55 version onwards. And this was around 2017 timeframe. However, very recently, all new brand Selenium IDE has been launched by Apply Tools. And also they have made it a cross-browser. So you can install the extension on Chrome as well as an add-on on Firefox browser. So they completely revamped this IDE code and now they have made it available on the GitHub under the Apache 2.0 license. And for the demos today, we'll be looking at the new IDE. Now with this new IDE also comes a good amount of features. Reusability of test cases, better debugger, and most importantly, it supports parallel test case execution. So they have introduced a utility called Selenium Side Runner that allows you to run your test cases on any browser. So you can create your automation using IDE say on Chrome or Firefox, but through command prompt, using your Side Runner, you can execute these test cases on any browser, thus by achieving your cross-browser testing. Control flow statement. So initially in the previous versions of IDE, there were control flow statements available. However, one had to install a plugin to use them. But now it is made available out of box. And what are these control flow statements? These are nothing but your if-else conditions, the while loops, the switch case, and so on. It also has an improved locator functionality. That means it provides a failover mechanism for locating elements on your web page. So let's look at how this IDE looks and how do we install it and start working on that. So for that, let me take you to my browser. So say, let's go to the Firefox browser. So on this browser, I already have the IDE installed. So when you already have an IDE installed, you will see an icon here which says Selenium IDE. And how do you install this? You simply need to go to your Firefox add-ons. Here, where it says find more extension, so just type in Selenium IDE and search for this extension. So in the search results, you see this Selenium IDE, just click on that. And now since I've already installed, here it says remove. Otherwise, for you, it is going to give you an add button here. Just click on the add button. It will install this extension. Once it is installed, you should be able to see this Selenium IDE icon here. Okay, so now let's go ahead and launch this IDE. So when I click on that, it is going to show me a welcome page where it's going to give me a few options. The first option is it says record a new test case in a new project. So straight away, if you choose this option, you can start recording a test case. In which case, it's going to just create a default project for you, which you can save it later. Then open an existing project. So you can open, if you've already have a saved project. Create a new project and close. So I already have an existing project with me for the demo purpose. So I'll go ahead and open that. So I'll say open existing project, and I have created a simple script. What the script does is it logs me into the Facebook using a dummy username and password. That's all. It's a very simple script with few lines, and this is what it's going to do. So what we will simply do is we'll just run the script and see how it works. For that, I'm just going to reduce the test execution speed so that you should be able to see every step of execution here. Alright, so what I'll do now here is I'll just adjust this window and I'll just simply say run current test. Alright, so I'll just get this side by side so that you should be able to see what exactly the script is doing. Okay, so now you are able to see both the windows. Okay, so now it's going to type in your user email here. There you go. And now it will enter the password and it has clicked on the login button. So it's going to take a while to say login, and since these are the dummy IDs, you are not able to log in here and you're going to see this error window. Fine, that is what is the expected output here. Now on the ID, if you look here, after I execute the test case, every statement or every command which I have used here is color coded in green. So that means this particular step was executed successfully. And then here in the log window, it will give you a complete log of this test case, right from the first step till the end. And your end result is, it says FB login, which is my test case name, completed successfully. Let's look at few components of this ID. The first one is the menu bar. So let's go to our ID. Alright, so the menu bar is right here on the top. So here is your project name. So either you can add a new project here or rename your project. So since we already have this project, which is named as Facebook. And then on the right, you have options to create a new project, open an existing project, or save the current project. And then comes our toolbar. So using the options in this toolbar, you can control the execution of your test cases. So first one here is the recording button. So this is what you use when you start recording your script. And then on the left, you have two options here to run your test cases. The first one is run all tests. So in case you have multiple test cases written here, you can execute them one by one sequentially by using this run all test. Else, what you can do is if you just want to run your current test, this is what you would use. Then ID has this debugger option, which you can use to do a step execution. So say for example, now whenever I run the scripts, it's going to execute each and every command here sequentially. So instead, if I just select the first command and say do step execution, alright, so what it does is the moment it finishes the first command, which is opening of Facebook, right? I think which is already done here. Yeah. Alright, so once this is done, it is going to wait immediately on the second command and it says paused debugger. So from here, you can do whatever you would like to do. In case you want to change the command here, you can do that. You can pause your execution, you can resume your execution here, right? You can even completely stop your test execution, or you can just select this to run the rest of the test case. So if we say run the test case, what it is going to do is it's just going to simply go ahead and complete the test case. Now, there is another option here, which is, you see the timer there, which says test execution speed. So to execute your test cases in the speed you want. Say whenever you're developing an automation script, right, and say you want to give a demo. So you need to control the speed sometimes so that the viewer is able to exactly see all the steps which is being performed. And this gives you an option to control that complete execution, right? So do you see the grading here? So we have somewhere from fast to completely slow execution. So the previous demo which I showed was I controlled the speed and then I executed it so that we could see every command how it is being executed. Alright, so what's the next? This is called as an address bar. So whenever you enter an URL here, that is where you want to conduct your test. And another thing what it does is it keeps a history of all the URLs which you have used for running your test. Then here is where your script is recorded. So each and every instruction is displayed here in the order in which you have recorded the script. And then if you look here, you have something called as log and reference. So now log is an area where it records each and every step of your command as in when they get executed. Right? So if you see here, it says open https facebook.com and OK. So that means this command was executed successfully. And after the complete test case is done, it gives you whether the test case passed or failed. So in case there is a failure, you'll immediately see this test case is failed in red color. Also, there is something called as reference here. For example, say if I click on any of this command The reference tab, what it is going to show me is details of this command which I have used in the script. It gives you the details of the command as well as what the arguments have been used, or how is that you need to be using this particular command. Okay, so now what we'll do is let's go ahead and write a simple script using this IDE. So with this you'll get an idea as how do we actually record scripts in IDE. So for that I have a use case here, a very simple use case. So what we will do is we will open amazon.in, then we'll simply search for say product iPhone. And once we get that search page where all your iPhones are displayed, we will just do an assert on the title of the page. Simple. Alright, so let's do that. So first thing what I need is an URL. Okay, so first let me go to my Firefox browser here and say amazon.in. So why I'm doing this, just to simply get the right URL, absolute URL path here, and so that I don't make any mistakes while typing in the URL. Okay, so I got this. So let me close all these windows. I don't need any of this. Let's minimize this. Alright, so here what I will do, in the tests tab, I'll say add a new test and name this test as Amazon search. Done. I'll say add. Now I'll enter this URL which I just copied it from my browser. Okay, and then I'll just say start recording. So what it did was, since I've entered the URL in this address box, it just opened the amazon.in URL. Now let's do our test case. So in my test case, what I said was I want to search for iPhone. Once I have this, I'm just going to click on my search button. So now this gives me a list of all iPhones. And then I said I want to add an assertion on the title of this page. So for me to do that, what IDE gives me an option is I have to just right click anywhere on this page and you'll see the Selenium IDE options here. So in this, I will select assert title and then I will close this browser. So that kind of completes my test case. So now take a look at all the steps which is created for me. So it says open / because I've already provided the URL here. So either you can replace it with your regular URL or you can just leave it as it is. So what I will do, since this is going to be a proper script and I might be using this to run it from my command prompt also. So I'll just replace this target with the actual URL. And then what it is doing, it is setting a window size. Then there are whatever I did on that particular URL on that website, it has recorded all the steps for me. So this is where it says type into this particular text box, which is my search box, and what did it type? iPhone. This was the value which I entered. Now there was one more feature which I told you in this new IDE, which I said it has a failover mechanism for your locating techniques. Now that is what this is. Now if you look here, this IDE is equal to tab search text box. This is nothing but that search box where we entered the text iPhone. And it has certain identification through which this IDE identifies that web element. And that has multiple options to select that particular search box. So right now what it has used is ID is equal to 2-tab search box. However, if you know the different locating techniques, you will be able to see here that it has other techniques also which it has identified, like the name and the CSS and the XPath. So how does this help in failover is, say tomorrow if amazon.in website changes the ID of this element, right? You are not going to come and rewrite the scripts again. Instead, by using the same script, what it will do is, if this particular ID fails, if it is unable to find the element using the first locator, which is the ID, it simply moves to the next available ones and it tries to search for that element until one of these becomes true. That is what was the failure mechanism which has got added now. It's a very brilliant feature because most of our test cases break because of element location techniques. Well, let's come back to this. So then we added an assert title, right? So what is assert title here? It simply captures the title of that particular page and it checks. This is all. A very simple test case. So what we will do now is, we will stop the recording and then I've also given a close browser. So right now what I will do is, I'll just comment this out. Why? Because if I just run this test case, it's going to be very fast and you might not be able to catch the exact command execution what has happened. Alright, so right now I'll just disable it, so that it will just do all these test cases and it just stays there without closing the browser. So now I'll just say run the current test case. So your Amazon in is launched. Okay, it is typed in the iPhone. It's also clicked on the search. So it is done. So now if you look here, since we are in the reference tab, it is not able to show. So let's go to the log. And now let's see the log. So it's going to be a running log. So if you notice here, the previous examples which we have run for Facebook is also in the same log. So we will have to see the log from running Amazon search because that's our test case. So if you see here, every command line right? It was executed successfully. Assert title was also done and your test case was executed successfully, so it passed. Now what we will do is on this assert title, I'll just modify this and let's say just add some text. I'll just add double S here. Now this, by intentionally, I'm going to fail this test case just to show you that whenever there is a test case failure, how does the IDE behaves and how do you get to know the failures. Alright, so I'll just run the test case again. So before that, let's close the previous window. Alright, done. And now here I'll also uncomment the close, because anyway it's a failure which I'm going to see, which I should be able to see it in the logs. So I'll close the browser after the execution of test case. Okay, so let's simply go and run the test case. Okay, Amazon.in is launched. It should search for iPhone now. Yeah, there you go. Alright, now it should also close the browser. Yes, it has closed the browser and it has failed. Now see here. Now this is the line where our command failed. Why? Because the expected title was not there. And if you look in the logs, it says your assert title on Amazon.in failed. Actual result was something different and it did not match with what we had asked it for. So this is how simple it is to use your IDE to create your automation scripts. So we saw all the components of IDE. We saw the record button, then I showed you the toolbar, I showed you the editor box and also the test execution log. So now let's come to what are the limitations of this IDE. With IDE, you cannot export your scripts, your test scripts to WebDriver scripts. This support is not yet added, but it is in the works. Data-driven testing, like using your Excel files or reading data from the CSV files and passing it to the script, this capability is still not available. Also, you cannot connect to database for reading your test data or perform any kind of database testing. With Selenium WebDriver, yes, you can. Also, unlike Selenium WebDriver, you do not have a good reporting mechanism with the IDE, like say for example, TestNG or ReportNG. So that brings us to the next component of the suite, which is Selenium RC, Selenium Remote Control. So Selenium RC was developed by Paul Hammond. He refactored the code which was developed by Jason and was credited with Jason as a co-creator of Selenium. Selenium Server is written in Java. It is used to write web application tests in different programming languages, as it supports multiple programming languages like your Java, C#, Perl, Python and Ruby. It interacts with the browser with the help of an RC server. So this RC server uses a simple HTTP GET and POST request for communication. And as I said earlier also, Selenium RC was called as Selenium 1.0 version. But it got deprecated in Selenium 2.0 and was completely removed in 3.0, and it got replaced by what? WebDriver. And we'll see why this happened and what was that issue which we had with the RC server. So this is the architecture of Selenium Remote Control at a very high level. So when Jason Huggins introduced Selenium, you know the tool was called as JavaScript program. And then that was also called as a Selenium core. So every HTML has a JavaScript statements which are executed by web browser, and there is a JavaScript engine which helps in executing this command. Now this RC had one major issue. Now what was that issue? Say for example, you have a test script, say test.javascript here, which you are trying to access elements from anywhere from the google.com domain. So what used to happen is every element which is accessible are the elements which can belong only to google.com domain. Like say for example, mail, the search or the drive. So any elements from this can be accessible through your test scripts. However, nothing outside the domain of say google.com in this case was accessible. Say for example, if your test scripts wanted to access something from yahoo.com, this was not possible. And this is due to the security reasons, obviously. Now to overcome that, the testers, what they had to do was they had to install the Selenium core and the web server, which contained your web application which is under test on the same machine. And imagine if you have to do this for every machine which is under test. This is not going to be feasible or even effective all the time. And this issue is called as a same origin policy. Now what a same origin policy issue says is, it prohibits a JavaScript from accessing elements or interacting with scripts from a domain different from where it is launched. And this is purely for the security measure. So if you have written a scripts which can access your google.com or anything related to google.com, these scripts cannot access any elements outside the domain. Like as we said in the example, yahoo.com. This was the same origin policy. Now
To overcome this, what this gentleman did was he created something called as Selenium Remote Control Server to trick the browser in believing that your core, your Selenium core and your web application under test are from the same domain. And this is what was the Selenium Remote Control. So if you look at again a high level architecture, or how did this actually work? First you write your test scripts, which is here, right, in any of the supported language like your PHP or your Java or Python. And before we start testing, we need to launch this RC server, which is a separate application. So this Selenium server is responsible for receiving the Selenium commands. And these Selenium commands are the ones which you have written in your script. It interprets them and reports the result back to your test. So all that is done through your RC server. The browser interaction, which happens through RC server, right, from here to your browser. So this happens through a simple HTTP and post and get request. And that is how your RC server and your browser communicate. And how exactly this communication happens? This RC server, it acts like a proxy. So say your test scripts asks to launch a browser. So what happens is this commands goes to your server, and then your RC server launches the browser. It injects the JavaScript into the browser. Once this is done, all the subsequent calls from your test script, right, from your test scripts to your browser goes through your RC. And now upon receiving these instructions, your Selenium core executes these actual commands as JavaScript commands on the browser. And then the test results are displayed back from your browser to your RC to your test scripts. So the same cycle gets repeated, right, until the complete test case execution is over. So for every command what you write in your JavaScript here or your test script here goes through a complete cycle of going through the RC server to the browser, collecting the results again from the RC server back to your test scripts. So this cycle gets repeated for every command until your complete test execution is done. So RC had definitely a lot of shortcomings, and what are those? So RC server needs to be installed before running any test scripts, which we just saw. So that was an additional setup since it acts as a mediator between your commands, which is your Selenium commands, and your browser. The architecture of RC is complicated. Why? Because of its intermediate RC server, which is required to communicate with the browser. The execution of commands takes very long. It is slower. We know why, because every command in this takes a full trip from the test script to your RC server, to the core engine, to the browser, and then back to the same route, which makes your overall test execution very slow. Lastly, the APIs supported by RC are very redundant and confusing. So RC does have a good number of APIs. However, it is less object oriented. So they are redundant and confusing. Say for example, say if you want to write into a text box, how and when to use a type key command or just a type command is always confusing. Another example is some of the mouse commands, using a click or a mouse down. Both kind of, almost providing a similar functionality. So that is the kind of confusion which developers used to create. Hence, Selenium RC got deprecated and is no more available in latest Selenium versions. It is obsolete now. Now to overcome these shortfalls, WebDriver was introduced. So while RC was introduced in 2004, WebDriver was introduced by Simon Stewart in 2006. It's a cross-platform testing platform, so WebDriver can run on any platform like say Linux, Windows, Mac, or even if you have a Ubuntu machine, you can run your Selenium scripts on this machine. It is a programming interface to run test cases. It is not an IDE. And how does this work actually? So test cases are created and executed using web elements or objects using the object locator and the WebDriver methods. So when I do a demo, you will understand what these WebDriver methods are and how do we locate the web elements on the web page. It does not require a core engine like RC. So it is pretty fast. Why? Because WebDriver interacts directly with the browser and it does not have that intermediate server like the RC had. So each browser, in this case, what happens is each browser has its own driver on which the application runs. And this driver is responsible to make the browser understand the commands which you will be passing from the script. Like say for example, click of a button or you want to enter some text. So through your script, you tell which browser you want to work with, say Chrome, and then the Chrome driver is responsible for interpreting your instructions and to execute it on the web application launched on the Chrome browser. So like RC, WebDriver also supports multiple programming languages in which you can write your test scripts. So another advantage of WebDriver is it supports various frameworks like TestNG, JUnit, NUnit and ReportNG. So when we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. So let's look at the architecture of WebDriver at a high level. What is in WebDriver? So WebDriver consists of 4 major components. The first one is we have got client libraries, right? Or what we also call it as language bindings. So since Selenium supports multiple languages and you're free to use any of the supported languages to create your automation script, these libraries are made available on your Selenium website, which you need to download and then write your scripts accordingly. So let's go and see from where do we download this. So if I go to my browser, so seleniumhq.org, right? So if you're working with Selenium, this website is your Bible. So anything and everything you need to know about Selenium, right? You need to come here and use all the tabs here in this website. So right now what we are going to look at is what are those language bindings. So for that, I'll have to go to this download tab here, okay? And if you scroll down here, you will see something like Selenium client and WebDriver language bindings. And for each of the supported language of Selenium, you have a download link, right? So say for example, if you're working with Java here, what you need to do is you need to download your Java language binding. So let's go back to the presentation. So this is where your language bindings are available. Next, so Selenium provides lots of APIs for us to interact with the browser. And when we do the demo, I'll be showing you some of these APIs, right? And these are nothing but the REST APIs. And everything, whatever we do through the script happens through the REST calls. Then we have a JSON wire protocol. What is JSON? JavaScript Object Notation. It is nothing but a standard for exchanging data over the web. So for example, you want to say launch a web application through your script. So what Selenium does it creates a JSON payload and posts the request to the browser driver. That is here. And then we have this browser drivers themselves. And as I said, there is a specific driver for each browser. As you know, every tool has its own limitation. So does Selenium. So let's look at what these limitations are and if there are any workarounds for them. Cannot test mobile applications requires framework like APM. Selenium is for automating web application. It cannot handle mobile applications. Mobile applications are a little different and they need its own set of automation tools. However, what Selenium provides is a support for integrating this APM tool, which is nothing but a mobile application automation tool. And using APM and Selenium, you can still achieve mobile application automation. And when do you usually need this? When your application under test is also supported on mobile devices, you would want a mechanism to run the same test cases on web browser as well as your mobile browsers, right? So this is how you achieve it. The next limitation, so when we talked about the components of Selenium, I said that with WebDriver, we can achieve only sequential execution. However, in real-time scenario, we cannot just live with this. We need to have a mechanism to run our test cases parallelly on multiple machines as well as on multiple browsers. So though this is a limitation of WebDriver, but what Selenium offers is something called as grid, which helps us achieve this. And we will see in shortly what the Selenium grid is all about. Also, if you want to know more details as how do we work with the grid, how do you want to install that grid, so do check out our video on Simplilearn website on Selenium grid. Third limitation, so limited reporting capability. So Selenium WebDriver has a limited reporting capability. It can create basic reports, but what we definitely need is a more. So it does support some tools like say TestNG, ReportNG and even extent reports, which you can integrate with Selenium and generate beautiful reports. Powerful, isn't it? Also, there are other challenges with Selenium, like Selenium is not very good with image testing, especially for the ones which are designed for web application automation. But then we have other tools which can be used along with Selenium like AutoIt and Securely. So if you look at all this, Selenium still provides a complete solution for your automation needs. And that's the beauty of Selenium, and that is why it makes the most popular tool of today for automation. Okay, let's do a quick comparison between the Selenium RC and the WebDriver. So RC has a very complex architecture. You know why? Because of the additional RC server. Whereas due to direct interaction with the browser, WebDriver architecture is pretty simple. Execution speed. It is slower in RC and much faster in WebDriver. Why? Because in WebDriver we have eliminated that complete layer of Selenium server, right? That the RC server, and we established a direct communication with the browser through browser drivers. It requires an RC server to interact with the browsers. We just talked about it, and whereas WebDriver can directly interact with the browser. So RC, again, we talked about this as one of the limitations, that we have a lot of redundant APIs, which kept developers guessing as which API to use for what functionality. However, WebDriver offers pretty clean APIs to work with. RC did not offer any support for headless browser, whereas in WebDriver, you do have a support for using headless browsers. Let's see the WebDriver in action now. Now for the demo, we will use this particular use case. And what this use case says is, navigate to the official Simplilearn website, then type the Selenium in search bar and click on it, and click on the Selenium 3.0 training. So we are basically searching for Selenium 3.0 training on the Simplilearn website. First, let's do the steps manually, and then we will go ahead and write the automation script. So let's go to my browser. On my browser, what I'll do is, let me first launch the Simplilearn website. Okay, and here what my use case step says is, I need to search for Selenium and click on the search button. So once I do that, it is going to give me a complete list of all kind of Selenium trainings which is available with Simplilearn. And what I'm interested in is the Selenium 3.0 training here. Once I find this on the web page, I need to go and click on that. Alright. So this is all the steps which we are going to perform in this use case. Okay. Now, so for writing the test cases, I'll be using an IDE which is Eclipse. I've already installed my Eclipse, and also I have installed Selenium in this instance of my Eclipse. Alright, so if you can see the reference library folder here, you will see all the jars which are required for the Selenium to work. Next, another prereq which is required for Selenium, and that is your driver files. Now, every browser which you want to work with has its own driver file to execute your Selenium scripts. And since for this demo, I'll be working with the Firefox browser, I will need a driver file for Firefox. Now, driver file for Firefox is the Gecko driver, which I have already downloaded and placed in my folder called drivers. Now, where did I download this from? Let's go ahead and see that. So if I go back to my browser, and if you go to your seleniumhq.website, you have to go to this download tab here. In the download tab, when you scroll down, you will see something like third-party drivers, bindings, and plugins. In this, you will see the list of all the browsers which is supported by Selenium. And against each of this browser, you will find a link which has the driver files. Now, since we'll be using the Gecko driver, this is the link where you need to go to, and depending on which operating system which you're working on, you need to download that particular file. Now, since I'm working on Mac, this is the file which I'm using. If you're a Windows user, you need to download this zip file and unzip it. So once you unzip that, you would get a file called Gecko driver for your Firefox, or a Chrome driver for your Chrome browser. And then what you do is, you just create a directory called drivers under your project and just place the driver files here. So these are the two prereqs for your Selenium. One is importing your jar files like this, and then having your drivers downloaded and keep them under a folder where you can reference to. Okay, so now we'll go ahead and create a class. I already have a package created in this project, so I'll use this project and create a new class. So I'll say create new Java class, and let's call this as search training. I'll be using a public static void main, and I'll click on finish. So let's remove this auto generated lines as we do not need them. Alright, now the first statement which you need to write before even you start writing the rest of your code is, what you need to do is, you need to define or declare your driver variable using your class WebDriver. So what I would do is, I'll say WebDriver driver. Done. Alright. Now you will see that this IDE is going to flash some errors for you. That means it is going to ask you to import certain libraries which is required by the WebDriver. So simply just go ahead and say import WebDriver from org.opensq.selenium. This is the package which we will need. Alright. So you have a driver created which is of the class WebDriver. And now after this, I'm going to create three methods. Alright. So first method I will have for
launching the Firefox browser. Okay, and then I will write a simple method for searching Selenium training and clicking on it. This is the actual use case what we'll be doing. And then third method I'm going to write is just to close the browser which I'm going to be opening, right? So these are the different methods which I'll be creating, and from the public static void main I will just call these methods one after the other. Okay, so let's go ahead and write the first method. Now my first method is launching the Firefox browser. So I'll say public void, since my return type is null or there is no return type for this, let's call it as launch browser. Okay, all right. Now in this, for launching any browser, I need to mention two steps. Now the first step is where I need to do a system.set property. Okay, let's do that first and then I'll explain what this does. I'll just say system.set property. So this accepts a key and a value pair. So what is my key here? My key here is webdriver.gecko.driver, and I need to provide a value. So value is nothing but the path to the Gecko driver. And we know that this Gecko driver which I'm going to use here is right here in the same project path under the drivers folder, correct? And that is what the path which I'm going to provide here. So here simply I need to say drivers/Gecko driver. Gecko. All right, done. And let me close this sentence. All right. Now, since I'm a Mac user, my Gecko driver installable is just the name Gecko driver. If you're a Windows user and if you're running your Selenium scripts on the Windows machine, you need to provide a complete path to this, including .exe, because driver executable on your machines is going to be gecko driver.exe. All right. So just make sure that your path which you mentioned here in the system.set property is the correct path. Okay. Then the next thing what we need to do is I need to just say driver is equal to new Firefox driver. Okay, so this command new Firefox driver creates an instance of the Firefox browser. Now this is also flagging me error. Why? Because again it's going to ask me to import the packages where the Firefox driver class is present. Okay, we did that. Now these two lines are responsible for launching the Firefox browser form. So this is done. So what's my next step in the use case? Now I need to launch the website Simplilearn. So for that we have a command called driver.get. Driver.get, what it does is whatever URL you're going to give it here in this double quotes as an argument, it is going to launch that particular website. And for us, it's a Simplilearn website. So what I do as a best practice is instead of typing out the URL, I go to my browser, launch that URL which I want to test, and I simply copy it. Come back to your Eclipse and just simply paste it. So this ensures that I do not make any mistakes in the URL. Okay, so done. So our first method is ready where we are launching the browser, which is our Firefox browser, and then launching the Simplilearn website. Now the next method. What is my next method? In my next method, I need to give the search string to search Selenium training on this particular website. Now for that we need to do few things. What are those few things? Let's go to the website again. All right, so let me relaunch this. Let's close this. Okay, let me remove all this and let's go to the home page first. Okay, this is my home page. So as you saw when I did a manual testing of this, I entered the text here. So now since I have to write a script for this, first I need to identify what this element is. For that, what I'm going to do is I'm just going to say right click here and I'll say inspect element. Alright, now this element, let's see what attribute it has which I can use for finding this element. So I see that there is an ID present. So what I'm going to do is I'm just going to simply use this ID and then I'll just copy this ID from here. Go back to Eclipse. Let's write a method first. So I'll say public void, and what do we give the method name? Say search training or just search. All right. Now in this, I need to use a command called driver.findElement by ID is what I'm going to use as a locating technique. And in double quotes, the ID which I copied from the website is what I'm going to paste here. Okay. And then what am I going to do on this element is I need to send that text, the text which I'm going to search for, which is Selenium. So I'll just say send keys, and whatever text I want to send, I need to give it in double quotes. So for that, Selenium. So this is done. So now I've entered the text here, and after entering the text, I need to click on this button. So for that, I need to first know what that button is. So let's inspect that search button. Okay. Now if you look at the search button, other than the tag which is span and the class name, I do not have anything here. Alright, so what I can do is I can either use the class name or I can write an XPath. Since this is a demo which we have already used ID locating technique, I would go ahead and use the XPath here. So for me to construct an XPath, I will copy this class first. Okay, and then I already have a CrowPath installed on my Firefox, so I'll use the CrowPath and first test my XPath. So I'll just say /, let's see what was that element. It has a span tag. Okay, so I'll have to use span and at class equal to, and I'll just copy the class name here, and let's see if it can identify that element. Yeah, so it is able to identify. So I'll just use this XPath in my code. So I'll go back to Eclipse and I'll say driver dot find element by dot XPath, and the XPath which I just copied from CrowPath is what I'm going to paste here. And what is the action I need to do here? I need to say click. Done. So I have reached a stage where I have entered this Selenium. Okay, and then I have clicked on the search button. Once I do this, I know that expected result is I should be able to find this particular link here, Selenium 3.0 training. Okay, and I should be able to click on that. So for that, again, I need to inspect this. So let's inspect this Selenium 3.0. Alright, so now what are the elements this has? Now this particular element has attributes like it has a tag h2, then it has got some class name and some other attributes. So I would like to use a XPath here. Now this time while using the XPath, I'm going to make use of a text functionality so that I can search for this particular text. So I'll simply copy this. I'll go to my CrowPath. The tag is h2. So I'll say simply h2. Okay, and here I'll say text equal to, and this is the text which I copied. I missed out that yes there, so I'm just going to add an s. Okay, so let's first test here whether it is able to identify that element. Yeah, so it is able to identify. So can you see here blue dotted line? It is able to show us which element it is identified. So I'll copy this XPath now and let's go to my IDE Eclipse. So now here what I need to do is I'll have to again simply say driver dot find element by dot XPath and paste the XPath which we just did, and then again I have to do a click operation. Done. Alright, so technically we have taken all the steps of the use case and we have written the commands for that. Alright, now let's add an additional thing here. Say after coming to this page, after finding this, we want to say print the title of this page. Now what is the title of this page? If you just hover your mouse on this, it says online and classroom training for professional certification courses Simplilearn. So what I will do is after doing all these operations, I will just print out this page title on our console. So for that I have to just do this driver dot so let's do a sysout. So I'll say sysout system.out.println. Okay, and here I would say let's add a text here. The page title is, and then let's append it with driver dot get title. So this is the command which we'll be using to fetch the page title. Done. Now what is the last method I need to add? Just to close the browser. Alright, so let me add a method here. I'll say public void close browser, and it's a one single command which I need to call. I'll say driver dot quit. Okay, and then I need to call all these methods from my public static void main. So let me use my class name, which is this. So I'm going to create an object obj is equal to new class name, and then using this object, first is I need to call the method launch browser, and then I'll call the method search, right, and then I'll call the method close browser. Done. So technically our script is ready with all the functionality which we wanted to cover from our use case. Now there are few other tweaks which I need to do this, and I'll tell you why I need to do this. Now for example, after we click here, right, after we click on the search, if you observed on your website, it took a little while before it listed out all the Selenium trainings for us. And usually when you're actually doing it, you wait for the Selenium 3.0 training to be available and then you click on that. Now same thing, you also need to tell your scripts to do that. You need to tell your scripts to wait for a while until you start seeing the Selenium 3.0 training or it appears on your web page. There are multiple ways to do that in your script, and it is a part of overall synchronization, what we call, where we use kind of implicit and explicit kind of ways. Now since this is a demo, for demo purpose, what I'm going to do is I'm going to use a command called thread.sleep, and I'm just going to give an explicit wait of say 3 seconds. So you can use this mainly for the demo purposes. You can use a thread.sleep command. Now, this thread.sleep command needs us to handle some exceptions. So I'm just going to click on add throws declaration and say interrupted exception. Now same thing, I'll have to do it in my main function also. Okay, so let's do that and complete it. All right, so this is done. So by doing this, what am I doing? I'm ensuring that before I click on the Selenium 3.training, we are giving enough time for the script to wait until the web page shows this link to the Selenium 3.0 training. That's one thing I'm doing. All right, and also now since you're going to be seeing this demo through the video recording, the script when it starts running, it is going to be very fast. So you might just miss out seeing how it does the send keys and how did it click on the search button. For us to enable us to see it properly, I'll just add some explicit waits here just for our demo purpose. So after entering the keys, right? So what I'll do is I'll just give a simple thread.sleep here. Okay, so probably a 3 seconds or a 2 seconds wait should be good enough. Okay, a 3 seconds wait should be good enough here so that we should be able to see how exactly this works on your browser when we execute this. Okay, now our complete script is ready. So what I'll do is I'll just save the script and then we will simply run the script. So to run the script, I'll just say right click, run as Java application. Okay, it says asks me to select and save. I've saved the script now. So let's observe how it runs. Okay, the Simplilearn.com, the website is launched. So the Selenium text has been entered in the search box. It has clicked on the search. Okay, all right. So now it did everything whatever we wanted it to do. All right. So since we are closing the browser, you were unable to see whether the Selenium 3.training was selected or not. However, what I have given here is to fetch the title after all these operations were complete. And if you see here, the complete operations was done and we were able to see the page title here. Okay. So now what I'll do, since we are unable to see whether it clicked on the Selenium 3.0 training or not, I'll just comment out the close browser, the command. Okay. So we will not call the close browser so that the browser remains open and we get to see whether did it really find the training link or not. Okay. So let me close this window. We don't need this Firefox window. Close all tabs and then I'll just re-execute this script. So I'll say run as Java application. So save the file. Okay, Simplilearn.com is launched. So search text is entered. Now it's going to click on the search button. Yes. All right. So we've got the search results. It should click on Selenium 3.0 training and yes, it is successfully able to click on that. All right. So now it's not going to close the browser because we have commented on that line. However, it did print us the title here. All right. So this is a simple way of using the Selenium scripts. Selenium Grid. So Grid is used to run multiple test scripts on multiple machines at the same time. With WebDriver, you can only do sequential execution, but in real-time environment, you always have the need to run test cases in distributed environment. And that is where Selenium Grid comes into picture. So Grid was conceptualized and developed by Patrick. The main objective is to minimize test execution time. And how? By running your test parallelly. So design is in such a way that commands are distributed on multiple machines where you want to run test and all these are executed simultaneously. What do you achieve by this methodology? Of course, the parallel execution on different browsers and operating systems. Grid is pretty flexible and can integrate with many tools. Like say you want a reporting tool integrated to pull all the reports from the multiple machines where you're running your test cases and you want to present that report in a good looking format. So you have an option to integrate such report. Okay, so how does this Grid work? So Grid has a hub and node concept which helps in achieving the parallel execution. Let's take an example. Say your application supports all browsers and most of the operating systems. Like as in this picture, you could say one of them is a Windows machine, one of them is a Mac machine and another one is say a Linux machine. So your requirement is to run the test on all supported browsers and operating systems, like the one which is depicted in this picture. So what you have to do is, first thing is you configure a master machine or what you also call it as a hub by running something called a Selenium standalone server. And this standalone server can be downloaded from the Selenium HQ website. Using this server, you create a hub configuration, that is this node. And then you create nodes specific to your machine requirement. And how are these nodes created? You again use the same server, which is your standalone Selenium server, to create the node configuration.
So I'll show you where the Selenium server can be downloaded. So if we go back to our Selenium HQ website, so you can see here right on the top it says Selenium standalone server.
Welcome everyone to our another demo on which we are going to see that how exactly we can do the installation of Docker on the Windows platform, specifically on Windows 10. Now Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands we can do the installation, but in the case of Windows you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows 10 particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the Edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the Edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular Edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the Edge there. So you just have to double click on the installer and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory to the downloads and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on okay. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line and any Docker command if you can run. So that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed, so you can run like Docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part.
So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I just opened the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. You just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install docker. So snap install docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker hub. So Docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state.
In this presentation, we're going to go through a number of key things. We're going to compare Docker versus traditional virtual machines and what are the differences and why you'd want to choose Docker over a virtual environment. We'll go through the advantages of working with Docker and the structure and how you would build out a Docker environment. And during that structure, we'll dig through the components and the advanced components within Docker. At the end of the presentation, we'll go through some basic commands and then show you how those basic commands can be used in a live demo. So with all that said, let's get started. So let's first of all compare Docker with a traditional virtual machine. So here we have the architecture on the left and right of a traditional virtual machine versus a Docker environment. And there are some things that you'll probably see immediately that are big differences. One is that the virtual environment has hypervisor layer, whereas the Docker environment has a Docker engine layer. And then in addition to that, there are additional layers within the virtual machine. Each of these really start compounding and creating very significant differences between a Docker environment and a virtual machine environment. So with a virtual machine, the actual memory usage is very high, whereas with a Docker environment, the memory usage is very low. If we look at performance, virtual machines, when you start building out particularly more than one virtual machine on a server, the performance starts degrading and starts getting poorer, whereas with Docker, the performance always stays really good. And this is largely due to the lightweight architecture used to construct the Docker containers themselves. If we look at portability, virtual machines just are terrible for portability. They're still dependent on the host operating system, and there's just a lot of problems that happen when you are using virtual machines for portability. In contrast, Docker was designed for portability, so you can actually build solutions in a Docker container environment and have the guarantee that the solution will work as you have built it, no matter where it's hosted. Finally, boot up time. The boot up time for a virtual machine is fairly slow in comparison to the boot up time for a Docker environment, which is almost instantaneous. So we look at these in a little bit more detail. One of the other challenges that you have with a virtual machine is that if you have unused memory within the environment, you cannot reallocate that memory. So if you set up an environment that has 9 gigs of memory that's being used, but you have 6 gigs that are free, you can't do anything with it. Though that whole 9 gig has been allocated to that virtual machine. In contrast with Docker, if you have 9 gigs and 6 gigs becomes free, that free memory can then be reallocated and reused across other containers used within that Docker environment. Another challenge is running multiple virtual machines in a single environment can lead to instability and performance issues, whereas Docker is designed to run multiple containers in the same environment and actually gets better the more containers you run in that hosted single Docker engine. Portability issues with a virtual machine is the software can work on one machine, but then when you move that VM to another machine, suddenly some of the software won't work because there are some dependencies that haven't been inherited correctly. Whereas Docker itself is designed specifically to be able to run across multiple environments and to be deployed very easily across systems. And again, the actual boot up time for a VM, it just takes a long time. You're talking about minutes in contrast to the milliseconds that it takes for a Docker environment to boot up. So let's dig into what Docker actually is and what allows for these great performance improvements over a traditional VM environment. So Docker itself is an OS virtualized software platform, and it allows IT organizations to really easily create, deploy, and run applications as what are called Docker containers that have all of the dependencies within that container very easily. And the container itself is really just a very lightweight package that has all the instructions and dependencies such as frameworks, libraries, bins, etc., all within that container. And that container itself can then be moved from environment to environment very easily. If we to look in our DevOps lifecycle, the place where Docker really shines is in deployment, because when you're actually at the point of deploying your solution, you want to be able to guarantee that the code that has been tested will actually work in the production environment. But in addition to that, what we often find is that when you're actually building the code and you're actually testing the code, having a container running the solution at those stages is also a really good plus, because what happens is that the people building the code and testing the code are able to validate their work in the same environment that would be used for the production environment. So really, you can use Docker in multiple stages within your DevOps cycle, but it becomes really valuable in the deployment stage. So let's look at some of the key advantages that you have with Docker. Some of the things that we've already covered is that you can do rapid deployment, and you can do it really fast. The environment itself is highly portable and was designed for that in mind. The efficiencies that you'll see will allow you to run multiple Docker containers in a single environment as compared to more traditional VM environments. The configuration itself can be scripted through a language called YAML, which allows you to be able to write out and describe the Docker environment that you want to create. This in turn allows you to be able to scale your environment very, very quickly. But with all of these advantages, probably the one that is most critical to the type of work that we're doing today is security. You have to ensure that the environment you are running is a highly secure but highly scalable environment. And I'm very pleased to say that Docker takes security very seriously. So you'll see it as one of the key tenets for the actual architecture of the system that you're implementing. So let's look at how Docker actually works within your environment. So Docker works, there is what's called a Docker engine. The Docker engine is really comprised of two key elements. You have a server and a client, and the communication via the two is via a REST API. The server, as you can imagine, has the instructions that are communicated out to the client and instructs the client on what to do. The connection between the client and the server, the communication, is via a REST API. On older systems, you can take advantage of the Docker toolbox, which allows you to go ahead and control the Docker engine, the Docker machine, Docker Compose, and Kitematic. So let's now go into what the actual root components, though, of Docker are. So let's have a look at those key components. There are 4 components that we're going to go through. We have the Docker client and server, we have Docker images, we have the Docker registry, and the Docker container. We're going to step through each of these one by one. So let's look at the Docker client and server first. So the Docker client and server is a command line instructed solution where you would use terminal on your Mac or command line on your PC or Linux system to be able to issue commands from the Docker daemon. The communication between the Docker client and the Docker host is via a REST API. So you can do similar communication such as a Docker pull command, which would send an instruction to the daemon, which would then form the interaction of pulling in the correct components, such as an image or container or registry, to the Docker client. The Docker daemon itself is actually a service which actually performs all sorts of operating and performance services. And as you'd imagine, the Docker daemon is constantly listening across the REST API to see if it needs to perform any specific requests. If you want to trigger and start the whole process, what you want to do is use the command dockered within your Docker daemon, and that will start all of your performances. And then you have a Docker host, which actually runs the Docker daemon and registry itself. So now let's look into the actual structure of a Docker image. So a Docker image itself is a template which contains instructions for the Docker container, and that template is written with a language called YAML, and YAML stands for yet another markup language. It's very easy to learn. The Docker image itself is built within that YAML file and then hosted as a file in the Docker registry. The image is really comprised of several key layers. And you start with your base layer, which will typically have your base image. In this instance, it's your base operating system, such as Ubuntu. And then you then have layer of dependencies above that. This would then comprise the instructions in a read-only file that would become your Docker file. So let's actually go through and look at what one of those sets of instructions would look like. So here we have 4 layers of instructions. We have a from, pull, run, and then command. So what does that actually look like in our layers? So to break this down, the from creates a layer which is based on Ubuntu. And then what we're doing is we're adding in files from the Docker repository onto that base command, that base layer. And then what we want to be able to do is then say, okay, what are the run commands so we can actually then build the container within the environment. And then we want to be able to then have a command line that actually executes something within that container. And in this instance, the command is to run Python. So one of the things that we will see is that as we set up multiple containers, each new container is a new layer with new images within the Docker environment. Each container is completely separate from the other containers within your Docker environment. So you're able to create your own separate read-write instructions within each layer. What's interesting is that if you delete a layer, then the layer above it will also get deleted. So what happens when you pull in a layer, but something has changed in the core image? What's interesting then is that the actual main image of itself cannot be modified. Once you've copied the image, you can then modify it locally, but you can never modify the actual base image itself. So here are some callouts for the components within a Docker image. So the base layer are in read-only format. The layers can be combined in a union file system to create a single image. The union file system saves memory space by avoiding duplication of files. And this allows a file system to appear as a writable, but without modifying the file, which is known as a copy on write. The actual base layers themselves are read-only. So to be able to get around this structure within a Docker container, the Docker environment itself uses what's known as a copy on write strategy within the images and the containers themselves. And so what this allows you to do is you can actually copy the files for better efficiency across your entire container environment. The copy and write strategy does make Docker super efficient, and what you're able to do all the time is keep reducing the amount of disk space you're using and the amount of performance that you're taking from the server. And that's really, again, a key element for Docker, is just this constant ability to be able to keep improving the efficiency within the actual system itself. All right, so let's go on to item number 3, which is the Docker registry. So the Docker registry itself is the place where you would host and distribute the different types of images that you have created or you want to be used within your environment. The actual repository itself is just a collection of Docker images, and those Docker images are built on instructions that you would write with YAML and are very easily stored and shared. And what you can actually do is you can actually associate specific name tags to the actual Docker images themselves. So it's easy for people to be able to find and share that image within the Docker registry itself. One of the things you actually see as we go through the demos, you actually see us actually using the tag name, and you'll see how it is an alphanumeric identifier and how we actually use it to actually create the actual container itself. One of the things you can do to as start off how you would manage a registry is you can actually use the publicly accessible Docker Hub registry, which is available to anybody, but you can also create your own registry for your own use internally. The actual registry that you create internally can have both public and private images that you create, and this may be for various reasons of how you structure your environment. The actual commands you would use to actually connect to the registry are both push and pull. Push is to actually push a new container environment that you've created from your local manager node to the remote registry, and a pull allows you to pull a new client that has been created and is being shared. So again, pull command, it pulls and retrieves a Docker image from the Docker registry, and makes it very easy for people to share different images consistently across teams. And a push command allows you to take a new command that you've created, a new container that you've created, and push it to the registry, whether it's Docker Hub or whether it's your own private registry, and allow it to be shared across your teams. Some key did you knows in Docker registry: deleting a repository is not a reversible action. So if you delete a repository, it's gone. So let's go into the final stage here, which is the actual Docker container itself. So the Docker container itself is an executable package of applications and its dependencies bundled together. So it gives all the instructions that you would have for the solution that you're looking to run. It's actually really lightweight, and again, this is because of the redundancy that's built into how you structure the container, and the container itself is then inherently also extremely portable. What's really good about running a container, though, is that it does run completely in isolation. So you're able to share it very easily from group to group, and you are guaranteed that even if you are running a container, it's not going to be impacted by any host OS peculiarities or unique setups as you would have in a VM or a non-containerized environment. The actual memory that you have on a Docker environment, they can be shared across multiple containers, which is really useful. Typically, when you have a VM, you would have a defined amount of memory for each VM environment. The challenge you start running into, though, is that you can't share that memory, whereas with Docker, you can easily share the memory for a single environment across multiple containers. The actual container is built using Docker images, and the command to actually run those images is a run command. So let's actually go through a basic structure of how you would run a Docker image. So you go into terminal window and you would write in Docker run Redis, and then it would run a container called Redis. So we're going to go in, and if you don't have the Redis image locally installed, it will then pull it from the registry. Then the new Docker container Redis will be then available within your environment, so you can actually start using it. So let's look at why containers are so lightweight. They're so lightweight because they really have been able to get away from some of the additional layers that you have in virtualization within VMs. And the biggest one is the hypervisor and the need to run on a host operating system. Those are two big elements. So if you can get rid of those, then you're doing great. So let's look at some of the more advanced concepts within the Docker environment. And we're going to look at two advanced components. One is Docker Compose, and the second is Docker Swarm. So let's look at Docker Compose. Docker Compose is really designed for running multiple containers as a single service. And it does this by running each container in isolation, but allowing the containers to interact with each other. As was stated earlier on, you would actually write the Compose environment using YAML as the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node, and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you'd use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker, and it'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have the, if we wanted to pull specifically from Docker Hub, then we would have docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build -t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we have outlined in the presentation for Docker. The first is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already, and we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker, and actually we don't want to do image, we want to select pull, and then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to go ahead and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded, so we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded, but we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 :80 :80, and then we'll put in MySQL latest, so we have the latest version, and we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running, and we'll do sudo docker ps to list all the running containers. And what we see is that the container is not listed there, which means it's probably not running. So let's go ahead and list out all of the images that we have within Docker so we can see whether it's actually listed there. So we'll do ps-a. And yes, there we are. We can see that we do have our new container, MySQL latest, and it was created 36 seconds ago. But it's in the exited mode, so what we have to do is we have to change that status so it's actually running. So let's change that to running state. We'll do sudo docker run dash it dash dash name, and we can name it SL SQL MySQL /bin/bash, and that's now going to be in the root, and we'll exit out of that. And now if we list out the Docker containers, we should see it is now an active container. Sudo docker start, and then we'll start the saying it, and we should now see it. There we are. It's now in the running state. Excellent. And we can see that it was updated 6 seconds ago. We're going to go ahead and we're going to clear the screen. Okay, now what we want to do is remove the Docker container. So what we're going to do is check list of images that we have. And so sudo docker images. Here are the images that we have, and we have MySQL is listed. And what we want to do is delete MySQL. And to do that, we're going to type in sudo docker rm-f image MySQL. Run that command, and what we'll find is the image. There's no such image. Oh, okay. So what we actually have to do is we have to go and see that the image is now gone. It's been removed. Excellent. It's exactly what we wanted to see. And we can also delete an image by its image ID as well. However, if an image is running and active, we have to kill that image first. So we're going to go ahead and we're going to select the image ID. We'll copy that. And it's going to, we paste that. It won't be able to actually run correctly because the image is active. So what we have to do now is stop the image and then we can kill it. So it's in the running state. So we have to do, so we do sudo docker kill and kill SL, and that will kill the container. And now we'll see that the container has gone. And now we can delete the image. And that's going to be the image gone with the image ID. Ba-boom. Easy peasy. Okay, let's go ahead onto the next exercise, which is to, so here we are, we've listed all of the containers and they're all gone. So let's go on to the next exercise, the final exercise, which is to actually create a batch image. And we're going to do a batch HTTP image. So let's go ahead and write that out. So it's going to be docker run dash dit dash dash name white, that's going to be the name of this HTTP service, dash p 8080:80 dash v, open quotes, $pwd, close quotes, colon, slash usr, slash local, slash apache2, slash htdocs, /httpd semicolon 2.4. Run that. Put in our password again. So what we see is the port is already being used. So let's go ahead and see which ports. Let's go see if we can change the port or see what ports are running. So let's do sudo images and see which ports are being used, because it's either the port or the name hasn't been put in correctly. So sudo docker images ps sudo docker ps-a, and yep, there's port 80 there. So we'll clear the screen. So we're going to change the container name, because I think we actually have the wrong container name here. So let's go in and change that, and we'll paste that in, and voila. There we go. Now working, and we'll just double check and make sure everything's working correctly. So to do that, we'll go into our web browser, and we'll type in, as soon as Firefox opens up, type in localhost :8080, which was the port that we created. And there we are. It's a list of all the files which shows that the server is up and running.
And today we'll be looking at the installation for the tool Chef. As you probably already know, Chef is a configuration management tool. So that basically means that Chef is a tool which can automate the entire process of configuring multiple systems. It also comes with a variety of other functionalities which you can check out in our video on what is Chef and the Chef tutorial. So before we move on to the installation process, let me just explain to you in brief the architecture of Chef. So Chef has three components. There's the workstation, which is where the system admin sits, and he or she writes the configuration files here. Your second system is the server. The server is where all these configuration files are stored. And finally, you have the client or the node systems. So these are the systems that require the configuration. You can have any number of clients, but for our demo, to keep it simple, we'll just have one client. Now I'm using my Oracle VM VirtualBox Manager, as you can see here. I'll have two machines, the master and the node. Both of these are CentOS 7 machines. As of the server, we'll be using this as a service on the cloud. So let's begin. Let's have a look at our master system first. This is my master system. The terminal's open over here, and the terminal color here, it's black background with green text. And this is my node system. So the terminal here has a black background with white text. So you can differentiate between the both. So we start at our master system. The first thing we need to do is we need to download the Chef DK. So you can write wget, which is the command for downloading, and then go to your browser and just type Chef DK here. The first link. So here you have different versions of Chef DK. Depending on the operating system that you're using, you need to select the appropriate one. I'm using the Red Hat Enterprise version, and that's number 7. So I'm using CentOS 7. So this is my link for downloading Chef DK. Just copy this link and go back to your terminal and paste it here. So your Chef DK is being downloaded. This will take a while. Right after we download the Chef DK, our next step is to install it on our system. So our Chef DK is downloaded. Now let's install it. So guys, this is the version of Chef DK that you have downloaded. So make sure this is exactly what you type down here too. So great, our Chef DK is installed. So basically our installation for the workstation is done right now. But just so you understand how the flow is, we'll also write a sample recipe on our workstation. So before we do that, let's first create a folder. My folder name is Chef Repo, basically the Chef repository. And let's move into this folder. Okay, so we're in. Next, what we need to do is, as I mentioned earlier, all your recipes will be within a cookbook. So let's create a folder which will hold all our cookbooks. And let's move into this too. Okay, so our next stage is to create the actual cookbook within which we'll have our recipe. So the command for creating the cookbook is chef generate cookbook sample quiz. So sample's the name of my cookbook. So guys, please notice here, cookbooks is the directory that I created, which will hold all our cookbooks. And here cookbook is the keyword. So sample is that one cookbook that we are creating under our folder cookbooks. And our cookbook's being created. Great, so that's done. Moving into our cookbook. Okay, so when our cookbook sample was created, automatically there's this hierarchical structure associated with it. So let's have a look at this hierarchical structure to understand what our cookbook sample exactly is before we move on. So the command for looking at a hierarchical structure is tree. So as you see here, within our cookbook, we have a folder recipes, and under this there's the default.rb recipe. This is where we'll be creating our recipe. So we'll just alter the content of default.rb. So let's move on to finally writing our recipes. So we'll move into this recipes folder first. So now we'll open our recipe default.rb in gedit. So the recipe for this particular demo is to install the HTTPD package on our client node, that is basically your Apache server, and we'll also be hosting a very simple web page. So let's begin. So the recipes in Chef is written in Ruby. So I'll explain you the recipe in a while. Okay, so the first line is where you install HTTPD. The second line for service is where you start or enable the HTTPD service on the client node. That's our first task. The second part's where we need to create our web page. So this is the part where your web page will be stored. If you have written any HTML file previously, you know that this is probably like a default path where our web pages are created. Yep, that's it. So this is the content that will be displayed on your web page if everything works right. And I'm pretty sure it will. So now we can save our recipe, and that's done. Close your gedit. So now that we have created the recipe, all our work at the workstation is completed. The next thing we do is we move on to the server. So as I mentioned earlier, we'll be using the server as a service on the cloud. So go to your browser and here just type manage.chef.io. So this is the homepage of your Chef server. Click here to get started. We need to first create an account for using the Chef server. This is completely free. We just need to give our email ID and a few other details. It's in fact a lot like creating an account on Facebook or Instagram. Fill in all the details. Check the terms of service box. So the next thing you need to do is go back to your inbox and verify your email ID. So I have my inbox opened here on my Windows machine. So this is my inbox. You would have received a mail from Chef Software. Just click on this link to verify it and create your password. And that's done. So let's continue this on our workstation machine. So type in your username and password. So the first time you log into your Chef server, you'll have this pop-up appear where you need to create a new organization. So create your organization. So this organization is basically the name that will be associated with a collection of the client machines. First thing you do, go to your administration tab and download the starter kit. So guys, when you're doing this part, make sure that you're on your workstation. That is, you're opening your Chef server on the workstation, because you need this folder to be installed here. You save the file, so this gets downloaded. So the Chef starter kit is the key to connecting your workstation with the server and the server with the node. So basically it has a tool called Knife, which we'll come across later in our demo. This Knife is what takes care of all the communication and the transferring of cookbooks between the three machines. In our case, the two machines, the workstation and the node, and the one server. So let's go back to our root directory. So our chef starter zip file is within our downloads folder. What we do first is we'll move the zip folder into our cookbooks folder and then we'll unzip it there, because our cookbooks folder is the one that contains the recipe, and that is where we require knife tool command to be present so we can send these recipes over to the server. So we'll just check the contents of our cookbooks right now to ensure that our chef starter.zip file is within the cookbooks. Yep, so it's here. So next thing we do is we need to unzip this folder. Great, so that's unzipped. And this means that our workstation and our server are now linked. So we just need to use the knife command tool to transfer or to upload our recipes, which we created on the workstation, onto the server. So before we execute this command, we need to move into our cookbooks directory. As you know, that is where we unzipped our chef starter kit. So that is where our knife command is present too. And now let's execute the knife command. So it's knife, cookbook, upload, and sample. So as you probably recall, sample is the name of the cookbook that we created. And within sample, we created our recipe, which is default.rb. So we're uploading the entire cookbook onto the server. Execute the command. Great, so our cookbook's uploaded. Now let's check this on our server. So move to your browser where you opened your chef server and go to policy. So here you go. This is the cookbook we uploaded sample, and it's the first time we uploaded it. So the version 0.1.0, the first version. Now what you would notice is if you go to the nodes tab, there are no nodes present. So if you have no nodes, you basically have no machine to execute your cookbooks. And the nodes are not seen right now because we have not configured them yet. So that's the next thing we need to do. All this so far was done on your master machine. Now we'll move on to the node machine. So before moving on, let's just check the IP of our node machine. So that's our IP. Note this down somewhere. And now we move back to our workstation. As we already saw that we uploaded a sample workbook, next thing we need to make sure that our server and node are able to communicate with each other. So again, we use the knife tool for this too. The command here is knife, bootstrap, and enter the IP address of your node, which we just checked. We'll be logging in there. So we'll be using the node as the root user. And then we also need to specify our root password for the node. And we give a name to this node. So this is the name by which we'll be identifying our node at the server. So as you've probably noticed here, we're using the term SSH, which is a secure shell. So it basically provides a channel of secure communication between two machines in an unsafe environment. Okay, so it's done. So if your command has executed right, which in our case, as we can see, has, our chef server and our chef node must be able to communicate with each other. So if this is so, we should be able to send the cookbook that we previously uploaded from our workstation onto the server, now from our server to our node. So to do that, before we move on to the node machine, we need to go back to our chef server. Let's refresh this page. And as you see here, previously under the nodes tab, we did not have any node mentioned. Now we do. Chef node, which is the node we wanted to identify our node by, which is a CentOS platform. And that's our IP. So it's active for 2 hours. That's the uptime. Last check-in, the last time we checked into our node was a minute back. And yeah, that's pretty much it. So now we'll create a run list and we'll add our sample to this run list. So just click on your node and you'll see the small arrow here in the end. Click on that, edit run list, and under available recipes, we have our cookbook sample present. So drag and drop this to the current run list and accept it. Okay, so now that we updated our run list, our recipe is sent to our node. What we next need to do is that we need to execute this at our node. So now we'll move on to our node machine. Chef client is the command to execute your. So while this recipe is executing, you can see what exactly is happening. Our recipe was to install HTTP package first, which is your Apache server. So the first line, that's done and it's up to date. The second line, it's enabled. Third line, the service is started. And the fourth line is where your content's created for the web page at this very location. So by the look of this, everything should work fine. So how do we check this? We can just go to our browser and in the search bar, just type localhost. And there you go. So our HTTPD package, which is the Apache server, is installed and our sample web page is also hosted. Congratulations on completing the Chef demo. Today we'll dive into a tutorial on the configuration management tool Chef. So if you look at the DevOps approach or the DevOps lifecycle, you will see that Chef falls under operations and deployment. So before we begin, let's have a brief look at all that you'll learn today. First, we'll get to know why should we use Chef and what exactly is the Chef. Two of the most common terms used with Chef, configuration management and infrastructure as code. We'll have a brief look at these. We'll also have a look at the components of Chef and the Chef architecture, quickly go through the various flavors of Chef, and finally we'll wrap it up with a demo on the installation of Apache on our nodes. So let's begin, guys. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides n number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy the product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure. But in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Opscode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D, and so on need to be well aware when the change is made, as to why it was made, what was the change made, and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here, the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code, and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something, and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it, and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable, and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And our final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node, and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine, and two nodes. You can have any number of nodes. First things first, The system administrator must create a recipe. So the recipes that are mentioned in our chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have 1 recipe, 2 recipes, 3 recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the OHI service. The OHI service will collect all information regarding the current state of your nodes and send it over to the chef client. When you run the chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is the Hosted Chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these 3 machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using 2 virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have 2 machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. Go to the first link, which is your Chef's official page. A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be showing you how you can install the configuration management tool, Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, A small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using two systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address, 192.168.2.11. Once you have typed in your IP address, give a space, and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML is extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root's called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK, because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible.
Thanks, Anjali. Now we have Matthew and Anjali to take us through how to work with Ansible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam, and like yourselves, Sam is a system administrator, and he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache, they could be database servers running MySQL, And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases, for the simple reason that we're all human, as if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server, and this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have 2 hosts, we have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create 2 different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics, they're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be taking you through a tutorial on Ansible. So Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo, I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to their correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you've gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources, and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often, and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks, and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting 2 virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do, is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these 2 machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. and become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy, because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing, we need to check if the syntax of our YAML file is absolutely right, because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed. As you can see here, gathering facts, that's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go, your Apache server is installed and your web page is hosted. Today I'll be showing you the installation procedure for the configuration management tool Puppet. So what exactly is the use of Puppet? If you consider the scenario of an organization which has a very large infrastructure, it's required that all the systems and servers in this infrastructure is continuously maintained at a desired state. This is where Puppet comes in. Puppet automates this entire procedure, thus reducing the manual work. So before we move on to the demo, let me tell you what the architecture of Puppet looks like. So Puppet has two main components. You have the Puppet Master and the Puppet Client. The Puppet Master is where you write the configuration files and store them, and the Puppet Client are basically those client machines which require the configuration. In case of Puppet, these configuration files that you write are called manifests. So let's move on to the demo. So here are my two machines. The first is the server system, which is basically your master where you'll write your configuration files, and the other is the node or the client system. So let's have a look at both of these machines. This is my node system. The terminal is open here, and the terminal has a black background with white text. And as of my server or the master machine, it has a black background with green text. So we start at our server machine. The first thing that we need to do is we need to remove the firewall. So in a lot of cases, there are chances that the firewall stops the connection between your server and your node. Now, since I'm doing a demo and I'm just showing you how Puppet works between two virtual boxes, I can safely remove the firewall without any worries. But when you're implementing Puppet in an organization or a number of systems on a local network, be careful about the consequences of doing so. So our firewall is disabled. Next thing that we do is we'll change the host name of our server system. Now while using the Puppet tool, it's always advisable that you name your server's host as Puppet. This is because the Puppet tool identifies the host name Puppet by default as the host name for the master or the server system. Let's just check if the host name is changed successfully. Yep, so that's done. So as you see, still localhost is appearing as the host name. So just close your terminal and start it again. And you see here, the host name has been changed to Puppet. Okay, so the next thing that we have to do is we install our Puppet Labs. Make sure your system is connected to the net. Right, so Puppet Labs is installed. Next, we need to install the Puppet server service on our server system. Now that our Puppet server service is installed, we need to move into the system configurations for our Puppet server. So the path for that is etc sysconfig Puppet server. So this is a configuration file for the Puppet server. Now if you come down to this line, now this line here, this is the line which allocates memory for your Puppet server. Now you must remember that Puppet is a very resource extensive tool. So just in case, to ensure that we do not encounter any errors because of out of memory, we will reduce these sizes. So as of now, we have 2 GB allocated by default. We'll change this to 512 MB. Now in a lot of cases, it may work without doing so, but just to be on the safer side, we make this change. Save it and go back to your terminal. We are now ready to start our Puppet server service. The first time you start your Puppet server service, it may take a while. Next, we need to enable this. And if your Puppet server service is started and enabled successfully, this is the output that you would get. In case you're still not sure, you can always check the status at any point of time. And as you see here, it's active. So everything's fine as of now. Next thing we do is we'll move on to our agent system or our client or node system. So here too we'll have to install Puppet Labs, but before we do so, we need to make a small change in our host file. So let's open the host file. Yeah, so this is our host file. We need to add a single line here which specifies our Puppet master. So first we put our Puppet master's IP address followed by the host name, and then we'll add a DNS for our Puppet server. So let's just go back to our server system and find out its IP address. And that's my IP address for the server system. Now the host name of our Puppet server and a DNS for it. Save this file and return to your terminal. So now we can download our Puppet Labs on the Node system. It's the exact same procedure that you followed for downloading Puppet Labs on your server system too. So in my Node system, the Puppet Labs is already downloaded. So the next thing is we need to install our Puppet agent service. So Puppet is a pull type of configuration tool. What this means is that all your configuration files that you'll be writing on your server is pulled by the Node system as and when it requires it. So this is the core functionality of the agent service, which is installed on your client node or agent system. So my Puppet agent service is installed. So next I'll just check if my Puppet server is reachable from this Node system. So 8140 is the port number that the Puppet server must be listening on, and it's connected to Puppet, so that guarantees that your server is reachable from the Node system. So now that everything's configured right, we can start our agent service. So guys, you would have noticed that the command for starting the agent service is a little more complex than the command for starting your server service. This is because when you start your agent service, you're not just starting a service, but you're also creating a certificate. This is the certificate that will be sent over to your master system. Now at the master system, there's something called the certificate authority. This gives the master the rights to sign a certificate if it agrees to share information with that particular node. So let's execute this command, which does both the function of sending the certificate and starting your agent service. So as you can see here, our service is started successfully. It's in a running state. Now we'll move to our master system or the server system. So first we'll have a look at the certificates that we received. The certificate should be in this location. So as you can see here, this is the certificate that we just received from our agent service. So this here within quotes is the name of our certificate. So next, when we are signing the certificate, this is the name we'll provide to specify that this is the particular certificate that we want to sign. So the minute we sign a certificate, the node that sends the certificate gets a notification that the master has accepted your request. So after this, we can begin sharing our manifest files. Now here's the command for signing this certificate. Okay, so our certificate is signed, which means that the node's request is approved, and the minute the certificate is signed, the request is removed from this list. So now if we execute the same command as we did to check the list of all the certificates, we will not find this certificate anymore. Let's just check that. So as you see, now there are no more requests pending because we have accepted all the requests. If you want to have a look at all the certificates that is signed or unsigned, you can use the same command with the addition of all. And all the certificates received so far will be listed. As you can see here, the plus sign indicates that the certificate request has already been accepted. So now that our certificate is signed, the next thing we do is we'll create a sample manifest file. So this is the path that you create your manifest files in. Our file name is sample.pp and our file is created. So right now we have no content in this file. We'll just check if the agent is receiving it, and once that's confirmed, we'll add some content to the file. So let's move to our agent system. Now this is the command to execute at the agent system to pull your configuration files. So our catalog is applied in 0.02 seconds. So now that the communication between our agent system and our master system is working perfectly fine, let's add some content to the previous placeholder file that we created on our master system. So now we open the same file in an editor. Okay, so we are going to write a code for installing the HTTPD package on our node system, which is basically a Apache service. Node, and then within quotes, insert the host name of your node system. So my node system's host name is client. The package you wish to install, which in our case is HTTPD, and the action to be performed. And that's it, a very small and simple code. Save this file. Now let's go back to our node system and let's pull this second version of the same configuration file. So every time you execute this command, as we did previously too, what happens is that the agent service basically checks on your master system if there's any new configuration file added or if there's any change to the previous configuration file made. If so, then the catalog is applied once again. So now our catalog's applied in 1.55 seconds. So now to check if our catalog served its purpose, let's just open our browser. Just type localhost here. And as you can see, if your HTTPD package has been successfully installed, the Apache testing page will appear here.
So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that would be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest templates and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client that is used and communicated back to through the agent. So let's step through the workings of Puppet. So the Puppet environment is a master-slave architecture. The clients themselves are distributed across your network and they are constantly communicating back to a master server environment where you have your Puppet modules. The client agent sends a certificate with the ID of that server back to the master. And then the master will then sign that certificate and send it back to the client. And this authentication allows for a secure and verifiable communication between client and master. The factor then collects the state of the client and sends that to the master. Based on the facts sent back, the master then compiles manifests into the catalogs, and those catalogs are sent back to the clients, and an agent on the client will then initiate the catalog. A report is generated by the client that describes any changes that have been made and sends that back to the master, with the goal here of ensuring that the master has full understanding of the hardware running software in your network. This process is repeated at regular intervals, ensuring all client systems are up to date. So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are: 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or SaltStack? All 4 are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStack. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find is a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from a beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. The more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. The way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all 4 tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network. And there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural in that they actually specify at how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all 4 tools are very secure in their communication. So who wins? Well, here's the reality. All 4 tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is.
Monitoring, as the term says, you're monitoring, you're watching, you're logging your production environment. So of course, there are a whole bunch of monitoring tools, so they become an important part of your production environment. And a lot of these monitoring tools are also, I've seen them also being used, especially in your UAT environment. And you can optionally have them for some time, even in your, development environment. No, not development, because development servers are usually not very high-end configurations, but maybe a decent development / integration server, especially if you have long-running scripts and if you have programs that use a lot of servers, maybe CPU or processing power. So then you can have monitoring tools when you're writing such scripts and you're doing the unit testing for those scripts, so that to see what kind of server utilization happens when you run this script. If you'll put this in production, will it actually slow down your production server, and what kind of impact that will have on the your rest of your application or other applications running on that server. But this particular chapter is more in context with production environment. So these tools, they basically monitor your server, they monitor your switches, of course they monitor your applications and any services that you have deployed on your servers. And they generate alerts when something goes wrong. And that's the whole job of monitoring. It is continuously watching, continuously looking at what is running, what is happening, what is going up, what is going down, when is CPU peaking, when is memory peaking, and all that. So that you typically send limits for these all these different parameters, and anytime any of these parameters goes outside of that limit, even more than that or less than that, these monitoring tools usually send out an alert, and these alerts could again be SMS alerts or email alerts, and there are usually people monitoring these monitoring tools to look out for any issues reported. And they also generate alerts when the problem has been resolved. So they work both ways. So Nagios is an open source monitoring tool, and it can even monitor your network services. There's a little diagram here, which is too small, but here is Nagios somewhere, what I can read. And status. So these are different devices I think. No. Yeah, these are different devices to which Nagios is sending the status. There's a browser, there's an SMS, there's an email, and then there's a graph also. And these are different objects that Nagios is basically monitoring. This is an SMTP server. I can read SMTP. This is, I don't know, TCP/IP? No, I don't know, some database server. Okay, this is a database server, and this is an application server. This is a switch router. Okay, I can read that now. So these are the different kind of objects. These are different kind of servers that Nagios monitors, and these are the different kind of devices or statuses that it can send. So it helps monitor your CPU usage, your disk usage, and even your system logs. And it uses a plugin script that can be written, in any scripting language actually. If you ask me. The Nagios remote plugin executors are basically agents that allow remote scripts to be executed as well, and these scripts are usually executed to monitor, again, your CPU disk usage, number of users logged in, who's logged in at what time, logged out at what time, and all these things. So all these monitoring tools work on the concept of polling. So polling is more like, so the NRP agent is a program that will continuously keep polling a machine for certain parameters that are configured in Nagios to be monitored. So this program continuously keeps pinging the server, bringing the program, to keep checking for what it has been asked to check. So in case of logged in users, you keep checking at a, like maybe every 30 seconds or every 1 minute, you keep pinging to see how many users have logged in onto this server and who are the users who have logged in, what time they logged in, what time they logged out, and things like that. So Nagios poll agents on remote machines. This is what basically it means. Nagios has agent programs that can help you poll or ping even remote machines. The Nagios remote data processor is an agent that allows flexible data transports, and it uses HTTP and XML protocols to do that. And we're talking about essentially your databases and data server usages, like within, if you have an Oracle database, how many database instances are there, how your load balancing is set up on that, how data is moving between different database servers within Oracle, and how data is moving within the load balancers, and there's always a DRP, there's always a backup with database. So that's why you see me mention DRP as soon as I say the word database. And if there's a backup plan, how's the data moving? How much time did the backup take? Did it take too much time? And why did it take? So it helps you do all those kind of monitoring. The NS client is basically mainly used to monitor Windows machines, and typically when we talk about servers, we end up talking more about Unix or Linux servers. Of course, now with a lot of Microsoft technologies being robust than they were, like SharePoint or things like that. There are Windows servers too, but 10 years ago, if you would talk about having a Windows server, it was actually kind of frowned upon, especially for production. And again, this helps you monitor your CPU, your disk usage, and it pulls the plugin. And this particular agent listens to this particular port always. So that's a reserved port. And usually your system administrators or server administrators know all these things.
Today, let's get started with Jenkins. Jenkins, in my opinion, is one of the most popular continuous integration servers of recent times. What began as a hobby project by a developer working for Sun Microsystems way back in early or mid 2000s has gradually and eventually evolved into very powerful and robust automation servers. It has a wide adoption since it is released under MIT license and is almost free to use. Jenkins has a vast developer community that supports it by writing all kinds of plugins. Plugins is the heart and soul of Jenkins because using plugins, one can connect Jenkins to anything and everything under the sun. With that introduction, let's get into what all will be covered as a part of this tutorial. I will get into some of the prerequisites required for installing Jenkins, post which I will go ahead and install Jenkins on a Windows box. There are a few first-time configurations that needs to be done, and I will be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part. I'll create few users and I will use some plugins for setting up various kinds of access permissions for these users. I will also put in some freestyle jobs. Freestyle job is nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon a time schedule. I will also connect Jenkins with GitHub. GitHub is our source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box and run few commands to build this particular repository that is pulled from GitHub. Sending out emails is a very important configurations of Jenkins or any other continuous integration server for that matter. Whenever there is any notifications that has to be sent out as a part of either a build going bad or build being good or build being propagated to some environment, and all these scenarios, you would need the continuous integration servers to be sending out notifications. So I will get into a little bit details of how to configure Jenkins for sending out emails. I will also get into a scenario where I would have a web application, a Maven based Java web application, which will be pulled from a GitHub repository, and I will deploy it onto a Tomcat server. The Tomcat server will be locally running on my system. Eventually, I will get into one other very important topic, which is the master slave configuration. It's a very important and pretty interesting topic where distributed builds is achieved using a master slave configuration. So I will bring up a slave, I will connect the slave with the master, and I will also put in a job and kind of delegate that particular job to the slave configuration. Finally, I will let you know how to use some plugins to back up your Jenkins. So Jenkins has got a lot of useful information set up on it in terms of the build environments, in terms of workspace. All this can be very easily backed up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins. And I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this WAR file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain 2 servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. Alright, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very, very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. Alright, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using these environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system, but in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables, all right, so I've just set in a Java home variable. If you see this, C: program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C: program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that, or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path, and if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. You also have a Docker container wherein you can launch Jenkins as a container, but I'll not get into details of that in this tutorial. All right, so what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier. And this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded. So let me just open that up. All right. So this is my downloaded Jenkins instance, or rather installer. This is maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C: program files 86 and Jenkins folder. If at all you run a war file, depending upon the user ID with which you're running a war file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right, so this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C:" program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right, so there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a war file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it will crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins as a part of the installation would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password. Something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it. But once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all Jenkins configuration. So I'll get into some of those important ones. something called as configure system. Configure system, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors, 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I have provided my email ID and my password. I'm using the SMTP port, which is 465, and reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right. So no other configurations that I'm going to change here. All of these look good. All right. So I come back to manage Jenkins. Okay. One other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be a separate server without anything being installed on it. So in case I want Jenkins to run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item, little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very, very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very, very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I have not run it yet. All right. So let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. all the plugins that is installed. The details of each of those plugins can be found here. All right. So the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right. So one job, one quick run. That's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins. Which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into manage Jenkins and manage plugin. A little bit of a confusing screen in my opinion. There's updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some roles for this particular Jenkins instance. So I would say first manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete, I don't want, read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure. Manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer1 sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user who I've created and then assign him to that particular role. So if you remember, the user that I created was developer1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube, and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very, very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very, very simple, repository that is there called Hello Java. And this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very, very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now, because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember, in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code, and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins, and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good. But what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub, and then on my behalf, pull out a repository. All right. If at all at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here you would see a red message saying that something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub, and then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this, and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository, and it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello, and there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, Git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it, and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN Web App. It's a Maven based repository. As we would know, Maven is a very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a war file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need two other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is a Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I've configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide these user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using these credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job. MVN web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credentials that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so MVN package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this, and let me first run this and see if it connects well, if there's any problem with my war file, or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file, and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I would go to manage plugins, available, type in container, container, deploy to container. Okay, so this would is the plugin that I would need. I would install it without a restart. Right, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application war file that is already built. So I would need to configure this plugin to pull up this war file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the war file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the war file that is there. So *****war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say MVN web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployed credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the war file that is found in this particular folder, and then context path is mn web app. Use the deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the war file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was mvn web app. So if I type in this, right, if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server, which is running on a different port, which is 8081. Now for this demo, I'm running everything locally on my system, but assuming that, this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the war file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and Maven. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he'll do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac, you support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers, or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave. But since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. my Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP, Java Network Launch Protocol. So using this, I would ensure that the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes, agents, and by default, this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol. And I'll configure the master and server to talk to each other using JNLP. So for that, I need to enable this guy. So I enable this guy instead of making by default, the configuration was disabled. So I make him random. I make him, enabled, and I say save this configuration. All right. So now I configured, or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to your Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I'll just give an identifier saying that Windows node. I would say this is a permanent agent. I would say, okay. So if you see the name, let me just copy this name here with the description. Number of executors, since it's a slave node and both of these are running on my system, I will keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this, since I have both my master is running on my C drive program files 86, or hang on, not 86, C:\program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like, you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that. And I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we're going to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node, and from there I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad plus is good for me. Okay, I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system and then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar, agent.jar, JNLP. This is the URL of my server. In case the server and client are on different locations or different IPs, let us specify the IP address. All this anyway would show up. And then the secret and the root folder of your Jenkins or the slave node. Okay. So something ran and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials or the slave.jar along with the launch code and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegated to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent.
DevOps is a collaborative approach just taken up by most companies these days. It focuses on scaling up and making the entire process of scaling up much smoother. So, no doubt companies are actively looking out for DevOps engineers. Welcome to another tutorial with Simplilearn. I'm Lance, and today we'll be looking at how you can become a DevOps engineer. So, let's begin. So, by definition, DevOps is a collaboration between the development and the operations team, which enables continuous delivery of application and services to the end users. So, let's expand on this definition. First, the development team is the one that actually produces the products. The operations team is related with the management or the maintenance of these products. Now, there's a link that DevOps forms between these two teams, which makes this entire process much smoother. And this approach, this collaborative approach, is what's called DevOps. So DevOps focuses on continuous delivery of application, which means that when the development team is ready with the product, it immediately goes into the maintenance or the management phase, and it's then pushed on to the end users with minimum delay. Now, just in case you doubt the stand of DevOps today or its growth in the near future, you must know that according to the Information Week, DevOps will be in high demand for upcoming years and has no chance of slowing down. Also, according to LinkedIn, over the past few years, DevOps has increased in demand by 50%. Now, that's quite a lot of growth, so clearly DevOps is a field that will be great to dive into and grow in. So, before we begin how you can actually become a DevOps engineer, let's look at what we'll be going through in this video. First, we look at who is a DevOps engineer, followed by the DevOps career roadmap. We'll then look into a DevOps certification, and then finally the salary trends for a DevOps engineer. So, who is a DevOps engineer? Now, a DevOps engineer is an IT professional who understands the software development lifecycle. And when I say software development lifecycle, I did not just mean the DevOps approach, but right from a waterfall model, which is a traditional software development lifecycle. And then, as you know, we moved on to the Agile, and then we finally reached the DevOps lifecycle. So a DevOps engineer needs to understand the whole purpose of this lifecycle, why we had to move from one model to the other, what are the shortcomings that the previous models had, and what all does DevOps make up for? Also, other than understanding this entire process, they also need to know how to use the various automation tools for developing the continuous integration and continuous deployment pipelines. So, of course, your next question must be, what is the continuous integration and continuous deployment pipeline? Well, as you can see on your right, we have an image of this pipeline. So there are various stages. So first you have your planning stage where you plan things out and write an algorithm for your product. Then it's the building stage where the algorithm actually transforms into a code and is a product which could be used. Then you have the testing stage. In the testing stage, your product is tested, all the bugs are caught, and all of this is corrected. And once all of that's done, it's then sent to the deployment stage, which means now your product is ready to be deployed. Once it's deployed, of course, a product needs continuous monitoring. And this is now something new which has been introduced into the DevOps lifecycle, that although your product is out in D now, the monitoring stage is something that the DevOps approach focuses on much more than our previous models, and for very good reason, which is that once your product is deployed into the real world, to ensure customer satisfaction, it's important that you continuously monitor the product. This way you're able to catch the bugs, fix them, and push it back to the clients and ensure that they are happy with your product and would go for it again. Now, in simple words, a DevOps engineer is expected to collaborate with the developers and the operations team to deliver high-quality products within a minimum amount of time. Now, DevOps engineer as such is not a profile that you might come across very often. But of course, there are a number of career paths that you can undertake under the DevOps engineer. But of course, there are a number of career paths under a DevOps engineer. Now, some of these are the DevOps architect, automation engineer, software tester, integration specialist, security engineer, and release manager. Now let's look at the DevOps career roadmap. So basically, if you are looking forward to bagging that DevOps engineer job, where should you start and how should you go about it? Well, first things first, there are a few programming languages which go hand in hand with the DevOps tools. You need to pick up these and also know the Linux fundamentals. DevOps uses these programming languages for developing and automating software. Now, the three most common languages used with the DevOps tools are Ruby, Python, and JavaScript. It is always advised that you know at least one of these, and of course we must consider the fact that these three languages are used with completely different tools, so knowing just one of these languages does not mean that you can now work with any tool under the DevOps approach. But it does give you a good hang of at least one of them, which is more than most can say. It's also important to know the fundamentals of the Linux command line interface. Of course, this is not very unique to DevOps. Whichever career path you are choosing, Linux fundamentals is one of the most important things. Now, let's discuss some of the mandatory Linux skills that a DevOps engineer should be aware of. First is, of course, the Linux shell. Now, you must either know Bash or the kernel shell. Then it's the Linux commands. Now, there are a huge number of Linux commands, but the basic ones you must know, no matter what, are the find, grep, awk, and the set command. And finally, we have the networking commands nslookup, which is for querying the DNS, and netstat for monitoring your connections. Our next milestone would be learning the source code management. Now, source code management is especially important when you're dealing with huge projects so that all your code, irrespective of the number of files you have or the number of versions of a particular code you have, everything is organized and can be easily accessible. So it's important that you're comfortable with at least one of the source code management tools here. The most common ones we see are Git, CVS, and Mercurial. I would personally recommend you to choose Git. And why Git? Because Git is used to track changes in the source code. It can manage large projects efficiently, and it allows multiple developers to work together with great ease. Now, our next stage is to learn to build applications. So, a DevOps engineer must know how to build an application and commit to the source code management tools such as Git. Now, a popular tool used to build applications, which makes things much simpler, is Maven. Why Maven? Well, it supports parallel builds, instant access to new features without any additional configuration, and has an easy build process. Now, Maven is actually an automation tool which helps to build and manage software projects within a short period of time. So here you have the BOM file, which is required to build an application, under which you have a set of jars. You have the commands which are to be executed, the builds plugins, and the builds profile. But in order to automate the entire process, you require a continuous integration or a continuous development tool. And this brings us to our fourth stage, which is learning to automate the process using CI and CD tools. One of the most extensively used tools in this field is Jenkins. Jenkins is an open source continuous integration tool. It helps to automate continuous development testing and deployment of newly created codes. Well, why Jenkins? Well, because it has multiple plugins, it is easily distributed across multiple machines, and has an easy installation and configuration process. Our next stage is to learn to test the applications. Once you have completed the build process, learn how to automate the testing process of web applications. One of the best testing tools for QA teams is Selenium. And why Selenium above all the other tools that provide the same functionality? Well, because it provides fast execution, allows scripting in several languages, and also supports parallel test execution. The next thing is to learn to deploy applications in production servers. So you should learn how to deploy and run the applications in the production servers. And in order to deploy an application, you should have the knowledge of containers, such as Docker, and configuration management tools like Ansible. So Docker helps with the containerization, while configuration management tools such as Ansible helps provide you the capability of pushing configurations onto multiple servers and maintaining them in the required state. So why choose Docker? Well, high scalability and efficiency, reusable data volumes, isolated applications. And why Ansible? Because unlike other tools in this field, it has a push-based configuration. It is agentless and uses SSH for secure connections. The next stage is to learn to monitor the applications. So monitoring your applications is another important aspect of a DevOps engineer. In this stage, we identify the issue and implement the changes as quickly as possible. The most popular tool, which provides for monitoring applications, is Nagios. It has a comprehensive monitoring system, high availability, and immediate remediation. And finally, a DevOps engineer must know the working of cloud providers. For a DevOps engineer, it's important to know about the cloud service providers and their basics. Cloud computing is an important skill to learn, irrespective of which field you're in today. As a lot of companies have the infrastructure on the cloud, Amazon Web Services is the most popular cloud provider, whereas Microsoft Azure and Google Cloud Platform are slowly catching up to Amazon. Amazon Web Services provides high scalability and flexibility, is cost-effective, and provides better security. Let's now look at some of the DevOps certifications you can opt for. The first one is the AWS Certified DevOps Engineer Program, which is offered by Amazon Web Services. And then, of course, we have the DevOps certification training offered by our very own Simplilearn. Simplilearn also provides programs which are more specific to tools such as Chef, Puppet, Ansible, and Selenium certification. And we also provide a DevOps Architect Master's program. So now these are some of the most popular certifications available in the market. If you're taking up a career, you must know what kind of salary to expect. An average salary of a DevOps engineer in the United States is $115,666 per year. So this is the average salary. As you can see here, guys, there's a graph which shows how there's been a growth, and this graph here will give you a good idea of the salary trend. An average salary of a DevOps engineer in India, on the other hand, is 6,12,000 per year. So again, here we have a graph on the right which demonstrates the pattern in growth in the salary. Now, here's some additional material to prepare yourself and help you in the journey to becoming a DevOps engineer. So this is Simplilearn's YouTube playlist on DevOps. As you can see here are a number of videos you can start off with. This fun short video on what is DevOps. It introduces DevOps to you in the most basic and fun way possible. And then you have DevOps tutorial for beginners. What is DevOps? Another tutorial introduction to DevOps. And then you can follow this up with the tutorials on the various tools under DevOps. For example, there's Git, there's Jenkins, Docker, Docker Swarm, Ansible Chef, Puppet, a comparison between the various configuration management tools. And there are also DevOps interview questions, part 1 and part 2, which will help you prepare for your interviews. Now, why DevOps is better than Agile, or if it's the other way around. Watch this video to find out how to create your resume for the post of a DevOps engineer, and so on. So there are a lot of videos here, guys. You can definitely go through them, and it provides you with a lot of information. Not only that, before you actually take up the Simplilearn course to get a better understanding of the kind of content and the quality of content that they offer, you can come back here and check out their free courses or their free tutorial videos. And with that, we come to an end of this video. I hope you all enjoyed it, and I hope it was really helpful for all those who are aspiring to become a DevOps engineer. Please hit the like button if so. Also share our video and subscribe to our channel if you haven't yet, because we have a lot more coming up for you. So thank you all, and see you all next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.
So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins, and this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master-slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. We want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be, or one dirty way to do that would be just, take a complete backup of our program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available. And let me search for some backup. There are a bunch of backup plugins. So I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my Manage Plugins. So this plugin is there. So hang on, Backup Manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to back up some data, and I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut on my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the Maven artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps and all the files that is required as a part of this is pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of backup, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all the workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or it's a hard disk failure and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I will say restore Hudson or Jenkins configuration.
So DevOps today is being implemented by most of the major organizations, whether it's a financial organization, whether it's a kind of a service organization. Every organization is somehow looking forward for the implementation and the adaptation of DevOps, because it totally redefines and automate the whole development process altogether, and whatever the manual efforts you were putting earlier, that is simply or gets automated with the help of these tools here. So this is something which get really implemented because of some of the important feature like a CI/CD pipeline, because CI/CD pipeline is responsible for delivering your source code into the production environment in less duration of time. So CI/CD pipeline is ultimately the goal, which really helps us to deliver more into the production environment when we talk about from this perspective. Now let's talk about that. What exactly is a CI/CD pipeline? Now, when we go into that part, when we go into that understanding, so CI/CD pipeline is basically continuous integration and continuous delivery concept, which is used or which is considered as a backbone of the overall DevOps approach. Now, it's one of the prime approach which we implement when we are going for a DevOps implementation for our project. So if I have to go for a DevOps implementation, the very first and the minimum implementation and the automation which I'm looking forward is actually from the particular CI/CD pipelines here. So CI/CD pipelines is really a wonderful option when we talk about the DevOps here. So what exactly is the pipeline term all about? So pipeline is a series of events that are connected together with each other. It's kind of a sequence of the various steps, like typically when we talk about any kind of deployment, so we have like build process, like we compile the source code, we generate the artifacts, we do the testing, and then we deploy to a specific environment. All these various steps which we used to do it like manually, that is something which we can do it into a pipeline. So pipeline is nothing but a sequence of all these steps interconnected with each other, executed one by one into a particular sequence. Now, the pipelines is responsible for performing a variety of tasks like building up the source code, running the test cases. Probably the deployment can also be added up when we go for the continuous integration and continuous delivery there. So all these steps are being done into a sequence, definitely, because sequence is very important when we talk about the pipeline. So you need to talk about the sequence the same way in which you are working on the development, and in a typical world, the same thing you will be putting up into a specific pipeline. So that's a very important aspect to be considered. Now let's talk about what is the continuous integration here. Now continuous integration is also known as the CI. Pretty much you can see that a lot of tools are actually named as CI, but they are referring to the continuous integration only. So continuous integration is a practice that integrates the source code into a shared repository, and it used to automate the verification of the source code. So it involves the build automations, test cases automation. So it also helps us to detect the issues and the bugs quite easily and quite faster. That's a very early mechanism which we can do as such if we want to resolve all these problems. Now continuous integrations does not eliminate the bugs, but yes, it definitely helps them easily to find out, because we are talking about the automated process, we are talking about the automated test cases. So definitely that is something which can help us to find out the bugs and then the development can help on that, and they can proceed with those bugs, and they can try to resolve those things one by one. So it's not a kind of automated process which will eventually remove the bugs is something which you have to recode and you have to fix it by following the development practice. But yes, it can really help us to find those bugs quite easy and help them to remove. Now, what is the continuous delivery here? So continuous delivery, also known as CD, is in kind of a phase in which the changes are made into the code before the deployment. Now, in this case, what happens that it's something which we are discussing, or we are validating that what exactly we want to deliver it to the customer. So what exactly we are going ahead, or we are moving to the customer. So that's what we typically do in case of continuous delivery. And the ultimate goal of the pipeline is to make the deployments. That's the end result, because coding is not the only thing. You code the programs, you do the development. After that, it's all about the deployments, like how you're going to perform the deployment. So that is a very important aspect. You want to go ahead with the deployments, that's right, you can go there. And that's a real beauty about this, because it's in kind of a way in which we can identify that how the deployments can be done or can be executed as such here. Right. So the ultimate goal for the pipeline is nothing but to do the deployments and to proceed further on that. Right. So when both these practices are placed in together in an order, so all the steps could be referred as a complete automated process, and this process is known as CI/CD. So when we are talking about, like, when we are working on this automation, so in that case, what happens that we are looking forward that how the automation needs to be done. And since it's in kind of a CI/CD automation which we are talking about, so it's nothing but the end result would be like build and deployment automation. So you will be taking care of both the build and the test case executions and the deployments as such when we talk about as such the CI/CD here. The implementation of CI/CD also enables the team to do the build and deploys quite quickly and efficiently, because these are things which is happening automatically, so there is no manual efforts involved, and there is no scope of human error also. So we have frequently seen that while doing the deployments we may miss some binaries or some miss can be there. So that is something which is completely removed as such when we talk about this. The process makes the teams more agile, productive, and the confident here, because the automations definitely gives a kind of a boost to the confidence that yes, things are going to work perfectly fine and there is no issues as such present. Now, why exactly Jenkins? Like, Jenkins is what we typically understand, or we here and there, that it's an CI tool, it's a CD tool. So what exactly is Jenkins all about? So Jenkins is also known as a kind of orchestration tool. It's an automated tool which is there, and the best part is that it's completely open source. Yes, there are some particular paid or the enterprise tools are there, like CloudBees and all, but there is no as such offering difference between the CloudBees and the Jenkins here. So Jenkins is a kind of open source tool which a lot of organizations pretty much implement as it is itself. So even if they don't want to go, we have seen in a lot of big organizations where they are not going for the enterprise tool like CloudBees and all, and they are going for the pretty much core Jenkins software as such here. So this tool makes it easy for the developers to integrate the changes to the project. That is something which is very important, because it can really help the teams to say that how the things can be done and how it can be performed over there. So the tools is very easy for the developers to integrate, and that's the biggest benefit which we are getting when we talk about these tools as such. So Jenkins is a very important tool to be considered when we talk about all these automations. Now, Jenkins achieves continuous integration with the help of plugins. That is also a kind of another feature or benefit which we get, because there are so many plugins which is available there as such, which is being used. And for example, you want to have an integration with Kubernetes, Docker and all. Maybe by default those plugins are not installed, but yes, you have the provisioning that you can go for the installation of those plugins, and yes, those features will start embedded up and integrated within your Jenkins. So this is the reason, this is the main benefit which we get when we talk about the Jenkins implementation. So Jenkins is one of the best fit which is there for building a CI/CD pipeline, because of its flexibility, open source nature, plugin capabilities, the support for plugins, and it's quite easy to use, and it's very simple, straightforward GUI which is there, which can definitely helps us. You can easily understand and go through the Jenkins, and you can grab the understanding, and as an end result you will be able to have a very robust tool which using which pretty much any kind of source code or any kind of programming language you can implement CI/CD. whether it's an Android, it's a .NET, it's a Java, it's a Node.js, all the languages are having the support for the Jenkins. So let's talk about the CI/CD pipeline with the Jenkins here. Now, to automate the entire development process, a CI/CD pipeline is the ultimate, solution which we are looking forward. To build such a pipeline, Jenkins is our best solution and best fit, which is available here. So there are pretty much 6 steps which is involved when we look forward for any kind of pipeline. It's a generic pipeline which we are looking forward. Now it may have like another steps which is available there, probably some additional steps you're doing, like some other plugins you are installing, but these are the basic steps which is there, like a minimum pipeline if you want to design. These are the steps which is available there. Now let's see. The first one is that we have to require a Java JDK, like a JDK to be available on the system. Now most of the operating systems are already available with a GRE, like a Java GRE. But the problem with GRE is that it's only for the build process. It will not be doing the compilation. You can run the artifacts, you can run the jar files, you can run the application, run the code base, but the compilation requires the Java C or the Java JDK kit to be installed onto the system. And that's the reason why for this one we also require the JDK. And certain Linux commands execution understanding we need to have, because we are going to run some kind of steps, some installation steps and process. So that's pretty much required. Now let's talk about how to CI/CD pipeline with Jenkins. Now first of all, you have to download the JDK, and that is something which is installed. So after that you can go for the Jenkins download. Now jenkins.io/download is the official websites of Jenkins. Now the best part is that there you have the support for different operating systems and platforms. From there you can easily say that if you want to go for a Java package like a WAR file, Docker, Ubuntu, Debian, CentOS, Fedora, Red Hat, Windows, OpenSUSE, FreeBSD, Ganto, Mac operating system. In fact, whatever the different kind of artifacts or different environment or different application you want to download, you will be able to do that. So that's the very first thing to start upon. You download the generic Java package like a WAR file. Then you have to execute it. You have to download that into a specific folder structure. Let's say that you have created a folder called Jenkins. Now you have to go into that Jenkins folder with the help of cd command, and there you have to run the command called java-jar and the jenkins.var there. So these are the executables artifacts. So WAR files can be easily executable. Jar files, WAR files can be easily deployed. So just because with the Java command you can run them, you don't require any kind of web container or application container as such. So here also you can see that we are running the Java command and it runs the applications as such. And once that is done, so you can open the web browser, and you can open like localhost colon 880. So Jenkins uses the 880 port just like a Tomcat Apache. So if once the deployment is done, installation is done, so you can just open the localhost colon 880. Now if you want to get the Jenkins up and running in the browser, probably you can go through the public IP address also there. So you can put the public IP address colon 880, and that can also help you to start accessing the Jenkins application. Now in there you will be having an option called create new jobs, so you need to click on that. Now once the particular new job, new item, new job, that's a different naming conventions which is available there. Now all you are going to do is that you're going to do like you are proceeding with creating the pipeline job. So you will be having an option called pipeline job over there. Just select that and provide your custom name, what pipeline name or job name you want to refer or you want to process there. Now once that is available, so what happens that it will be an easy task for us to see that how exactly we can go ahead and we can perform on that part. So this can really help us to see that how a pipeline job can be created and performed on these modifications as such. Now when the pipeline is selected, and we can give a particular name, that this is the name which is available, and then we can say okay as such over there. Now you can scroll down and find the pipeline section. So there what happens that when you go over there and say that okay, this is the way that how the pipelines are managed and those kind of things. So you will scroll down and find the pipeline section and go with that pipeline script. Now when you select that option, there are different options which is available, like how you want to manage these pipelines. Now you are have the direct access also, like if you want to directly create a pipeline script, you can do that. If you feel that you want to manage, like you want to retrieve the Jenkins files, also a code management tool also can be used there, so you can work on that also. So like this, there are so many a variety of things which is available like which you can use to work around that how exactly the pipeline job can be created. So either you can fetch it from the source code management tool, like Git version or something like that, or you can directly put the pipeline code as such over there, right? Now, so next thing is that we can configure and execute a pipeline job with the direct script. So we can, once the pipeline is selected, so you can put the particular script like Jenkins file into your particular GitHub link. So you may be having like already a GitHub link, so that where the Jenkins file is there, so you can make use of that. Now once you process the GitHub link, so what we can do is that we can proceed with that, and once the processing is done, so you can do the save, and you can keep the changes, and it will be picking up the pipelines. The pipeline script is added up into the GitHub, and you have already specified that let's just go ahead with this Jenkins file pipeline script from the GitHub repository and proceed further. Now once that is done, so what next you can do is that you can go with the build now process. You click on the build now, and once that is done, so what will happen that you will be able to see that how the build process will be done and how the build will be performed over there. So these are pretty much a kind of a way. So you can click on the console output, you will get all the logs that is happening inside that. Whatever the pipeline steps are getting executed, all of them you will be able to get, or you will be able to get on that part there. So these are the different steps which is involved as such. And the sixth one is that yes, whatever the particular when you run the build now, you will be able to see that source code will be will be checked out and will be downloaded before the build, and you can proceed with that part. Now later on, if you want to change the URL of this GitHub, you can configure the job again, the existing job, and you can change that URL, GitHub link URL, whenever you require. You can also clone this job whenever you go ahead and you work on that, and that's also kind of the best part which is available as such, right? And then you can have the advanced settings over there. So in there you can put like your GitHub repository. You can say like, okay, the GitHub repository is there, so I'm just going to put this URL, and with that, what will happen that the settings will be available there, and the Jenkins file will be downloaded as such. And when you run the build now, you will be able to have a lot of steps, like a lot of configurations going on. So then the checkout SCM, so we can have a declaration like checkout SCM which is there. So when the checkout SCM is there, so it will check out a specific source code. After that, you go to the log, and you will be able to see that each and every stage which is being built up and executed as such. Okay, so now we are going to talk about a demo here. So on the pipeline here, so this is the Jenkins portal. Now you can see here that there is an option called create a job. You can either click on the new item, or you can click on the new job, create a job here. Now here I'm going to say like a pipeline, and then you can select the pipeline job type here. Now you have the freestyle pipeline, GitHub organization, multi-branch pipeline. These are the different options which is available there, but I'm going to continue with the pipeline here as such. So when I selected the pipeline and say okay, so what will happen that I will be able to see a configuration page which is related to the pipeline. Now here the very important part is that you have all the general build trigger options which is similar to the freestyle, but the build step and the post build step is completely removed because of the pipeline introduction. Now here you either have the option to put the pipeline script all together. You can also have some particular example. For example, let's talk about some GitHub Maven particular tool here. So you can see that we have got some steps as such over here, and it's pretty much running over there. Now you run it, it will work smoothly, it will check out some source code. But how we are going to integrate like the Jenkins file into the version control system, because that's the ideal approach we should be following when we create a pipeline of a CI/CD. Now I'm going to select a particular pipeline from SCM here, then go with the Git here. Now in there, the Jenkins file is the name of the file of the pipeline script, and I'm going to put my repository over here in this one. Now this repository is of my Git, which is like having a Maven build pipeline which is available there. It's having some steps related to CI for the build and deployments, and that's what we can follow as such over here. Now in this one, the if it is a private repository, definitely you can add on your credentials, but this is a public repository, a personal repository, so I don't have to put any kind of credentials. But you can always add the credentials with the help of add here, and that can help you to set up whatever the credentials, private repositories you want to configure. Now once you save the configuration here, Now what it's going to do is that it's going to give you a particular page related to build now. If you want to run, if you want to delete the pipeline, if you want to reconfigure the pipeline, all these different options are available there. So we are going to click on the build now here, and when I do that, immediately the pipeline will be downloaded and will be processed. Now you may not be able to get the complete stage view as of now because it's still running. So yeah, you can see that the checkout code is done, then it's going on to the build. Okay, that's one of the steps which is there. Now once the build will be done, so it will continue with the next steps, with the next further steps there. So you can also go to the console output log here, like you can click on this, or you can click on the console output to check the complete log which is happening there. Or in fact, you can also see the stage wise logs also, because that is also very important. When you go for the complete logs, it may have a lot of steps involved, and a lot of logs will be available there. But if you want to see a specific log of a specific stage, that's where this comes into the picture. And as you can see that all the different steps like test cases executions, the sonar cube analysis, the archive artifacts, deployment, and in fact the notification, so all this is a part of a complete pipeline. This whole pipeline is done here, and you get a kind of a stage view, its success over here, and the artifacts is also available to download. So you can download this WAR file is a web applications as such over here. So this is what a typical pipeline looks like, that how the automation, the complete automations really looks like as such over here. Now this is a very important aspect because it really helps us to understand that how the pipelines can be configured, can be done, and pretty much with the same steps you will be able to automate any kind of pipelines as such. So that was the demo to build a simple pipeline as such with the Jenkins, and pretty much in this one we understood that how exactly the CI/CD pipelines can be configured, and we can use them, and we can get hold on that part.
So there are approximately 7 sections that we cover in DevOps. We go from general DevOps questions, source code management with tools such as Git, continuous integration, and here we'll focus on Jenkins, continuous testing with tools such as Selenium, and then you also have the operations side of DevOps, which is your configuration management with tools such as Chef, Puppet, and Ansible, containerization with Docker, and then continuous monitoring with tools such as Nagios. So let's just get into those general DevOps questions. So one of the questions that you're going to be asked is, how is DevOps different from Agile? And the reality is that DevOps is a cultural way of being able to deliver solutions that's different from Agile. If we look at the evolution of delivery over the last 5 to 10 years, we've gone from waterfall based delivery to Agile delivery, which is on sprints, to where we are with continuous integration and continuous delivery around DevOps. The whole concept of DevOps is culturally very, very different from Agile. And the difference is that you're looking at being able to do continuous releases. What does that mean? The difference is that you want to be able to send out code continuously to your production environment. That means the operations team, the development team have to be working together. That means that any code that gets created has to be able to go to production very quickly, which means you need to be testing your code continuously, and then that production environment must also be able to be tested continuously, and any changes or any errors that come up have to be communicated effectively and efficiently back to the dev and op team. Another area in which I see that DevOps is different is really the response that we have for how we engage with the customer. So the customer is coming to your website, to your mobile app, to your chatbot, or any digital solution that you have, and has an expectation. When you're going through and actually doing a DevOps paradigm, the old model would be that you would capture requirements from the customer, then you do your development, then you do your testing, and there would be these barriers between each of those. As we move faster through from waterfall to Agile, what we saw is that with Agile, we were able to respond much faster to customer demands. So instead of it being weeks or months, sometimes in some cases years between releases of software, what we saw was a transition to
to weeks and months for releases on software. Now we see with DevOps is that the release cycle has shrunk even further with the goal of continuously delighting the customer. How further has that release cycle shrunk to? There are companies that have gone from having releases of once a week or once every 2 weeks or once a month to now having multiple releases a day. Indeed, some companies have up to 50 releases a day. This isn't something to also bear in mind is that each of those releases are tested and verified against test records so that you can guarantee that the code that's going to production is going to be good continuous code. So what are the differences between the different phases of DevOps? So effectively, there are two main phases of DevOps. There's the planning and coding phase, and then there's the deploying phase. And you have a tool such as Jenkins that allows you to integrate between both environments. Some of the core benefits that you may have to DevOps are going to be some technical benefits and some business benefits. So when somebody asks you what are the benefits of DevOps, you can reply that from a technical point of view, you're able to use continuous software delivery to constantly push out code that has been tested and verified against scripts that have been written and approved. You can be able to push out smaller chunks of code so that when you have an issue, you're not having to go through massive blocks of code or massive projects. You're going through just very small microservices or small sections of code, and you're able to detect and correct problems faster. On the business side, the benefits are absolutely fantastic. From a customer that's coming to your website or to your mobile app, they're going to see responses happening continuously so that the customer is always aware that you as a company are listening to their demands and responding appropriately. You're able to provide a more stable environment, and you're able to scale that environment to the demands of the number of customers that are using your services. So how will you approach a project that needs to implement DevOps? So this is really an exciting area for you to be in. So there are effectively 3 stages when it comes to actually working in a DevOps. The first stage is an assessment stage, and think of this as the back of the napkin ideation stage. This is where you are sitting with a business leader and they're giving you ideas of what they would like to see from feedback that they've had from their customers. This is blue sky opportunity. This is thinking of big ideas. That second stage, and this often comes as a fast follow to stage 1, is actually proving out that concept. So developing a proof of concept. And a proof of concept can actually be multiple different things. So it could be something as simple as a wireframe, or it could be something that is as complex as a mini version of the final application. Depending on the scope of the work that you're delivering will really depend on how complicated you want the POC to be. But with that in mind, whatever choice you make, you have to be able to deliver enough in the POC so that when you present this to a customer, they're able to respond to that creation that you've developed and able to give you feedback to be able to validate that you are going with the right solution and able to provide the right product to your customers. That third stage is where you get into your DevOps stage, and this is just the exciting part. This is where the rubber hits the road and you start releasing code based on a backlog of features that are being requested for the solution. In contrast to doing agile delivery where you just continuously work through a backlog, with DevOps, what you're also looking at is putting in analytics and sensors to be able to validate that you are being successful with the solution that's being delivered. So that once you actually start delivering out code that customers can interact with, you want to be able to see what are the pieces of the solution that they are using, what do they like, what is complicated, where are the failure points, and you want to use that data and feed that back into your continuous integration and have that as a means to be able to backfill the demand of work that gets completed in the backlog. So what is the difference between continuous delivery and continuous deployment? So continuous delivery is based on putting out code that can be deployed safely to production. It ensures that your businesses and functions are running as you would expect them to be. So it's going through and
completing the code that you'd actually see. Continuous deployment, in contrast, is all about ensuring that you're automating the deployment of a production environment. So you're able to go through and scale up your environment to meet the demands of both the solution and the customer. This makes software development and release processes much more faster and more robust. So if we look here, we can actually see where continuous integration and continuous deployment come hand in hand. So when you actually start out with the initial pushes of your code, that's where you're doing your continuous integration and your continuous delivery. And then at some point, you want to get very comfortable with deploying the code that you're creating so that it's being pushed out to your production environment. One of the things that's great about working with the tools that you use in a DevOps continuous integration and continuous delivery model is that the development tools that you use, the containerization tools, the testing tools, should always reflect the production environment. And what this means is that when you actually come to deploying solutions to production, there are no surprises because your development team have been working against that exact same environment all the way through. So a question that you'll also be asked is, what is the role of a configuration management in DevOps? And so the role of configuration management really has three distinct areas. The first, and this is really the obvious one, and this is the one where you probably already have significant experiences, is the ability to manage and handle large changes to multiple systems in seconds rather than days, hours, or weeks, as may have happened before. The second area is that you want to also demonstrate the business reasons for having configuration management. And the business reason here is that it allows IT and infrastructure to standardize on resource configurations. And this has a benefit in that you're able to do more with fewer people. So instead of having a large configuration team, you can actually have a smaller, more highly skilled team that's able to actually manage an even larger operational environment. And thirdly, you want to be able to highlight the ability to scale. So if you have configuration management tools, you're able to manage a significant number of servers and domains that may have multiple servers in. It allows you to effectively manage servers that are deployed on cloud or private cloud and allow you to do this with high accuracy. So how does continuous monitoring help in maintain the entire architecture of the system? So when this question comes up, you want to dig in and show your knowledge on how configuration and continuous monitoring is able to control an entire environment. So the number one topic that you want to bring up when it comes to continuous monitoring is that with being able to effectively monitor your entire network 24/7 for any changes as they happen, you're able to identify and report those faults or threats immediately and respond immediately for your entire network instead of having to wait, as it happens sometimes, for a customer to email or call you and say, hey, your website's down. Nobody wants that. That's an embarrassing thing. The other three areas that you want to be able to highlight are the ability to be able to ensure that the right software and the right services are running on the right resources. That's your number one takeaway that you want to be able to give of continuous monitoring. The second is to be able to monitor the status of those servers continuously. This is not requiring manually monitoring, but having an agent that's monitoring those servers continuously. And then the third is that by scripting out and continuously monitoring your entire environment, you're creating a self-audit trail that you can take back and demonstrate the effectiveness of the operations environment that you are providing. So one of the cloud companies that is a strong advocate for DevOps is Amazon's Web Services, AWS, and they have really 5 distinct areas that you can zero in on for services. So when the question comes up, what is the role of AWS in DevOps? You want to really hold out your hand and list off 5 areas of focus using your thumb and finger. So you want to have flexible services, built for scale, automation, secure, and a large partner ecosystem. And having those 5 areas will really be able to help demonstrate why you believe that AWS and other cloud providers, but AWS is certainly the leader in this space, are great for being able to provide support for the role of DevOps. So one of the things that we want to be able to do effectively when we're releasing any kind of solution is to be able to measure that solution. And so KPIs are very important. So you will be asked for 3 important DevOps KPIs. And so 3 that really come to mind that are very effective. The first one is mean time to failure recovery. And what this talks about is what is the average time does it take to recover from a failure? And if you have experience doing this, then look at the experience that you have and use a specific example where you are able to demonstrate that mean time to failure recovery. The second is deployment frequency. And with deployment frequency, you want to be able to discuss how often do you actually deploy solutions and what actually happens when you're actually doing those deployments, and what does the impact to your network look like when you're doing those deployments. And then the third one is really tied to that deployment frequency, which is around what is the percentage of failed deployments. So how many times did you deploy to a server and something happened where the server itself failed? What we're looking for when you're going through and being asked for these KPIs is experience with actually doing a DevOps deployment and being able to understand what DevOps looks like when you're pushing out your infrastructure. And then the second is being able to validate that self-auditing ability. And one word of caution is don't go in there and say that you have 100% success. The reality is that servers do degrade over time. And you maybe want to talk about a time when a server did degrade in your environment and use that as a story for how you were able to successfully get over and solve that degradation. So one of the terms that is very popular at the moment is infrastructure as code. And so you're going to be asked to explain infrastructure as code. And really, it's something that actually becomes a byproduct of the work you have to do when you're actually putting together your DevOps environment. And infrastructure as code really refers to the writing of code to actually manage your environment. And you can go through many of the other tools that we've covered in this series, but you'll see that XML or Ruby or YAML are used as languages to describe the configuration for your environment. This allows you to then create the rules and instructions that can be read by the machines that are actually setting up the physical hardware versus a traditional model, which is having software and installing that software directly onto the machine. This is really important when it comes to cloud computing. There really is a strong emphasis of being able to explain infrastructure as a service, and infrastructure as code is fundamental to the foundation to infrastructure as service. And then finally, it allows you to be able to talk about how you can use scripted languages such as YAML to be able to create a consistent experience for your entire network. All right, so let's now get into the next section, which is source code management. And we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application, and if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model actually we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal, because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have 4 options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as GitLab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way, using git init, allows you to create a working directory using the command git init. And then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, using the bare way, you have a different commands for setting that up. So it would be git init --bare, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are 2 ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 56DE0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are 2 ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you want to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is what is a Git stash. So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that, and that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git and how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in, and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially four stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. That will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved, and then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. You will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into to GitHub. And this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with the command line you want to use git bash. And so you want to, as a first step, open up git bash and then navigate to the local git repository in command line using the cd change directory, and then list out the actual folder where you actually are putting all of your code. And then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor, but actually go through and edit out what you want to keep and what you want to manage in your conflict. So you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository. All right, let's talk about the next section, which is continuous integration with Jenkins. So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository, such as GitHub, and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for three distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline, and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as their domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. A question you'll be asked as well is, how can you copy Jenkins from one server to another? Well, there are three ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. There are three ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the three responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins Home Plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom build plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled, allowing you to make your administrative changes, and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled or run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent on each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build an environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart. So let's go into the 4th and final section of this first video, which talks about continuous testing with Selenium. So the first question you will be asked most likely around Selenium are, what are the 4 different Selenium components? And again, you will want to hold open your fingers because there are 4 distinct environments. You have Selenium Integrated Development Environment, or Selenium IDE. You have Selenium Remote Control, or Selenium RC. You have Selenium WebDriver, and then Selenium Grid. You'll be asked to explain each of those areas in more detail, but let's start off by looking at Selenium Driver. What are the different exceptions in Selenium WebDriver? So it's useful to remember that an exception is an event that occurs during the execution of a program that disrupts the normal flow of that program's instructions. And so we have 4. We have a timeout exception, an element not visible exception, no such element exception, and a session not found exception. And each of those, if we step through them, are the 4 different types of exceptions that can be thrown up when using the Selenium WebDriver. So as we evolve in our digital world with the different types of products that are available for us to be able to build solutions onto multiple platforms, you're going to be asked, can Selenium and other DevOps tools run in other environments? And so a good question around this is, can Selenium test an application in an Android web browser? And the short answer is absolutely yes, it can. But you have to use the Android driver for it to be able to work. So you want to be able to talk about the 3 different types of supported test within Selenium. So when the question comes up, what are the different test types supported by Selenium, you can answer it. And there are 3 different types of tests. First is a functional test. Second is a regression test, and third is a load testing test. The functional test is a kind of black box testing in which test cases are based on a specific area or feature within the software. A regression test helps you find any specific areas that functional tests or non-functional areas of the code wouldn't be able to detect. The load testing test allows you to monitor the response of a solution as you increase the volume of hits in how you're using the code are put onto it. An additional question you'll be asked is, how can you get a text of a web element using Selenium? Well, the get command is used to retrieve text of a specific web element. It's important to remember, however, that the command does not return any parameters, but just returns a string value. So you want to be able to capture that string value and discuss about it. A question you'll be asked around Selenium is, can you handle keyboard and mouse actions using Selenium? And the answer is yes, you can, but you have to make sure that you're using the Advanced User Interaction API. And the Advanced User Interaction API is something that can be scripted into your tests, and it allows you for capturing methods such as a click and hold and drag and drop mouse events, and then keyboard down or keyboard up key release events, so that if you want to capture, say, the use of Control Shift or a specific function button off the keyboard, you'd be able to capture those. Of the following 4 elements, which of these elements is not a web element method? A, get text. B, size. C, get tag name. D, send keys. And it's B, size. You're going to be asked to explain what is the difference for when we use find element or find elements. And so if we look at find element finds the first element in the current web page that matches the specified locator value. In contrast, find element finds all of the elements on the web page that matches the specified value. When using WebDriver, what are the driver close and driver quit commands? And these are 2 different methods used to close a web browser session in Selenium. So driver close will close the current web browser on which your focus is set, and driver quit closes all the browser windows and ends the WebDriver session completely. The final question that you are likely to be asked in using Selenium is, how can you submit a form using Selenium? Well, in this instance, that's relatively easy. The following lines of code will let you submit a form in Selenium, which would be web element el equals driver.findElement, and then you put in the ID and the element ID, and then l submit, open close parentheses, semicolon. So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable HTTP.service, system disable HTTPD, or the final option, which is systemctl disable HTTPD.service. Your answer should be the first one, which is hashtag systemctl disable HTTP.service. So Chef comes with a series of tools that allow it to function effectively. And one of the tools that you're going to be asked about is what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do what is the command to sign a requested certificate, the top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the three options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the three tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are four. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables.
And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture. So let's get on to our next section, which is containerization. So let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker does contain and occupy, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms. And then finally, for space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution path that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes.
Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you're going to be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is you want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked how to create a Docker container. So let's go through what that would look, and we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, for the registry, we have Docker registry is an open source server-side service used for hosting and distributing Docker images. Whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry, and it has two tabs, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace, but you could add in there IBM, Bluemix. Could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker?
So if we go through, expose is an instruction used in Docker file, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these are expose 8080, or with Docker, we would put in, or for publish, we would do the example Docker run -d-p and then 0.0.0.80 as our command line. So let's look at continuous monitoring. So with continuous monitoring, how does Nagios help in continuous monitoring of systems, applications, and servers? And so this is really just a high-level question of using Nagios within your environment. And you should be able to just come back very quickly and say, Nagios allows you to help manage the servers and check if they're being sufficiently utilized and if there are any task failures that need to be addressed. And so there are 3 areas of utilization and risk that you want to be able to manage. This is being able to verify the status and services of the entire network, the health of your infrastructure as a whole, and if applications are working properly together with web services and APIs that are reachable. So the second question you'll be asked is, how does Nagios help in continuous monitoring of systems, applications, and services? So it's able to do this by having the initial Nagios process and scheduler and the additional plugins that you would use for your network connect with the remote resources and the Nagios web interface to be able to run status checks on a predefined schedule. So what do you mean by Nagios Remote Plugin Executor, or the MPRE of Nagios? So MPRE allows you to execute plugins on Linux Unix machines that allow you to do additional monitoring and machine metrics such as disk usage, CPU load, etc. What are the ports used by Nagios for monitoring purposes? In this example, there are 3, and they're easy to remember, so I would memorize these 3, but they're essentially ports 5666, 5667, and 5668. So there are 2 types of checks within Nagios. So you will be asked for what is an active and passive check in Nagios. So an active check is initiated by the Nagios process and is run on a regular schedule. A passive check is initiated and performed by an external application or process. So this may be where a system is failing. And results are submitted to Nagios for processing. And to continue with this, for what is an active and passive check, active checks are initiated by the check logic within the Nagios daemon. Nagios will execute a plugin and pass information about what needs to be checked. Plugin will then check the operational state of the host or service and then process the results of the host or service check and send out notifications. In contrast with the passive check, it is an external application that initiates the check. It writes the results of the check to an external command line file. Nagios reads the external command file and places the results of all passive checks in a queue for later processing, so you can go back and revalidate. And then Nagios may send out notifications, log alerts, etc., depending on the results that they get from checking the information. So you're going to be asked to explain the main configuration file and its location in Nagios. So the main configuration file consists of a number of directives that affect how Nagios operates. So consider this as the configuration file that's read by both Nagios processor and the CGIs. So this will allow you to be able to manage the main configuration file that's placed into your settings directory. So what is the Nagios Network Analyzer? And again, hold out your 4 fingers because there are 4 options here. So the Nagios Network Analyzer 1 provides an in-depth look at all your network traffic, source, and security threats. 2 allows system admins to gather high-level information on the health of your network. 3 provides a central view of your network traffic and bandwidth data. And then 4 allows you to be proactive in resolving outages, abnormal behavior, and threats before they affect critical business processes. So what are the benefits of HTTP and SSL certificate monitoring with Nagios? So with HTTP certificate monitoring, it allows you to have increased server and services and application availability, obviously very important. fast detection of network outages and protocol failures, and allows web transaction and web service performance monitoring. The SSL certificate monitoring allows you for increased website availability, frequent application availability, and provides increased security. So explain virtualization with Nagios. So in response to this, the first thing you should be able to talk about is how Nagios itself can run on many different virtualization platforms, including Microsoft Visual PC, VMware, Xen, Amazon EC2, etc., etc. So just make sure you get that right off the bat. Nagios was able to provide capabilities to monitor an assortment of metrics on different platforms. It allows for quick detection of service and application failures, and has the ability to be able to monitor against many metrics, including CPU usage, memory, networking, and VM status. So name the 3 variables that affect recursion inheritance in Nagios, and it is name, use, and register. So name is a template name that can be referenced in other object definitions. Use specifies the name of the template object that you want to inherit its properties and variables from. And register indicates whether or not the object definition should be registered to Nagios. And on the right hand side of the screen, we have an example of what that script would look like. Again, you may want to be able to memorize this, as it's something that you can actually write down and show someone if you're going through a technical interview. So why is Nagios said to be object-oriented? And fundamentally it comes down to the object configuration format that you can use in your object definitions. It allows you to inherit properties from other object definitions, and this is typical of object-oriented development and is now applied for the Nagios environment. So some of the objects that you can inherit are services, hosts, commands, and time periods. So finally, explain what is state stalking in Nagios. And so there are really 4 options here when you're talking about state stalking. So state stalking is used for logging purposes in Nagios. It allows you to enable for a particular host or service that Nagios will watch over very carefully. It will log any changes it sees in the output of the check results. And then finally helps the analysis of log files.
And so with this, we have reached to the end of our DevOps full course. We hope that you guys found it informative and helpful. Do like and share it. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.